I'd like to welcome everybody to the second day of the 41st Annual AMSAT Space Symposium. We had a great night last night at the social and auction, and I'm still trying to recover from those. But let's see on the schedule today. Yesterday was engineering. This morning starts off educational aspects, and then we have a collection of various important topics to go after that, followed by at 3 o'clock we have the AMSAT member general meeting. So at this time I'm going to turn over to, are you going to introduce, or?
I am indeed, yes, that's right. Hi, good morning. Again, I'm Zach Metzinger, N0ZGO. I'll be your MC for today. And first up, we have a presentation by the VP of Educational Resources, Alan Johnson here, and he is going to talk to us about CubeSatSim update and demonstration. So off to you, Alan.
Okay, thanks, Zach. So can everybody hear me okay? It sounds good. Okay, all right, excellent. So good morning, everybody. It's a pleasure to be back here in Dallas. I used to come to Dallas a lot. Years and years ago, I worked for WorldCom before they merged with MCI. And so I used to spend a lot of time in Richardson in the telecom corridor there. So anyway, it's good to be back. So today I'm going to give you an update on some things that have been going on with AMSAT in our education program, and specifically about our CubeSat simulator that I have some of them here. And I'll show off some of the new features, including a live demo, which I'm sure will fail. But let's give it a try here, see how we go. So I'm going to start off by mentioning the team that's been working on this, because I stand up here and give presentations, but there's a whole lot of people working on this, and without them we wouldn't be where we are today. I'll introduce the CubeSat simulator. How many of you have not heard me speak about this before? I see some. Okay, good, excellent. All right, very good. Some of you might have heard me at Hamvention or other symposiums as well. So we'll talk a bit about what we use it for, what its purpose is, and then we'll talk about basically what we've done with it in the past 12 months. So we'll talk about it in the classroom, at events, articles that have been written about it by my team and others. Then we'll do a demo here, and then give you information about how to get involved in the project. So this is the team. All these different people have been involved. So thank you. Anyone here in the audience on the team? I don't believe so. Oh, Chris. Where's Chris? There you are, Chris. Ah, okay. Thank you, Chris. Chris has supported us with changes to Fox to LAM, basically spacecraft for the CubeSat simulator for that. So thank you, Chris. So what is a CubeSat simulator, or CubeSatSim as we call it for short? It's the sort of centerpiece of our educational outreach. And the idea is that satellites are cool, but they're way up there in space, and you can't see them, and they only fly over for 10 minutes twice a day. And so that makes them a little bit hard when you're trying to explain to students or do demonstrations. So having something that you can have in your hand and you can pass around. Also, it's designed to be low cost, so that if a student drops it and it smashes, it's no big deal. We wouldn't normally pass around flight hardware that's going to be shipped to the integrator next month. So it's a good way to do the hands-on. And so we use it in schools. We use it. It's used in a number of universities and STEM programs, and we're also trying to get it into sort of non-conventional places like maker fairs, libraries, museums, and things like that. Just so people know, ham radio is still there, and we're doing cool, interesting things with space. So the CubeSat simulator, it's basically a fully functional model of a nanosatellite, a CubeSat, the standard. For nanosatellites these days, and you're going to hear from Bob Twiggs, who's one of the co-inventors of the CubeSat standard at this event. I'm excited to meet him in person. And it's basically fully functional. It runs on rechargeable batteries. It's got working solar panels. It transmits real radio signals in the 70 centimeter band. And it transmits them in real format. So you use the same software you would use to receive telemetry and decode telemetry and receive images is what you use with the CubeSat simulator. So you can also treat it like a trainer, basically. You can train and get all your software working and then just switch to an outside antenna and you can receive telemetry and images from real satellites as they fly over. So this is what it looks like inside, and I have it here. It's a 3-board stack. It includes a Raspberry Pi Pico microcontroller. It also includes a Raspberry Pi Zero as well. And it has a number of sensors too, and I'll talk about some of those. And this slide here shows the excellent FoxTelem software, which is what AMSAT uses for our CubeSats that are on orbit. And many of you might run FoxTelem in your station, and you might upload the telemetry data you get into AMSAT servers so that AMSAT engineering can see what's going on with our CubeSats. So this is one way that we get telemetry out of the CubeSat simulator. You can look at voltages and currents and temperatures and things like that and see them happen in real time. So the CubeSat simulator has been around for a few years. I've been working on it myself for a couple of years, and we have a version, the current version is version 1.2, and quite a few of those have been built. We're working on a new beta, bless you, a new beta hardware and software, and we've been working on it for the past 18 months. It's been a little tricky. Part of it was motivated by supply chain issues. It's very difficult. The CubeSat simulator is basically a kit. We don't currently sell fully assembled units, so we provide a bill of materials, and keeping that bill of materials up to date so that people can actually buy the parts on there is just, frankly, it's just been a nightmare the past year and a half. It's so difficult. And so we've tried to redesign to make the parts easier to find. And also make the bill of materials a little easier as well. And also updating some of the technology like the Raspberry Pi Pico microcontroller. And along the way, we've also added a couple of features, but it's not a big upgrade. It's really just sort of future-proofing the hardware, basically. And you can tell the difference between the two. On the left there, the whiteboards, that's the current version. That's the released production version, version 1.2. Our new boards, we're going with this cool blue. So that way I'll always be able to tell, so I won't be confused when my first question for support is going to be, what color are your boards? Because that will tell me right away what's going on. So I'll just go through a couple of changes because some of you might be familiar. I think some of you have definitely built CubeSat simulators. I know Chris did and Dennis did. Anyone else in the audience build one before? Oh, okay, excellent. Oh, terrific. Wow. Okay, very good. So you'll be pleased to know that there's actually a path to upgrade your existing CubeSat simulator. You won't get all the features of the new hardware, but you will get many of them. Basically, you can build a new STEM payload board and then replace your existing STEM payload board, which is the top board on the stack, with this new one, and you'll get many of the features. And what are those features? So we replaced the SparkFun Pro Micro microcontroller with the Raspberry Pi Pico. Anybody used a Pico before? Played with that? It's kind of cool. It's really nice to program. You just drag a UFT file on into a flash drive, and it just programs the whole thing. It's great. You can also program it in Python, which students in schools really like Python much more than C. I don't know why. But anyway, it's quite popular. So that's something good for the future. Also, it has Wi-Fi. It's the Pico W. So in the future, we're going to do things with Wi-Fi as well with it. Also, it has this little board chip thing here. This is a FM transceiver module on there. We had some issues with FM on the original board with frequency offsets. And also we had issues where as soon as we put this thing out there, people immediately started to misuse it, which is always good, right? That means they're experimenting. And the one thing that kept coming up is, can we fly this on a balloon? Well, first was, can we send this to space? And it's like, no, don't do that. Okay, this is designed to be ultra low cost and easy to build, and it's not designed to survive in space. But the second, not quite as unreasonable, was, can we fly it as a payload on a balloon? And so some of us tried it. I tried it twice, and it wasn't a good experience. The power level was too low. There were frequency offsets that caused issues. So like your APRS beacon would be off by 5 kilohertz, and all the digipeters wouldn't receive it. Oops, things like that. So now we have an FM transceiver board on there, and for the simulator, we just we attenuate it down to 10 milliwatts. Because generally our ground station, like my ground station is that Pi 4 over there, we don't want to blow it up with our transmitter sitting right next to it. So we really attenuate it. But if you remove the attenuator circuit, you can get a half a watt, 500 milliwatts out of this. And we successfully flew that on one of our balloons back in May. We did slow scan TV and APRS live in flight. And it worked really well. So in the future, the answer is going to be yes, you can fly it as a balloon payload. Some of the other details. Oh, there is a new frame. So if any of you have printed the old frame before, we do have a slight update. The frame is 3D printed plastic, which students like to. It's a lot of fun printing it, watching it come in. We have a better bill of materials now. I'll show you that while we're doing some demos here. And also, there is a surface mount assembly option. How many of you have done surface mount soldering before? Oh, okay, lots of you. How many of you like surface mount soldering? Not me. Okay. It's good if you have good eyesight and a steady hand, which is good for youngsters. Some of my students, you give them the thing, and it's done in like 2 minutes. They're really quick at it. So my students actually this past spring did a surface mount assembly, and it worked well. Ran it through the reflow oven, and that was good. But also we're going to use that next year, hopefully, to make fully assembled boards. So we'll be able to we'll still call it a kit because you'll have to stack the boards yourself and put it all together. But it'll basically be a no soldering kit, and I think that's going to be a good thing for the future. Because right now, when people are like, oh, I want one, here's a check, and we're like, okay, here's a board and here's a bill of materials. That might be good for us, right? But it's not necessarily good for the average STEM outreach person. So, okay. So a little bit of details on the board, and then we'll get into some other things. So this is the STEM payload board, which is the one that I'm holding here. And besides the Pico, it's also got 2 sensors. It's got this purple BME 280, which is a pressure, altitude, temperature, what's the final thing? Pressure, humidity sensor, which is fun because you can make it do things. You can put it outside and see the temperature change. And it's also got a 3-axis gyro and accelerometer there, which is fun. This is what we call the solar board. What it really is, it provides all the circuitry to run the solar panels. So it's got diodes to prevent backfeeding, and it's got these blue boards here are INA 219 boards, actually made by Texas Instruments. They're a really nice little chip, and it gives us current and voltage sensors for every solar panel and the battery, so we can look at this in real time, which is fun. And one of the fun things that we do, I don't have the demo here, but we use a little turntable, like for spinning cakes or objects or things. And if you put it in front of a lamp, or if you just put it in sunlight, as it spins around, you can see the currents and voltages spike on the solar panels. And that's exactly the kind of telemetry you get from real CubeSats, right? Because they're always spinning in space, and one side faces the sun, and so you can determine, axis of rotation and rotation rate and things like that, which is fun. And one of the things in our new design is we're using these smaller solar panels, so we're using 2 on each side, and these solar panels are easier to source. Before Before you had to locate them on AliExpress or eBay, places like that, unless you wanted to pay an arm and a leg, which for me is like $10 a solar panel. These are about $1.50 each, which is what we need to keep the costs down here. So I have a battery board. One of the most common questions I get is, why do you use nickel metal hydride batteries? You know, why don't you use lithium, right? They're much more powerful. Well, some of my, actually I didn't have anything this semester. Previous semester, students were soldering the board with the batteries in, and they bridged the positive and negative with solder. Okay? Now imagine that with lithium batteries. Okay, you'd be calling the fire department, you'd be explaining to the dean what happened to the lab. With this, all that happened was the trace glowed red like a toaster. Something to see. And fortunately, I was standing right there, and so I just grabbed the soldering iron and I unbridged it. And those batteries actually kept working. So nickel metal hydride batteries, they're very, very safe for students to work with. It's very hard to do anything to destroy them or to destroy your lab or your hands or something like that too. So anyway, so nickel metal hydride, not the latest battery technology, but they're cheap and they're very, very safe. And they also allow us to have a very simple charging circuit. In the past, we had a charging circuit that used a chip. I've been concerned about those boards becoming unavailable in the future. So now we actually just charge it directly, because nickel metal hydride batteries, they're really tolerant to what you do to them. So that's allowed us to simplify things, reduce costs. And you can charge them using the solar panels in sunlight. Indoors, you'll never get enough current out of the solar panels unless you use. In the past, I've done demos with like work lights. You know, there's like 250 watt halogen work lights. Those you can get power out of a solar panel. You also need to not melt the frame. So you need to keep it spinning if you're going to use those. And don't let anybody touch the grill because they're hot. But if you just put an LED light, which is cold and safe, in front of it, you can see a little voltage spike and a little current spike. But if you really want to charge it, you need sunlight or you need a high power warm lamp like halogen. And in addition, you can charge it from a USB-C cable. So generally that's what I do. I just charge it overnight before I do a demo like today, and then it's good to operate for a while. So there's a couple options for the ground station. As I said, it generates real telemetry. So you can, for example, use an SDR application and decode it, and then you can run whatever software you might run, whether it's Direwolf or QSSTV or MMSSTV on Windows, Sound Modem. You know, if you decode satellite telemetry, you might already have the software there. If not, you can install it. An easier solution is to do basically a ground station in a box where you can load up, we have all the software pre-installed on a Raspberry Pi SD card. So this is it over here. Basically, it's just a Pi 4. A Pi 3B Plus works. It's a little bit iffy for everything, but a Pi 4 is good. And then an RTL SDR, which is our radio piece of it. And you don't need much of an antenna. I always like showing my students how a paperclip works as an antenna. It kind of freaks them out. They're like, really? That works? Sure. It's a conductor. And the nice thing is that if you just put this SD card and boot up the Pi, it turns on like a radio, and it's got all the software you need, and you just switch. I'll be showing it a little later. So these are the 5 different modes. We'll hear most of the modes today during my demo, if all goes well, which I'm sure it won't. So a little bit about the telemetry. So I'm an electrical engineer myself, and telemetry is an interesting thing. And basically, the CubeSat simulator sends what we call housekeeping telemetry. So just the basic health of the satellite itself. So temperature, voltages, currents, the battery, you know, what's going on with charging, what's going on with battery draw. You can tell a lot about the health of a satellite. looking at the housekeeping telemetry. And then in addition, if you add sensors, and with the STEM payload board, you mix in additional information as well. So those are like your experiments. Those are like your payloads that your CubeSat is taking. And the nice thing is that you can program those using, basically using the Arduino IDE development system. So we use the Raspberry Pi Pico, but you can just program it using the Arduino IDE. So it's very simple for adding new sensors. And we've also just added, I don't know if you can see, but there's this little red board here. So it's a SparkFun Quick connector. So if you buy I2C sensors, a lot of them will have this quick connector on them, and you can basically wire them up without soldering. So you just have a little quick jumper cable, you plug it in here, you plug it into your sensor, and then you just need to update the software on your Pico, and you've added a new sensor to it. So that's kind of exciting. And in addition to the real telemetry that the CubeSat simulator will do, it also has the ability to generate simulated telemetry as well. It's a mode you put it into, and it generates pseudo-realistic things with it basically calculates a rotation rate and an angle of rotation, and whether it's in eclipse or illumination, and chooses a period. It actually chooses a very short orbital period. You don't want a real orbital period. It's like 5 minutes kind of thing for the attention span. And then you run it, and it will generate pseudo-realistic telemetry, which is good for doing demos and the like. Because not everywhere can you set it up with a turntable and a lamp and all that. And each time, all the parameters are randomly chosen. So every time you reboot it, it'll be different. And when it comes up, you don't know, is it an illumination? Is it an eclipse? Is the battery discharging? Is it charging? And so you can look at the telemetry and do it. So it's kind of fun. Okay, so I'll talk a little bit about what we've done with the CubeSat simulator the past 12 months. Things got pretty slow in education during the COVID time, as you could imagine, but things are ramping up. And actually right now, well, I just got one of them back, but I had 4 of our Lunar units were shipped out. And this was the first time in a couple of years that 4 of them were out at the same time. Recently, they've only been borrowed every couple of months kind of thing. But we have been using them in the classroom at the Thomas Jefferson High School for Science and Technology in Alexandria. They actually built quite a few of them and used them in the classroom. They've been used at the University of Colorado Springs in some aerospace engineering classes. They developed some labs with them where students had to answer questions and do things with them. And I myself, I've used them in this past spring in my freshman projects class. So this is like the first electrical engineering class that they do. And we don't really teach them a whole bunch. We just kind of want to get their feet wet. And so we give them the instructions, we give them a pile of parts, we give them a soldering iron, teach them which is the hot end and which is the cold end, and then we say go for it. So, and the kids actually enjoy it. One of the fun things is when they contact me like a year or two later and they're like, what did we do in that class again? Did we build a satellite and put it into space? They have this vague recollection of what they did, and then they're like, did we actually build a satellite? I'm like, oh, almost. But anyway, it's a good class. And building, for those of you who have built them, building a CubeSat simulator, it's pretty fun. It's about 10 hours of soldering and 3D printing and other things. So at events, the CubeSat simulator's been at a few things. Dennis here took it to Hamcation. Thank you, Dennis, for doing that. And I participated in the QSO Today Academy twice this year. I showed it off there with their online event. And we also had it at Hamvention, and again, Dennis helped staff the table, along with Karsten Glassbrenner. Drew's son, who did an awesome job. He was, we have our, this is our Fox engineering model here. That's always a big hit, that Hamvention, and he was putting it in the hands of every kid that walked by, and he just did a great job. Okay, good, good. And he's hopefully going to be building one too. So maybe next year he'll say, "I built this one." We'll see. Oh yes, yeah, and then Tom in the back there. Thank you, Tom. He's taken it to a event here, Frontiers of Flight Moon Day. Looks like a great event. I've seen the pictures. The latest pictures, if you go to the pictures and the overall picture, you can see a banner in there, and it says "Keep Amateur Radio in Space." So, yeah. Yes. Excellent. Excellent. Yeah, he's saying that Virginia Smith built one and showed it off to a local Dallas ham club here. Yeah, I was hoping to meet her on this trip. Last year she also wrote an article in the AMSAT Journal about her experience, and she's recorded videos. Yeah, she's a great resource for this. Okay, excellent. Yeah, exactly. The purple creatures. Yeah. Okay. Very good. Yeah. No, it's a lot of fun, and you know, kids can do it. I don't recommend it as a first soldering project, right? But like a second soldering project, or maybe you solder the pin headers and things because you don't want every one of them bridged. So we've also had, the CubeSatSim has also been in the AMSAT Journal a bunch of times. There was a great article just recently, July, August, by Olivia Bellion. She was an intern at the Savannah River Federal Research Lab, and she basically built, I guess she 3D printed the CubeSatSim frame, and then she decided she could do better, and so she redesigned it, which was really cool. And she wrote an article about it. So that was her intern project, which was great. There was also a good article by Paul Graveline. Paul? There's Paul. Good to meet you, Paul. Paul and I we've been working together on this project for almost over a year now. So all right, good. I need to stop by and say hi. So Paul wrote this article where he interviewed Bruce about his experience building it. So it's a good neutral article, not by a biased person like me who will say it's a lot of fun. And then I also wrote an article about some of the hardware changes that are there. There was a segment, I guess, of celebrating the 20th anniversary of the CubeSat standard, and it was on the NPR Science Friday, which is their national program, and a teacher, Darren Yu, out in California, he's built CubeSatSims in his classroom, and so he mentions it in his interview, which is nice. Also, AMSAT-UK recently built a CubeSatSim, and this image here is from their colloquium, which was just last weekend. I actually watched it live, and Dave Johnson there, G4DPZ, he actually demoed it. He did a live demo, and it even worked. So that was good. That was showing it off to the UK audience there. Also, in the UK, they're now stocking the blank boards on their store, and they ship to the rest of the world. Because here on the AMSAT store, we only ship to US addresses, but now the UK, AMSAT-UK is supplying the rest of the world, which is great. And I mentioned that we did a balloon flight back in May, and we flew an earlier beta version of this CubeSatSim hardware, and it worked quite well. Okay, are we ready to do a demo here? Enough of me talking? Okay, so I'll turn on my radio here. So we're going to be transmitting at 434.9. You can, if you have a radio, you can turn it on if you want. So we're going to launch it just like we launch real satellites by taking out the remove before flight. And if we do that, we will get going. So one of the things you'll notice with the, I should show the See if we're still, oh, okay. We disconnected. We'll need to reconnect the ground station. Let me just do that. So I'm using VNC to log in. If you want to. No, actually, I'll need to push buttons and things. So, okay. Default password Raspberry. Okay, so this is our ground station, which is also basically the Fox in a Box software that Burns and Chris put together here. So let's see, I'm going to start running the WebSDR here. And so we see the green light is on, indicating the software is running. The blue just flashed, indicating that the transmitter is getting ready to go. And in a minute, we should hear something. There we go. Okay. Anybody copy the call sign? Yeah, that's a familiar one, right? That's AMSAT's call sign. Okay, so this is oh, there we go. Here the APRS packet. It's starting up in mode 1. So this is it's known as a WebSDR. It's basically an SDR interface, but you access it through a web browser. So it doesn't have a million controls, right? 'Cause I really hate when you run an SDR software, when you start it up, nothing happens, right? You got to find the magic places to press, and then noise comes out of it. And that can take you, hours, days, who knows how long, until you actually get the thing to do what it's supposed to do. This just comes on, which I like. And it's got built-in decoding. So if I click here, this actually fires up an APRS decoder, and so it should decode these packets as they come in. So we'll see if that works. And one thing to notice the CubeSatSim now has 2 antennas, and that's because we actually have two transmitters in it. And one of the transmitters is also a transceiver. And so for the first time, we're able to actually receive radio. And so one of the things I'm going to demo here, there we go, that worked. See the packet here? So W3ZM-11. So I actually have it in high altitude balloon mode, in HAB mode right now. So it just says high, and then it gives the battery voltage, 3.96 volts, the battery current, which is 397 milliamps, and then the rest of it there is some of the sensor data. So the BME, it's 23 degrees Celsius in this room. It's 994 kilopascals. What else is of interest in there? Correct. Yeah, it's transmitting like every 40 seconds instead of like every 5 seconds, which would annoy people on APRS. It also doesn't do the CW call sign as well, which you don't want. And it uses the balloon icon here. I don't think the map is going to work because I'm not connected to the internet here with my network. But this software will basically look up the latitude and longitude, and it will map it for you, which is nice. But yeah, the map is not working there. Okay, so that's working. So now I'm going to try the part of this that's never been done before. So right now my HT is on 434.9 megahertz, which is where we're receiving. I'm going to change it to 435 megahertz. This is where it's listening. And after it sends a packet, it's going to listen. I'm going to transmit, and we'll see if it changes modes. We'll see this LED, this green LED will blink. So let's see. Transmit. Oh, I didn't see it blink, but it turned off, didn't it? Did it blink? Okay, excellent. Thank you for catching that. Okay. So, all right, nice clean spectrum there from the Baofeng, as expected. So, okay. So it's actually changing modes now, and it's going to reboot, and now it's going to switch to mode 2. Normally we change modes by using the push button, right? Which is not that effective when you're in space, right? You don't really want to have to send somebody out there to push a button. So doing it by radio is obviously how real satellites do it. So now I'm going to switch to Fox Telem, and I do that just by running the script here. The other really annoying thing about SDR software is that any SDR software is guaranteed to break every other SDR software you have running. They're all just designed to interact with each other. And we actually found 5 or 6 programs that if you configure them correctly, that they don't blow each other out of the water. So that's one nice thing about this. Okay, so this is the familiar Fox Telem. And let's see if we get something here. And while we're waiting for that, I'll just show you. Change this back here. Oh, okay, there's the CW. Okay. Make sure this is in the right mode. Yeah, we're in FSK 1200 bits per second, so that should work for mode 2. So now it's transmitting, but it's just the carrier. It takes about a minute for it to come good. Oh, there it goes. Okay, we are locked in. We got the nice open eye here. We've got a digital signal. I do have find signal turned on, so it'll automatically find it. And now if we go here into the FSK tab here, we should see things changing. Let's see if we see things changing. Yeah, there we go. Just got a packet there. 3.88 volts, 424 milliamps of current there. That current's a bit high. I don't know why that's high. That's interesting. And you'll notice here that it says simulated telemetry is off right now. It keeps track of the ground commands. I had done one to test it yesterday. So as we do more here, we should see this. It's not safe mode. The bus is working. The camera is working, which we use for slow scan TV. It's got a Pi camera there for doing selfies. And the transmit and receive antennas are both showing as deployed. Okay, so I'm ready to change mode again. So this time I'm going to watch it, since I missed it last time. So I'm going to transmit again and watch for the blink. There we go, 3 blinks. So now it's changed into mode 3. So mode 3 is BPSK, which is basically Fox 1E emulation. Before we were emulating, like one of the FM Foxes. So I'm going to change this now to Fox 1E and start. Okay, so that should be ready. And then while we're waiting for that, I'll just show you a couple of things here. So this is the current wiki instructions for building the CubeSatSim. You can see the whiteboards. This is the original version. But if you go in here and put 1.3.2, oh, I forgot to preload it, so we won't see it. But basically, you'll see the updated instructions, which we're going to be testing. What else do we have here? So this is the new bill of materials. And it's been simplified. Also, we're using something called Octopart. Anybody ever used them before? Yeah, it's really nice. Octopart has links to the distributors. So you put in a part, and it will tell you who has it in stock and what their price is. And when you make a whole list, oh, here we go. Oh, I'm on the wrong one here. There we go. So we're waking up in BPSK mode here. Start with a carrier. And in Octopart, you can just say buy, and it'll basically generate a shopping cart at DigiKey or whoever your preferred distributor is, which is nice. There we go. That's the beautiful sound of BPSK when you listen to it in FM, which you shouldn't, of course. But there it is. We also have a nice open eye diagram there, a good phaser. And if we go into BPSK, that gets annoying fast. We should see the data updating there as well. All right, so I'm going to change to one more mode here, because I think I still have a couple minutes, right? I still have time? Okay, good. All right, so I'm going to change back here and transmit again. There we go. So now we'll be in mode 4 in a minute. So we'll get going with that. And so I showed you the bill of materials. So this is the at the AMSAT store if you want to buy the blank boards. That's where we have them there. Did I find the AMSAT UK? I think I did not. Oh, there it is. Yeah, this is the AMSAT UK page that has the where you can order them. They just did them in green. I guess they're cheapskates. You have to pay like $5 extra to get different colors. So they just went with green. And instead of $35, it's 35 pounds too, so inflation. Okay, so now we're going to be doing slow scan TV. So I'm going to switch to QSS-TV. And this is going to come up and ask me what frequency I want to listen to, because it's got a script with RTL-FM. And for instance, you could pick the ISS frequency, and with an outdoor antenna, you could receive the slow scan TV images that they're sending out, which is fun. You can also choose other frequencies or do a test. So I'm going to choose the CubeSatSim, and then that will get going. And QSS-TV, it does automatic, based on the tones, it'll automatically switch modes. We use Scotty 2 mode for SSTV. The only reason we use that is that there's a very nice open source stack for it that works really well. I'm sure there are other better modes, but it works. We'd like to use like the PD 180 that the ISS uses. 120, PD 120, yeah. Unfortunately, there isn't a good open source stack for that. But if you know of one, let me know, because I'd like to switch to that same one. But okay, so hopefully this is going to come up in a minute here. Actually, it's not coming up right now. That's not a good sign. We'll see. Yeah, so the old software, we just had to restart the application.
Alan, could you repeat the question for those who are online, please?
Oh, sure. The question is, why does it take so long to change modes? So right now, it could be because it's suffering an anomaly. Oh, no. Okay, it just took a while there. But now, because we have different modes, I'm actually doing PWM modulation on the Raspberry Pi Zero, and we're doing RPi-TX. Remember I talked about software that kills each other? You know, these things don't interact well. So the only way to get reliability is to actually reboot the Pi each time. So before, we could just restart the software when we changed modes. So now it adds about another 20, 25 seconds. It's unfortunate. There might be a workaround in the future, but I have not found it yet. You know, these software packages, they just interact badly with each other. So, okay, so still nothing here. I think we're having an anomaly here. Well, anyway, this proves it's a real demo here. We'll see if it comes good. Maybe it's going to wake up here. No, because I'm listening on my radio too, so it's silent. Yeah, this is what you don't want when you're CubeSat. You're listening, you got nothing, got no telemetry, you've got no lights on it. Actually, you know what? We could send the reboot command. We could deploy the astronaut here and say, "Oops, let's do a hard reset." Who knows? Maybe that'll work. Okay, I'm going to go back here because I want to leave time for questions here. So if you're interested in this, if this sounds like something you're interested in, how can you get involved? Well, there's a bunch of things you can do. Certainly you can build one if you want to. It's a fun project. And it's also fun to build. You can build it in a group. You can basically divide the boards. You know, and some people work on software, some people work on hardware, some people work on ground station. So you can do it with a group. And it's about $300 in parts for everything, which is not too bad. I think Jerry spends a little more for each CubeSat that we build, but anyway, 300 is not bad. And hopefully next year we'll have solderless kits. But the other thing you can do is you can borrow a loaner. So we have them as basically they come in one of these padded containers, and you get the CubeSat simulator, you get a ground station, and instructions. And you know, I can ship it out to you a week before your event, and then you can get up here and be like me and do failed demonstrations with it. Mostly it works. This is beta hardware.
Hang on just a second.
Yeah.
Just a point of, sorry, Lou. Let me get a microphone to you here.
What grade level would you suggest to start with bringing this thing in?
So, I mean, building them, You know, soldering, I guess some people solder with elementary school kids, it's possible, but probably high school kids for soldering. For really getting into the details of what telemetry is and, you know, things like that, it's high school kids. But even grade school kids, you can do fun listening exercises where you just listen to the different modes and hear how they sound and talk about how, you know, the sound, decodes in different ways and the like. So you can definitely do things with it. The ARIS actually has a program, Sparky, right, is their program, and they actually have radio exercises that go all the way down to elementary, and they start off by teaching, you know, what are waves and you know, things like that, starting with the real basics, which is what you really need to go with younger students. And we also intend to develop some materials in the future when we're not building beta hardware like we've been for the past year and a half. Yeah.
So when you flew this on high altitude balloon,
Yeah.
How did you track it?
Yeah. So so what you can do is the Pico has got a number of serial ports. So you add a GPS module that's just got a serial interface. The software is all there, and that way when you transmit your APRS. Right now this will just transmit a fixed latitude and longitude. But if you put a GPS module on there, but we didn't rely on it. We had two other trackers. One was actually a radio sonde, which right now is our favorite one. If you repurpose National Weather Service radio sondes, flash them with software so they transmit on amateur radio frequencies. There's an article in the AMSAT journal from last year I was one of the co-authors, but it's mainly a group in San Diego at the Mount Carmel Amateur Radio Club there. And radio sondes are fantastic for balloon tracking. We also have a commercial GPS, like a spot track as well. So, you know, on the other hand, if you don't care about recovering your payload, it's not as critical, but we like to get them back. So,
How difficult would it be to add a GPS receiver to perhaps a subsequent iteration of this CubeSatSim?
Yeah, I mean, literally, it's just a matter of connecting it. The only issue is that a lot of GPS modules don't work above a certain altitude, so there's no perfect one out there. You know, you could buy like expensive ones, I guess, that would go up high, or you could buy cheap ones that are going to top out at 18,000 feet or whatever they are. So yeah, it's definitely an option for adding it in the future. Yep.
There is actually a good answer in GPS space these days, the U-Blox Max M10S.
Okay.
We're using that for high power model rocketry, and it has an avionics mode you can put it in where it doesn't max out until 80,000 feet.
80,000 feet, that's pretty
And they're
good.
about, in quantity one, they're less than $15.
They're $15 in quantity. Oh, quantity of one, excellent. Okay, and so that was the U-Blox M10S. Okay, I think we're recording, so we're good. Okay, so I'm at the questions point here. You can always email me, and there's also a good, if you go to the wiki page, go to the GitHub page, there's a active discussion forum there.
Yeah, Alan, are the new boards available now, or is that coming out still in the future?
Yeah, so what I plan to do is to do an official beta release, basically. And I was hoping to have it done here, but there was a fabrication error in the latest batch. So probably in the next 2 weeks or so, I'll basically officially release it. And all the Gerbers are there, so anybody could get them printed if they want to. I'm going to get some made. We're actually planning to, if anybody has bought the blank boards from AMSAT, from the AMSAT store in the past, we're actually offering for a limited time, and I think the first 50 or so people that respond will actually ship you a free blank board, basically. And with that, you could build this upgraded STEM payload board and then plug that in top. You could also get the other two boards as well, and then build your own. But anyway, hopefully in the next 2 weeks it'll be an official beta release, And I'll keep it in beta until early next year, just to get plenty of feedback. And then after that, release it, hopefully, as the new version 2. And we're going to keep supporting the original boards, of course. And the software is backwards compatible. If you upgrade to the new software, but you have the old hardware, you just won't get many of the features. Yeah, Paul.
Yeah, I just wanted to mention to the people here that once we get this done, we're looking at a fair amount of, I guess, customer support. We're going to try and have significant information on the AMSAT bulletin board, on the AMSAT website, and we're going to develop curriculums for people to have this. Somebody asked who's going to use it, and I'm hoping that we get like high school teachers and even science teachers. And a big challenge is a lot of these people don't know much about science, don't know much about rocketry or science. So we're planning to back it up, you know, with some type of help.
Yeah, hopefully once we've literally spent 18 months developing new hardware and software. It's been a rough period. After that, we plan to switch back to developing materials, videos, exercises, things like that. So hopefully that's what I'll be talking about this time next year, not, oh, here's the latest beta that's going to be released in 2 weeks, probably.
Hey, Alan, not a question, just a comment. Virginia is watching the live stream. She wishes she was here. She was here, and she's loving the new CubeSatSim design and plans to build one.
Excellent. I'll see her next time.
I'll make a comment also. The little tag you have that says pull before flight. I was at an IEEE meeting at University of Texas at Dallas, and there's like a Top Gun kind of a pilot that's a test pilot at General Dynamics. His son was there, and he was telling war stories about those little flags were actually used on bombs on planes, and the pilot's supposed to walk around and pull those pins before he takes off. And he was in formation, and one of his buddies didn't pull the pins, and he could see the flags over there flashing. So those are real things.
There's a reason why they're red.
That's right.
Yeah, and I think AMSAT has a sad story about them too, which goes way back.
5 minutes.
All right. So yeah, I'll just close by acknowledging this work is built on the work of a lot of others, including Mark Spencer, WA8 SME. He built the first CubeSat simulator many years ago. And also it owes a lot to Bob Bruniga's LabSat work as well, and also the simplicity. He was very good at designing very simple, very low-cost hardware, and that's something that we've tried to emulate here with the CubeSat simulator. And finally, just want to thank all the members of AMSAT, the board of directors, everybody who's supported our work over the years. And any other final questions? Okay, well, thank you.
All right, that was Dr. Alan Johnston, and excellent demo, Alan. Thank you very much for doing that today. A couple of housekeeping notes. Number one, if you just arrived today and you have not gotten your registration packet, please see Mr. Frank Karaskis in the back right corner, actually your left corner, I guess, but depends on which way you're facing. We'll call it port. How about that? Starboard and port, right? The next presenter that we have up will be the ThinSat project for high schools, Nick Pugh and Bob Twiggs. And one other item, if you have a question, please raise your hand. Let me get a microphone or someone else to get a microphone to you. We have a number of people watching online, YouTube, live stream, and if they can't, if we don't get you a microphone, they can't hear you. So with that, I will turn it over to Nick right now, I believe, right? Oh, maybe he's not quite ready yet. So.
Well, good morning, everybody. This is going to be the Bob and Nick show. So I'm Nick Pugh. I'm the Raging Cajun from the French-speaking piece of Louisiana. But as most of you guys, I think we're tinkerers. You know, and you might be a tinkerer if by the time you learn to crawl, you figured out how to jam a wire into a receptacle and get yourself excited. For you youngsters in the office, in the audience, when we grew up, you know, I used to take a forklift to move a TV around. And in the TV, you know, they had a cathode ray tube that was about this long. And to accelerate a beam down that thing, it took about 30 kilovolts. Well, as a youngster, we took that thing apart and quickly found out where the high voltage was. Some of us probably built a crystal set. How many of you guys in here built a crystal set? Yeah. You know, and one of the things that we got through our careers, the first thing we did, we went into our dad's workshop, built something that caught on fire. You know, and being an engineer, we innovated that process and made a bigger fire. And some of us, most of us, I hope, got an amateur license. So our mission is to get 20 high schools and universities with almost no experience to build or design, build, launch, and operate a satellite in LEO. Now, AMSAT has got several programs, 2 or 3 of them, ours being one of them, that are kind of parallel, and we think ours might be the starter. So it's our intention, if we can get Alana to give us a launch, is that we will put 20 small satellites in orbit every year. So the way we plan to do that is we're going to take a 3U and we're going to jam as many small mini satellites as we can get in there and release them on orbit. We're going to wait till we get below the ISS orbit, and we'll probably, if we're lucky, we'll get about a year's life out of them. But our program differs from some of the others is that we're kind of like womb to tomb. We want actually to get kids and college guys flying satellites. You know, Alan's deal, we think ours might be the starter, and then they migrate into Alan's, and then let those students build bigger and better satellites. Now, we got some challenges, but here's some of the outcomes we want. You know, if you're going to build a satellite, it takes teamwork. And young kids and college students don't work well as teams, but to get something done, you gotta work as a team. As if you're going to build a satellite, you got to learn something about space. You got to know something about orbital mechanics. You got to know something about communications. You got to know something about how to convert sun energy into batteries, energy, and store it, and how to efficiently use it. And you're going to use and learn things about sensors. And of course, because there's radios on it, and we're just biased to be radios, we want everybody that gets on a build a satellite to become an FCC license holder. So here's some of the things we're going to tell NASA. Here's why they ought to give us the launches. First of all, it meets their education goals. This allows NASA to get 20 satellites a year into orbit. Now, we're going to pass our merit and review panels. We've got this thing fully funded. It's a big workforce effort. You know, if you got kids building satellites, most of them are going to work in aerospace. And what I always tell educators, you know, if you think you're going to collect your Social Security, you better start teaching kids how to build things. And of course, you know, we get excited. I call this the wow factor, is that once you get somebody who can brag about putting their fingerprints on hardware in space, that ought to get them excited. If they're thinking straight, this gives them a ticket for scholarships. I tell them, you want to give your parents a raise? go get a scholarship. So let me describe what we're trying to do here. This is a very early piece of prototype. I got one I'm going to put on the table in a minute. We think we're going to build these things. They'll be 85 by 85 by 15 millimeters. We want these things to weigh less than 200 grams. We want them to be programmed in an Arduino IDE. We're going to release these below the ISS orbit. We understand all the new rules, and the FCC is not excited about licensing things that are smaller than 1U. We're going to package a 900 milliamp hour battery in there. We're going to have solar panels that are producing 2 watts per face. Now we're challenged because this thing will be flipping around. We don't know how much of that 2 watts we can actually gather. And we're going to, of course, we're going to put a peak power tracker in there. Some of the other descriptors of this thing is going to put out a whopping, we're going to power it up for 20 minutes in an orbit. We think we've got enough battery to run that transmitter for 20 minutes. It's going to put up a whopping output power of 17 dBm. Here's what is exciting to us. The sensitivity on this receiver is minus 148 dBm at 24 baud. We understand, you know, you trade sensitivity for data rate. But if our students are smart enough, we're going to make this data rate adaptive. So as that satellite gets a little closer, we're going to crank up the data rate. Of course, we're going to put this in the UHF band 437 to 438 megahertz. Now here's what's kind of unique about this. Because of that sensitivity, we're going to put a monopole on the end on the satellite and an omni antenna on the ground. So this makes the ground stations extremely simple. You know, probably a 5/8 inch vertical would probably just do really fine. Of course, you know, we got to make this thing work from minus 10 to 50 degrees Celsius in orbit, and we got to probably shake it to 22 grams. And we're gonna fly it in the ham band, so it's going to be, somebody's got to get this thing licensed. So some of the other things that we're going to fly on the payload, we're going to let the students design their own payloads. This satellite will contain a solar panel, a battery, a processor, and a radio. And the processor will, of course, have buses, I2C buses, 1 or 2 GPIOs, an analog to digital deal, and a UART. We think if we did our energy corrections right, we will have the payloads will have about 200 milliwatt hours per orbit, milliamp hours per orbit to run their payloads. We've got about 150 square centimeters of empty space for them to design their own sensors and their own payloads. We're going to have an external watchdog timer, watchdog cutoff circuit for latch-ups. And of course, we're going to build in temperature and battery and voltage sensors on them for housekeeping. So now here's the link budget, and here's what's kind of exciting about it. We're going to put it in the UHF band. We're going to say that at the horizon, that's about 1,500 miles from the ground station. We're going to have an output power of plus 17 dBm. We're going to run 0 gain antennas on the satellite and 0 dB gain antennas on the ground, which gets us puts a received signal level coming to our receiver at minus 136 dBm, and the radio will work down to minus 148. So here's a quick power budget. Our little receiver will pull 12 mils. We'll run that all the time. Our transmitter at 7 plus 17 will pull 120 mils. And of course, our processor will pull 14 mils. And we're going to allow 200 milliamp hours per orbit for payloads. So the total power consumption we're hoping to be power positive is that we will consume about 461 milliamp hours per orbit. If we miss that, we'll have to back off on our transmit time. And if we get into real trouble, we'll have to start putting some of these devices to sleep. So here's the block diagram. We are showing 16 little solar panels. Actually, the mechanical team tells me I can only get 14 in, so this is not quite accurate. We're going to put a peak power tracker on both faces. We're going to have batteries, 2 little coin cell batteries in there, a watchdog timer, and a Shao microprocessor. So let me talk a little bit about this radio. It's a LoRa, and I know Zach back there is going to complain because it's proprietary. But for $5 and its sensitivity, we think this is a pretty good choice. So this thing has an output power of plus 18. The sensitivity at 24 baud is minus 148 dBm. In fact, that's so low, it's very difficult for us in our little skinny lab to make sure we can get enough isolation to test the sensitivity on this thing. And of course, the modulation is a chirp spectrum. So it's kind of magic how this thing works. But this thing allows us to detect signals 20 dB below the noise, which is, in my view, magic. Here's a little deal why we think sensitivity is important. You know, a typical G3 RUH modem at 24 baud requires us to put a signal at the input of the receiver at minus 137 dBm. This LoRa module at the same rate will detect things 20 dB below the noise, so we only have to come in at minus 148 dBm, which is a significant improvement. And that lets us get into schools that have no infrastructure. And we have a little demo of the ground station over here. So they can go plant a vertical out in the middle of some field out there, and they've got a ground station. You know, for us who've put up Oscar antennas, that's a pretty good project for us. So here's the demo that we're hoping, we're kind of like Alan, we're keeping our fingers crossed and hope Murphy stays home, is that on the left over here is our balloon version of the satellite. This box over here, this little box in the middle is our ground station. And of course, it's tethered to my smartphone. And what we're going to demo is that this thing is now Wi-Fi'd into a server, io.adafruit server. So we have a server built in, and I'm going to switch to that in a minute. Because we can put this thing on, by the way, this thing only weighs 5 ounces, and this includes enough insulation to let that thing work at minus 50 or 70 degrees in centigrade. So we start by flying this thing on a balloon. But, and because the server's built in, you know, the kids can not only, they can walk around the parking lot and measure things. We got several sensors involved and hooked up in this thing. And so basically, guys, let's see. I thought I had a picture. Oh, missed. Well, gee. This thing won't let me back up. So let me switch and see, keep our fingers crossed and see if we can actually let this thing talk to this server. So this is a server picking up live data. And remember, this balloon package will talk to this ground receiver, which is tethered to my cell phone, which is then hooked to a server. So in the classroom, all the kids can see this data live. And here's some of the sensors in that balloon. So we're picking up the RSSI. We're picking up some temperature in here. And look how neat the graph is. It's all set up and done, and kids can configure their own server really quickly. So that's what we got. So are there any questions so far? Bob's going to get up and continue this talk on what he's up to. Okay, Bob, it's your turn. You got your thumb drive?
How many of you have heard of a CubeSat? Many years ago, and tonight I'll give a presentation on the kinds of satellites that I've been involved in. And a very interesting thing happened in the academic thing with myself, using satellites as a way to teach students how to build things. And it turns out that I've found out, and I'm sure you found out, once you give these kids an opportunity to get in the lab and start building something, I had a problem with them locking me out of the lab. They didn't want me in there fiddling with it. So. But the CubeSat come about from a fact that I had some students that were building microsatellites, and there was too much room in a microsatellite, and it was a group of master's degree students, and they wanted, they only stayed in the program for 1 year, and every time a new group would come in, they would want to change everything and put more stuff in there. So I figured the best way to stop them from adding all of these things was make something so small that they couldn't put very much in it. And so we had a project where we actually used a microsat to launch pico satellites. We worked with the Aerospace Corporation and launched these pico satellites that were about the size of an ice cream Klondike bar. And it worked out pretty well, but I thought if you're going to make a little satellite, you probably should have something that's not flat like an ice cream bar. And so I started looking around for something to use for a small satellite, and I went to the local plastic store and found a 4-inch box that they put Beanie Babies in. And so I got that box, went back to my office and looked around to see if I could find solar cells that fit on it. And by golly, I could put a couple of solar cells on each side. So another professor at Cal Poly, Jordy, talked to him about it, and he says, well, let's try that. And then I made a launcher out of plastic and sent it to Jordy along with my specifications, and we decided to go there. And so Jordy proceeded with his students to get the specifications going and so on. And then we advertised it. And how many of you remember when it was first advertised? Do you remember what you said to us? We're stupid. Nobody would use anything that small. And there were not some very complimentary things said about us at that time, including you academic guys aren't smart enough to build a satellite. So what do you do when you get a challenge like that? You know, you give it to the students and they do it, right? We got a lot of comments about this is kind of a stupid idea. Do you know what the projected commercial value of the small satellite is in 2030? $6 billion. And whoever thought that? We said, we don't care what you think. We built this for education, and look it, there it is on the table, being used for education, and it is amazing. I'm working with a former student of mine that is writing a book about the CubeSat, and so we're talking to a lot of the people that got into it, and it is really interesting. I went back and talked to some of my former students, and we said, and there are a number of them that are very, very successful. There are a number of them that started out with some guy named Elon Musk, and with his rockets, getting them launched. And I talked to the students, one in particular is a young lady that's working at the Lockheed Martin advanced lab in Palo Alto. And her team is building instruments for, they build instruments for the James Webb telescope and some newer telescopes. And we talked to her, what was the value of that program? And she said, well, it was you put us in the lab and you said we had at that time to build a microsatellite, and we had to go get all the parts, beg and borrow to get parts, and if we could, we would steal them. But she said it was working on that satellite and all the things that we had to do in terms of a group to get it to work. And I said, well, what about my classes? Well, they were okay. You know, but they learned the most in the lab, and I think that is a real lesson. That young lady now got her PhD at Stanford. She's working for Lockheed Martin and has 87 people working for her. So it really helped out. It really was an educational project. So we went on from there and worked with, early on, worked with AMSAT on the microsatellites, the 4 microsatellites that were launched. But one of the things that I have wanted to do since I retired is to get back into the grade schools and the high schools with STEM projects, because it really makes a difference in the kids. I know all of you have had that kind of experience, but you get a group of kids together, and ones that said, you know, I hate school. I really hate school. By the time they work on these projects, they really learn to like school because they need all of the classes and all of the subject that they need. But one of the things that we got into is, one of the things that I found out is when the CubeSat got popular, we got pushed out from the education side because of the price of the launches. You know, we got our first launch for $30K, and we can almost have a bake sale to get $30K. But then they went up to $90K. And then, of course, NASA got in, and oh boy, did the paperwork increase. How many of you do NASA paperwork? Yeah. It's a real pain, right? When we first started, we didn't have to do all of that paperwork. But the thing that I wanted to do was get the price of getting something launched down. And so I started working on a thing called Pocket Cube. How many have heard of Pocket Cube? A few of you, huh? Now that's a really going, actually commercial business. And so I was trying to figure out with the CubeSat launcher, how could I make pocket cubes? And Pocket Cube is not a 100 centimeter satellite, it's a 50 centimeter satellite. And of course the guys that said you can't put anything in a 100 centimeter satellite said, oh crap, there he goes again, you know. But the thing that happened is the miniaturized components really can get some stuff that's really small. But I kept trying to find a way to get them launched, and I finally run into Warren Frick at the SmallSat conference in Utah. And I'd heard about the possibility of launching something on second stages. You don't get much orbit time. But I thought, hey, if we can get on the second stage, they said we'll get anywhere from 5 days to a week. And, you know, that's just the attention span of the kids, right? 5 days or a week. So we can get them launched. So anyway, we got together with him, and believe it or not, Warren says, I think there's an opportunity for you. So we got together with Orbital ATK and Virginia Space, and within a month, I was in the office of Orbital ATK, and they said, we'll do this. You know, how many of you have ever got anything accepted that quick? It was amazing. And so we ended up on the Orbital ATK second stage, and one of the things we come up with, instead of the little 50 centimeter cube, was to do the toast thing, you know, cut it up and make it in toast like this. So I don't know, any of you remember, it's called ThinSat. And we worked with Orbital ATK and Virginia Space. They've actually put a lot of money in the project. And in 2019, we launched 60 of these things for the kids. 60 in one shot, you know. And they kind of worked, but the orbit life was more like 2 days than 5 days. But it was good. And then 2021, we launched 30 of these things for the kids. So the proof is you can do it. You can make a satellite, and you can make it work in something like that. So what Nick and I decided to do was, how many of you in here consider you're techies? How many consider that you're non-techies? Okay, I want to only talk to the non-techies, all right? The rest of you guys, plug your ears. We want to offer only to the non-techies the opportunity to build a satellite with a bunch of kids. We can put these kits together, and Nick and I will sponsor at least the first 10, all of the cost for doing this. So this is a model of the satellite. It's made out of styrofoam. The batteries run down very quickly. The electronics in it don't work worth a darn, because there are none in it. And what we want to offer to you is the opportunity to get a group of kids together. And here's what our plan is. So Nick and I, along with you, would like to see younger AMSAT members. How many kids do we have in the audience here? Kids. Oh boy, I'm glad you still consider you're a kid. So we want to find a way to get new AMSAT members. So the following is, we're going to offer 10 prototype satellite kits at no charge for extensive use on the ground, but also will evolve into a space satellite to be launched into LEO off the ISS and operate below the ISS, so it has a short life. The kit will challenge you at your hometown to recruit a group of at least 10 young men and ladies and adults that want to learn the principles needed to build and operate a small picosat for at least a 3-year program, because it's going to take that long by the time you go through everything and we get our launch. So Nick and I will provide you with a kit and all of the hardware, software, and technical support to launch, to evolve into a NASA-launched satellite. We call it SlimSat because this other one was called ThinSat, and we wanted another name. So anyway, what we can do is in the space of a 3U, we can put about 20 of these. And so to get the free kit, you must, now this is for all of the non-techies, you must pledge to be a member, a mentor for these program for at least 3 years. So I've got this form that I'll hand out, and you've got to complete the form. And what you'll do is on this form, you'll give me your name, signature, address, and everything, and give it to Nick and I. I have 2 copies in there, so you keep one. And I'm going to give you the kit. The kit has the foam sat in it. Now, I make models in my shop, and this isn't perfect, but it's something to show the kids. The other part of the program is we're challenging as many people as possible to give us a new name. So we get to name the class of satellite, but you can name anything that you want to on your particular satellite. So Nick has showed you the hardware. That works. But the real value of this thing is you can do lots of things with that before you actually launch it into space. And we really want to see kids here. Now, one of the things in this is you're required to get the new members of your club to get their novice license within 3 months. Okay? You think they can do that? I think so. The other thing that we're going to ask, and this might rub a few, I won't tell you what, but we want to challenge AMSAT that every one of those kids that get their novice license and staying in this club gets a free 1-year AMSAT membership. Is that possible? Let me see a show of hands who think it's possible. Ah, that's a good number. Now, what we hope is each year after this year, when we come here, we've got kids in the audience. Are you having any trouble getting kids into AMSAT? Let me show you, see a show of hands. Yeah. And that's what this program is for. So please, non-techies, we don't have as many non-techies as I'd like to see here. And if you think you're a techie and would like to do this, we will lower the standards and give it out to some of you techies. So, what I want to see is I want to see a raise of hands who would like one of these 10 kits. Nobody. Oh, 1, 2, 3. Let me 4. Okay, now we'll let the techies in. Any techies want a kit? Okay, well, we've got some people that want to do this. I would like to see more of you guys involved with the kids. But I've got these kits up here. I got 10 kits, and one of the things to give the to give the students as a reward, we've got a little duck in there, okay? Do you know why we're using ducks? Well, I'll tell you the story. We're working with a group of students who are going to do zero-G experiments on the NASA zero-G airplane. And the pilot and the co-pilot, when they decide that they're in zero-G, is they have a duck, a little yellow duck, that they hold up and it floats around. So we've decided that's a good mascot, is a little yellow duck. So along with the model and the guarantee that we'll support you are 10 yellow ducks for the students. So, okay, so anybody that wants to pledge and do this, please come up and get a kit. Thank you.
And Nick, we do have some time for questions. If anybody has questions, maybe about 5 minutes. If you would wait till I come around with a microphone, and then we can ask your question.
Nick, I saw a mention of a receiver. Can you telecommand to these SlimSats to control them in orbit?
I don't quite understand your question. The receiver of the ground station.
The receiver, once it's in space, can you send telecommands to it to control it?
Yeah, it's a two-way module, and it can take commands, and we're leaving it up to the designers to do what they want with it. But after watching Chris Thompson's deal, we can probably fly his software on that if they want to. Yes.
Yeah, Nick, thank you and Bob for a wonderful presentation. And I'm wondering, so these are deployed from a 3U CubeSat, and then is that how this works? And are they tethered? Are they free fly?
No, we're gonna put them in a 3U, and we're gonna release them. Now, of course, you know, we have the challenge with NASA to fly smaller than a 1U, but we think we'll get them to relax that rule.
Okay, and then I couldn't figure out if I was a techie or a non-techie, so I couldn't figure out if I should raise my hand. I may still do so. Thanks.
Yeah, I'm a non-techie, so probably what you're looking for. But one of the things I've been thinking about, which I've not been able to implement, is approaching parent groups and trying to get some information to them about how learning the skills that you're producing would get their kids jobs later on. In other words, you know, sort of be an advocate for the aerospace industry. Because a lot of people, parents, even the kids don't understand that. But it might be attacking the parent group, if you can do this, like homeschoolers, that might be a possibility. I haven't done it, but to me, there's a lot of people there.
Well, we're open to talk to anybody, and the homeschoolers tend to be a pretty good place to get there.
Hey there, a couple of things. First of all, do you have any literature or proposals that I could throw at that I could give to an educator? Because, you know, I don't want to take a kit, but I want, because I'd like to know if I can find an educator that's interested, then we'll talk. Question number two. So first of all, I'll answer that one more.
We don't have literature yet. Our main focus is we've got to get a LANA request in by mid-November, but we will produce literature to introduce to the school system.
Okay, question number two, since this is a potential swarm of small satellites being pushed out of the ISS or out of a CubeSat at the same time, are they all going to have the same frequency? And for both receivers and transmitters, and how does that work from a command or a data download standpoint if they're all running on the same frequency?
Well, we haven't quite worked that out. First of all, we can put individual address headers on the radio, but we hadn't quite worked that out yet. But that's we're going to leave that up to our students at the university. We also would like to make a self-organizing mesh network. That's in the works too. Somehow or another, these things get out there and they'll And I see Ron shaking his head, and I'm hoping he's got ideas how to do it. But that's on our list, a design list to do.
And I think we have time for one more question.
Okay, guys, I enjoyed coming. Come participate with us.
Thank you very much, Nick and Bob. We're really grateful to see you here today. Next up, we have Frank Karnauskas, VP of AMSAT Development, and he will be talking about the AMSAT Youth Initiative. So please welcome Frank.
And I need the HDMI cable. Where did that go? Oh, it's laying down there. Yeah. Brad, help. Oh. I got I think I'm live again. Okay, good morning, everybody. Thanks for coming out today. And Bob Twiggs, this is going to be your dream speaker here, because if there's any non-technical person here, that would be me. As a kid, my dream was to be an electrical engineer. That career goal was cut short with my first calculus course. So after that, I went into psychology, which was a make-believe science. Okay, so what we've got here is we're going to talk about just an overview of the AMSAT Youth Initiative. And, why do we do this? Well, it's the right thing to do, okay? Like Bob said, this is mainly a room full of old guys, okay? There's a couple exceptions here, but next year we want to fulfill Bob's dreams and have some kids in here, some women in here as well, okay? And you know, it's important that we realize that this is in the AMSAT bylaws. We're an organization that's devoted to promoting education and engineering excellence and innovation. So what we're going to see here is kind of a marketing approach to this, because that's what I am. I'm a marketing guy. I was a marketing guy before I was retired. So we're going to build on what Alan has been doing with the CubeSatSim, what Chris and Bernsey have done with the Fox-Telem stuff. We're just kind of packaging and putting it out there to help kids just get some exposure to this and some interest in this, and then let them play with the big kids' toys along the way. There's a couple really unique features of this program. Again, me being a non-technical person, we want to overcome a lot of kids' aversion to, oh, electronics, my God, there's no way I could possibly do this. This is really, really scary sounding. Now, if you go into a room full of kids and you say, okay, who here is interested in amateur radio? You know, it's going to be crickets for sure. But if you look at what the kids hierarchy of needs are, you know, it's a food, a place to sleep, then it's, do my friends like me? Am I popular? How do I get rid of my acne? And then they're concerned about the fourth or fifth thing down on the list is they're concerned about their futures. Okay? They're also concerned about what their world is going to look like in a couple of years. Okay? But mainly they're concerned about their future. What am I going to do with my life? What kind of job do I want? What kind of career I want? Really hot these days are the physical sciences. Okay? So again, you go back to that room full of kids. Instead of saying, who here is interested in amateur radio, say, anybody here interested in climate change? Well, you're going to get some kids raising their hands. What about pollution control? You're going to get some more hands. Anybody interested in a career in broadcasting? You want to be a video DJ on MTV? Okay. Career in the military? Anybody here want to be a truck driver? Yeah, I want to be a truck driver. Well, then you should know about GPS and things like that if you want to become an executive in the transportation industry. There's all kinds of different ways to tap into the interests that kids already have. Okay? So rather than trying to intimidate them with electronics and math and all that kind of stuff, let's first talk to them in things that they can relate to. So our story, our approach is, and when you think about it, it's hard to find something in our modern life that satellites don't play an important role. Okay, so our message to the kids is satellites in space help us improve our lives here on Earth. And you can be part of it, okay? And we're going to show you how you can do that. Now, again, I'm a marketing guy, okay? So the first thing I did when we started thinking about this was we need trade names, okay? So and we also need domain names. Now, the domain name squatters, if you're looking for anything with SAT in it, good luck. Now, SlimSat.org is available for $20,000, okay? So it was quite a challenge finding domain names that were appropriate, but also that we could trademark, okay? Because I'll tell you why the trademark is very important in the future, in just a little bit. So we were able to, I was kind of amazed that we got kidsat.com and .org. We were able to trademark that with the U.S. Patent Office, and BuzzSat for the older kids. Why BuzzSat? Well, high school kids don't want to be called kids, you know, so we needed some other name. And somebody said, well, why BuzzSat? Well, why Amazon.com? And I think they're doing okay. So it's not really so important what the name is, it's what you do with it. So those are our two entry points there. And to be honest with you, I'm about a year behind where I wanted to be with this right now. We're finally pulling the pin on this and making some of it happen. For the KidSat, we're actually moving that down a couple of years, okay? And the BuzzSat, we're putting all of our energy into that right now. Why? Because it's easier to find content for the what do they call it, junior high, okay, and high school kids. To be honest with you, I'm struggling for content for the younger kids, and that's okay because we've got enough to do anyway. We'll eventually get to that. But I did need something for to get onto the KidSat website, and just as a starter to get something going, we're putting coloring book pages on there, okay? And these are simple little, and they follow the same interest paths that we're talking about for the older kids, but just think, so these are pages that the parents can go, you know, download for the kids, and each of these are like little two-panel cartoons, okay? So on the left-hand page, it's satellites help us protect our forests so we can have a picnic with our family, okay? Satellites help maintain the fish population so everybody has enough to eat. You know, it's just these simple little moral plays that tie in why satellites are relevant, and the kids can color. A really unique and fun feature about this is that, you know, one of the things we really need to pay attention to is inclusiveness. We got to get more kids from different backgrounds involved in this. So a really neat feature of this is at the start of this, the parents look at a page and say, my kid looks like this, okay? So now all the cartoons are exactly the same, but depending on whether you think your child looks more Caucasian or black or Asian or Latino, you can pick that, you know, or boy or girl, and you can pick that. So in all of the coloring book pages, the only thing that it differs is some little features on the faces, so it looks like your kid, okay? So this, you know, it's a start. It's very basic, but we're showing that we're making an effort to be an inclusive organization, and this is an easy way to start. Okay, so that's all I'm going to say about the CubeSat program right now, because right now we're kind of focused on the older kids. So who's the target audience? And you're not going to hear me use the term STEM or STEAM very often, because when you think of STEM or STEAM, you think of schools right away. This is not a school-based program. This is a community-based program. So we want to make this material available to students grade 5 through 12, parents, homeschool pods, youth group leaders, Boy Scouts, Girl Scouts, 4-H club, church groups, whatever the case may be, and primary and secondary school teachers, okay? And again, we want to especially make sure that we're addressing the access to the unserved or underserved communities. We want to make sure we're paying attention to that. And aside from it being the right thing to do, this makes funding opportunities a lot more available too. So, I mean, and a lot of grant opportunities there, you need to be very vocal and very obvious about that you are serving everybody, not just the usual mainstay. Now, I kind of tread on dangerous ground here, okay? Because when I say it's a community-based program, it's not a school-based program, and here's where I really stick my neck out. When I say schools are not our friends. They're not our enemies, okay? And we have some glowing examples of outstanding teachers and programs that are doing a great job in our area, but we know they're far and few between. And it's not the teachers so much, it's the school systems. You know, the school boards, they're under tremendous pressure to perform, you know, the budget cuts, all kinds of social issues they're dealing with right now. They're oriented towards, you know, making sure their kids test towards the school. So we're not turning our back on the school. I'm just saying we don't want the school boards or the school systems to stand in our way of succeeding. Okay? But I want to be very clear, we're not turning our backs on the school. So if it isn't a school-based program, how do we get the word out there? Remember, I'm a marketing guy. So our intention is to develop partnerships with local broadcast television stations. There are about 210 or 215 local television markets. That's who we want to partner with, okay? Now, why them? Every television station has a promotional manager or a PR manager, and that person's job is to help that station engage with its community for a legitimate purpose to increase their viewership, okay? So they want ways to further interact and engage with their audience. Everybody has probably seen this, and it usually the front, okay, that does this interaction is their meteorologist. Everybody may have seen this at one point or another where, and it's usually on a Friday, a slow news day, where the meteorologist goes out to the school, does the cyclone and a pop bottle experiment. The cameraman is there showing their weatherman, weather lady, whatever, engaging with the kids, and they put that on the news and say, see, we're engaging with the community. We're a member of this community. And that's all really good, okay? So what we're doing is giving them another opportunity to engage with their audience, and at the same time, okay, they've got benefits, okay, in terms of, like I said, engaging with the community, and also, you know, when they get go for their license renewal, they have to have some stuff in their folder that says, here's why we deserve to have our license renewed. So there's benefits for them to participate in this program. There's benefits for us, okay? Promotion at the local level, technical support, okay? There's engineers at all of these stations. Some of them are even hams. They will provide the cost for the local equipment and the technical support, okay? And this can also serve as a revenue stream for AMSAT. This is not a cost center. This can be a profit center. In no worst case, it is self-sustaining. This is not going to take any resources away from AMSAT in its engineering goals, okay, to fly things. We're going to go about 5 minutes later, okay? You're going to lose about 5 minutes in your break time. Sorry, guys, okay? But I'll be as quickly as I can. So how does this work in reality here? Okay, every TV station has an app, right? And everybody goes to their app, not so much to look at the news maybe, but everybody's looking for, you know, what's the radar look like? I kind of laugh in Tucson, you know, they all have first alert weather. Well, in Tucson, what we have an outbreak of sunshine or something like that? You know, in the north where they have tornadoes and storms, that makes sense, but in Tucson, I don't know. So anyway, here's what a website would look like. You know, their website, and you'll notice on the bottom there, along with the current temps and the traffic report, there's a little bug there for kids and young adults, okay? So if somebody taps on that, it takes them to an introductory page that talks a little bit about what the CubeSat program is, gives them a chance for them to promote their weather personalities, their weather forecasters, why getting good grades in school was important and how that led them to their career in meteorology or whatever. And we start to talk about some of the interest areas that the kids can explore, okay? So that's our interest point at that level there. So there, it just goes on a little deeper, okay? If you choose the climate change or the pollution control or the broadcasting or space exploration or a career in the military, it will then divert them to either the content for the younger kids or for the high school kids. So I'm going to skip that right now. Aside from the broadcast stations, there's additional promotional opportunities through professional organizations and youth organizations, and that, you know, everybody kind of knows what we're talking about there. Okay, so what are the components? What is the content? Okay, online curriculum. We're going to talk about the online software-defined receivers. We have a network of those. What we call the non-orbiting Earth science experiment, and then, as Jonathan was talking about yesterday, educational payloads that can fly on the Fox Plus satellites. Okay, so again, we'll have a series of online courses where it shows how satellites play an important role in all of these different areas. The first one that we're putting out, hopefully before the end of the year or early next year, is one in meteorology. We have a course developed for satellite meteorology. Okay, so it's really kind of cool. Why did we put meteorology at the top of the list? Again, because they use the meteorologist, okay, as kind of their key point to interacting with the community. So that was kind of we wanted to make sure we were addressing the broadcast station's need for, you know, some legitimate way for them to go. And I have to mention this really quick. I talked to some of the local meteorologists and said, oh God, this is really cool, you know? And then like, well, okay, it's really cool. And then the light went on and I said, oh, you know who I have to be talking to? I need to be talking to those promotion managers. And that's when the lights went on and yes, 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 we're ready to go. One station that we're talking to is actually a member, is owned by a broadcasting network that has stations in over 100 markets in the United States. That's half of them TV markets. They're watching this very closely. If this works the way we're hoping it should, we don't have to do the work. They will bring this into their 100 plus stations around the country. That would be a huge, huge win for us, okay? So we have the online curriculum, and these aren't like college level courses. Just think of like Boy Scout merit badge on steroids, okay, a little bit meatier than that. And then if we've got the kids' interest, they've got some resources that we can refer them to go on further. Okay, a key part of this is a fleet of software-defined radios that are hosted at the television stations. A couple technical issues that we're dealing with there, but they're happy to work with. One is, you wouldn't believe the noise level, from all the computers operating in those sites. The hash level is really intimidating. The other thing is network security. You know, the days are gone when they would put a piece of tape on a machine and everything's stored digitally. And, remember the old Batman show where the Joker or the Penguin would, take over the television station, and they would be broadcasting all these evil messages, and that's a real fear, okay, with broadcast stations today. So, but they will host and maintain the SDRs. They're willing to do that, and it works something like this. You pick the location of your SDR, okay? You enter the date and time that you want to listen to. You pick, now this is not the kind of SDR that you or I are used to, where we can just tune anywhere you want. These are radio buttons, okay? And you can choose the International Space Station, or obviously the NOAA low Earth orbiting polar satellites that give beautiful detailed, camera pictures from space. There's also a button there for the nosy. What's that? Well, you'll learn in a minute. So anyway, and Heimer there has been very gracious enough to help us develop a front end for the tracking. Anyway, you pick your location, you pick your satellite that you want to listen to, and enter that. The program will tell you the dates and times of when you're going to have some passes. So hey, kids are learning a little bit about orbital mechanics, how to do predictions for satellite passes, and then what it can do is turn on, it'll show them the radar thing, picture, and then they can download and record the telemetry or the video image from the satellite, and then they'll be provided with the tools, like the Fox Telem, in order to analyze the data. So they can do all of this virtually, and hopefully this gets them, some of them, and not all of them, we have to be realistic, but some of them are going to say, you know what, I'm going to buy the RTL SDR, plug that into my computer, I'm going to make my tape measure antenna, and just kind of move them along. We call that shaping behavior, okay? So yeah, this is just a feeder program for all the other excellent work that you guys are doing. Okay, the non-orbiting Earth science experiment, why do we call it that? Because my son, who's a professor up at the University of Colorado in atmospheric and oceanographic science, this was back in the previous White House administration. Don't use the word climate change or you are out on your butt, okay? So now we can say climate change again, but now we kind of like the acronym NOSI, the non-orbiting Earth science experiment. We thought we were going to have to develop a completely new vehicle for this, but actually Alan has done such great work with the CubeSatSim. We have one of Jonathan's engineers working on the sensors, okay, the climate change variables that'll plug right into the CubeSat simulator. So all we have to do is probably harden that CubeSat sim so that it can survive those 115-degree days in Tucson or those minus 20-degree days nights in Minneapolis. So this will just be located in proximity to the SDR, because the CubeSat sim outputs the FM. So like I said, all we had to do is have a button on there to tune that SDR into the frequency of the CubeSat sim, and we've killed two birds with one stone that way, okay? And then finally, again, Jonathan talked yesterday about some of the possible STEM payloads that we can fly on the Fox Plus series. And Will, where are you? There you are. Will, I misspelled your name on the badge, right? No, that was correct. Oh, yours was? Whose name did I misspell? Okay, I'm sorry. I was thinking, oh, God, I misspelled the name on the badge of the guy who's doing the slow scan TV program. I said, oh, that's going to set me behind another year, So, okay, so that's kind of it. The funding, again, ARDC is interested in this. They want some demonstrations done to prove that we can do what we're talking about. We also, we got 100,000 for them, close to 100,000 from them for the 3U space frame and deployable solar panels. So they want to see us do a good job of spending that money first before we go back to them to ask for some more. So, oh, and one other thing is everything is open access. Okay, all the curriculum and that, except if we are given some curriculum from a professional society or something like that, obviously we have to respect their copyright things there. I mentioned why the trade name, the KidSat and the BuzzSat is so important. That obviously is not going to be openly available. We're going to control that very tightly for one very important reason. Whenever you use the words children and online in the same sentence, the most important person in your organization is your child safety officer. Okay? So we're happy to make all the content available to everyone, but they're going to have to use it under their own name. Okay? We want to maintain control over our program so that we make sure, especially as we kind of evolve into the social media aspect, that we're not endangering kids. Okay? So I'm only 5 minutes overdue here. Any quick questions? Otherwise, you can catch me in over the break. Paul?
Yeah, Frank, just one from the live stream here. Peter 2M0SQL mentions that interesting focus on NOAA APT sats, but do you have any concern, of course, that those are not going to be replaced, and when they're gone, there won't be any more APT on 137 megahertz?
Well, I'm 75 years old, and by the time they're dead, I will be too, and I won't care. No, no, seriously, folks, our engineering team needs time to get our educational payloads up into space, so we're just taking advantage of those polar birds right now to serve a need. Good question. Anybody else? I know I'm the last thing standing between you and the restroom, so thanks everybody for coming out this morning, and you can catch me for questions later.
Thank you very much, Frank. And as Frank mentioned, we are at a break right now. We will come back at 10:15, please, if you'd be back in the room at 10:15, and we'll resume then. Thank you. There we go. Now we are, yeah. If everybody could start taking their seats, please. We're getting ready to start. If everybody could take their seats, please. We're getting ready to start.
You got to do it a third
Three times. All right. If we could take our seats, please. We're going to get started here. We have up next Frank Bauer, the ARIS NA Executive Director with the Amateur Radio Spectrum Use in the Lunar Environment. So please welcome Frank Bauer.
Thank you, Zach. Let me just say, I'm Frank Bauer. I didn't put my call sign on here, which I normally do. It's KA3HDO. I think everybody knows me, but you'll get to know me over time, I'm sure.
The reputation precedes.
That is very true, Barry. My reputation does precede me. So I'm going to, this talk, I kind of felt this was a good time to have a talk on, on radio spectrum in the lunar environment. I'm a little concerned, I will say, because I'm starting to see some things happening. It's great to see things happening, but I want to make sure that we are good stewards of the amateur radio frequencies as we try our best to be. I mean, we do know that there's a World Radio Conference coming up. One of the agenda items is on our spectrum, the 1300 megahertz spectrum concerns. And some of that has to do with the fact of people knowing what's going on in the world and, you know, how to protect our radio frequency spectrum. I heard George Presley just the other day. We were down talking to him, and he gave the talk to our one of our new director of education in ARIS, and, you know, passionately telling everybody how important it is for us to protect our microwave bands. And I totally agree. All of our bands that we have are important. And so I think it's important we talk about this now and start getting everyone, and, you know, this is in the United States discussion with AMSAT North America, but this really needs to be had across the world to make sure that when people are building things in the lunar environment, we operate on the frequencies that are out there for us. So just as a, and let me just say how this all came up, you know, it has to do with the fact that these individuals are starting to build satellites, and this past week, and it's actually been several months, I've been working, you know, my day job, most of it is ARIS, but I do support NASA on a part-time basis, and I support them on lunar position navigation, well, position navigation timing, but mainly lunar activities now. This is an offshoot of what we, AMSAT, did on AO40, where we actually showed you could use GPS above the constellation. We're now using GPS halfway to the moon, and we're talking about utilizing it in a lunar environment. So, so that's part of the position navigation and timing activity, but there's a lot of other aspects of it. And part of it, of course, has to do with frequency coordination. So the actual person that, we had a UN meeting this past week. It's called the International Committee on GNSS. And we had the person that handles frequency coordination give a presentation at that meeting. So what I want to tell you is that that person, actually, a number of the charts I have in here are from the person that runs the Lunar and Martian Spectrum Group as part of the Space Frequency Coordination Group. And I'll explain those terms in just a minute. But this basically, this chart shows the lunar landscape in just the next couple of years. And each one of these names on here are missions that are coming up. Some that you're very familiar with, the Artemis program. You know, with Artemis 1, they got launched this year, I should say. No, I'm sorry, last year. And then Artemis 2 coming up next year, and Artemis 3 later and beyond. Yeah, a number of you are familiar with the fact that AMSAT and ARIS have been working on the Lunar Gateway activities in a program called ARIX, or Amateur Radio Experimentation. But there's a lot of commercial and space agency activities going on. There's several dozen, as you can see here, several dozen missions being planned. Some of them are commercial, the CLIPS landers, the commercial landers that are going to be going to the surface of the moon. And one of them actually in next year is called Blue Ghost, which is being done by Firefly, and we have a lunar experiment on there, similar to what we did on for AMSAT Oscar 40. We're doing the same thing to fly around the moon and understand how well that will, how well GNSS can be received in and around the lunar environment and on the surface. So there's a lot of missions, and people are trying to get on those missions, including AMSAT and ARIS. And I know, and let me just say, AMSAT North America and ARIS are working on things, but there are people all around the world that are working on things. I've had a high school student that wanted to build a satellite, or a voice repeater, and put it on the surface of the moon, and he wanted to do it on 2 meters. So let me just say that, and we'll talk about frequency spectrum in a few minutes. So the challenge, one of the biggest challenges we have here is there's a big deal with the radio astronomy community that when you're on the backside of the moon, you don't have any of the Earth signals anymore. And this is an opportunity of a lifetime of, humanity to be able to really utilize the backside of the moon and understand. I mean, we're all radio frequency folks. We always are interested in discovering things, and the radio astronomers want to discover things along with that. And so it gets back to similar to the national parks, how do you protect and preserve the opportunity to do that when actually the radio astronomers need to get their data out, so they need RF transmitters to be able to get their information out, and but at the same time to protect the opportunity. So basically what's being developed is a set of standards that can be applied to users and on how we can operate in and around the moon. And I will tell you, this is a pretty, we all know how passionate people are on radio spectrum. This is another area, and we even heard it, I will tell you, at this UN meeting that I attended all this past week. So the ITU has defined an area called the shielded zone of the moon, and the way this is basically the definition of it, and they want to keep a very low noise environment for the observations of radio astronomy. The question is, what can we do, especially if you're an orbiter on the moon? If you land on the surface of the moon on the side that is opposite of the far side, in other words, the near side of the moon, and I think everybody knows that the moon is basically in a gravity gradient stabilized orbit, so basically the one side of the moon is always pointed to the Earth, and the other side is not. And so it's the side that's not. There is no, even Pink Floyd says on their album, there is no dark side of the moon, okay? So there is no dark side of the moon. It's the far side of the moon. And so shielding the far side of the moon from radio spectrum is important. But one of the things that's coming up, and you see the highlight at the bottom, is that the spectrum above 2 gigahertz is reserved, I'm sorry, the spectrum below 2 gigahertz is reserved for radio astronomy. But they have interests in other areas too, and this has been a very complex dance, I'll say, between the organizations that are trying to utilize this spectrum and the radio astronomers. So this is an ongoing thing, and we all need to be sensitive to this and understand that some of this stuff might change. You notice at the bottom too that actually these charts were actually used by the folks for the meeting that I was talking about at the UN. So I'm giving full credit to the NASA. It's basically Kathy, well, Lou knows this. Kathy Sham is the individual that coordinates a lot of this stuff for NASA, and she's actually the chair of the Lunar Martian Spectrum Group. So the way they do this is through a thing called the ICG, and it's an organization that was developed similar to the ITU. That's an organization of the civil space agencies. When we started talking, and some of those that were involved in the ERICS activities early on, one of the first things we got told about flying on Lunar Gateway is, have you been to the Space Frequency Coordination Group, and are your frequencies coordinated? And it's like, oh boy, this is a big shock. I don't even know what a Space Frequency Coordination Group is, let alone, you know, how we coordinate with them. But then I found out that the person we'd been working with for 30 plus years on SAREX and ERIS was actually the same person that was from NASA that was doing some of this stuff. So basically, they are trying to work with the radio astronomers and try to, you know, develop the plans, the policies, and things like that to be able to, and with the ITU. And literally, they've been, Kathy was at the ITU meetings, and then in our UN meeting, at pretty much almost the same time, because they're preparing for the World Radio Conference. And then there's other liaison organizations that are involved. There's a lot, you know, these 4-letter and 5-letter organizations. Well, I think a lot of people know what IEEE is, but some of these other things, IOAG is basically an operations group within the space agencies, and things and CCSDS, I think a number of you know what that is. It basically, we're trying to, the Space Frequency Coordination Group is working with all of these groups to try to coordinate the frequencies and to make sure that radio astronomy is together. So there's a subset of the Space Frequency Coordination Group. It's been engaged for you know, many years now, but for about 18 years, 17, 18 years now, the Lunar Martian Spectrum Group has been engaged, and basically that handles both Lunar and Mars, as you'd expect. So, you know, this kind of shows, and let me just say, the amateur radio frequencies really aren't on this, but this shows the complexity of everything. You know, starting with, you know, lunar to Mars, I mean the lunar to Earth and Earth to lunar activities, and what you would do on the surface, because, you know, they're talking about things similar to a 5G type network on the surface of the moon. What could be done, what can't be done, and but basically these are all the frequencies that have been worked over time. And the big red one is optical. I mean, that's going to be the trunk line between Earth and the moon. Okay. And you know, depending on what they're doing, whether it's lunar orbit, lunar surface, you know, then we have these issues where NASA and other space agencies have been using frequencies for things like the spacesuits at 400 megahertz. And how do you handle that? Search and rescue right now is the primary frequencies at 406. Well, that's below 2 gigahertz. So how do you coordinate that? And, you know, they're working on frequencies associated with that. Some of them have been worked. Some of them are under study. And like I said, you know, at least one of the frequencies for lunar position navigation and timing is in the C-band area, 5 gigahertz, and that's a contentious area too to talk about for various reasons, including wireless. You know, the wireless community in the world, the wireless lobby, I would call it. So, bottom line is, what we tried to do was to look at the amateur satellite allocations that we have and work with the Space Frequency Coordination Group. And I'm going to start at the bottom because that's the part I want to focus on first. The other stuff I think everybody knows. When you talk about above 2 gigahertz, things are better. But I put the 70 centimeter and the 2 meter frequencies in red because really the only way we can utilize those is for contingency operations. And let me explain what that means. And I'm going to use the context of the Lunar Gateway as an example. I'll talk about ARIS and SAREX. SAREX and ARIS over the years have had the, I'll say, opportunity to utilize amateur radio how it's in one facet of what it's intended, when all else fails, to be able to support contingency communication. And we have been called up on and utilized on Space Shuttle, as Lou McFadden knows, we were called up on Space Station at one point. And there's been some incidents, you all know, even on Space Station, where there's been some problems. So it's a lot easier, when you're talking about Lunar, it's a lot easier if there's a problem to utilize the lower frequency bands from the perspective of using a whip as compared to a highly gained antenna if the vehicle is not in the orientation you want it to be in, and to utilize modes like FT8 or something like that. I'm using that as an example, but modes that we could send messages back and forth to the crew and be able to communicate with that. So basically the 2 meter and 70 centimeter band would be utilized for contingency communications, or as it applies in the shielded zone of the moon, okay? Which means that if you didn't turn the transmitter on until you landed on the surface of the moon and you're on the near side of the moon, you could utilize 2 meters and 70 centimeters, okay? But you would have to show that you would not be utilizing it, in that shielded zone of the moon. Okay, so I put that in red so you're all aware of that. The other things are very similar to what we do now. In other words, I'm using, QO100 as an example. We're using X-band basically for downlink, and S-band for uplink for QO100. We also have put C-band in here as a capability. So the C-band and the S-band would be for uplink frequencies to the moon, and then X-band would be downlink. Okay, and I can come back to this and again, but basically this is the crux of what I wanted to bring up, is that we need to. And so I've seen a number of. There's already been a couple amateur radio satellites that have flown that have used 70 centimeters. I think we're going to be good stewards of the frequencies. I think we're going to need to try to move into microwave and do those things in the future. We can't use it on the backside of the moon. Right now, there are no, as we speak right now, there are no stations set up to do radio astronomy on the backside of the moon, but China has already flown a vehicle and landed on the backside of the moon. We are getting very close to starting to do things with observations on the backside of the moon. So we can't, and we know it takes satellites a while to get there, and to be able to turn your radio on and off at the right time if you're in a lunar orbit is going to be tough. So I really feel very strongly that we need to prevent utilizing our 70 centimeter and 2 meter bands for those types of operations, except for the thing I talked about, which I'll go back to that student that wanted to put a repeater on the surface of the moon. Well, if you do exactly what I described, which is you don't turn the thing on till you land and it's on the near side of the moon, that's doable, okay? So I just wanted to, my closing slide was just to show you what we've been planning relative to the ARIX or the amateur radio exploration activity, for Lunar Gateway, is using X-band for downlink capability and C and S-band for uplink capability. And on the right side there, you can see 70 centimeter in there for contingency comm. Okay? And that's all I have. So any questions or comments? Yes, Nick. Hold on.
What size antennas is it going to take to hear your station?
Oh, on the ground?
Yeah.
Well, that's a function of how much power we can do, okay? So, you know, Kent has been working with us on the ERICS activity, and he's come up with some gained antennas on the vehicle. You know, trying to put a lot of microwave out is a challenge more from a safety perspective of the crew and us making sure we don't cause a problem there on X-band. But, you know, what we were taught, we have different scenarios that we could fly. Some of them would use big dishes. Some of them would use dishes on the order of about, you know, a meter, basically 2-meter dishes. Okay?
Got it.
Okay, so part of it can be like, as you see on the right there, you know, we could use big radio dishes like Bochum or Goonhilly or Gavert for things like if we need to do emergency comm or as a telebridge station. As we learn more, as we find out how much power we can utilize and how much power we can pipe out of whatever we're flying, we'll define what size dish we would use. Is there another question? Yeah,
Frank, you sort of reflected on it already, but what is the status of Lunar Gateway and the amateur radio involvement with it? Can you give us a quick summary of where things stand?
Yeah. All right. So I'll go back to that one chart, and I got to find it. It's like this is an eye chart. I understand that, but if you look at, let me see if I can do it here. 2027. See here. 2027 is when Gateway becomes our operational. Okay. The first they went through a process, and we were in the process of the first payloads they fly, and they were very limited. Actually, they didn't even have their interface documents done. They were very limited in what they could do, and they basically ended up selecting 2 payloads, which are radiation and ionospheric measurement, space weather type payloads, primarily because it affects human factors. You know, basically the astronauts and cosmonauts that would be flying to the moon area. So they started with that. They've been working through, because actually one of my jobs is to be in the Gateway and the Artemis meetings once a month. They're gotten very mature with their interface documents, and they're starting to come out with requests. So we're getting closer to this. They are still very interested in us. They haven't thrown us away. We have to keep, you know, it's like business development. You got to keep asking and talking and things like that. So that's what we're doing. I will say that I will say this, and this is for the whole community, and you know, this is something we need to think about. There are opportunities on Artemis flights for orbiters, and so if you all really, I mean, but the problem is, and it was talked about yesterday, we need propulsion on these systems. So you know, golf is a start, but we need to get it to the point where we have some propulsion on them, on those vehicles too. So there's that, and then there's Gateway. So we're trying to look at all, and I'll say both ARIS and AMSAT are looking at these things together, because you notice the pictures, all of these charts have both AMSAT and ARIS on there. We need to work together on this if we're going to make this happen. And I think, you know, we're still out there for it. And for everyone's understanding, our best opportunity is for us to be on the logistics modules. The logistics modules come up. They spend it's about 6 months at the Gateway and then go away. But what we'd like to do, and one of the things we were talking about, is we could fly an antenna system that would be on each one of the logistics modules and have our hardware system available, that we could pull it away from the logistics module, keep it inside Gateway, and then integrate it back when the next logistics module is. So we're not spending all the money on the radio systems every time, but the antennas we would have to fly new ones every time they flew. Does that answer your question, Gary? Barry, I'm sorry.
At this point, you're talking about the next decade before anything.
Well, no, I wouldn't say the next decade. 2027 to 2030, I would say, is probably the time frame we're talking about. But let me just say this. There's opportunities right now. I know this. There's opportunities right now in Artemis 2, which is going up next year. But, you got to have something ready to go. Yeah, and you don't have it right now. So this is the challenge. I mean,
The Lunar Gateway you're talking about in 2029, 20 plus.
I think 2028, 2029 is a good area for us to be working towards for Lunar Gateway. We're not going to be on right at the very beginning. We weren't right on the very beginning on shuttle either. So, and it's going to, as time goes on, it's going to be more challenging. I'll also say another area where, which are opportunities, and we're looking at them very carefully, are the landers, the human landers. And for those that aren't familiar with it, the two major ones out there are the SpaceX Starship and Blue Origin's Blue Moon vehicle. And so those two have been selected by NASA as commercial organizations to support that. So those are opportunities we need to be looking at too. Any other questions? And I know I've already seen we got 4 minutes.
Maybe a dumb question, but couldn't the bird just listen to noise originating from Earth to decide when not to transmit in that exclusion zone on the far side? Kind of like the Apollo missions when they went to the dark side?
That's an idea. Yeah, that's an idea. But remember, if I go back to that shielded zone of the moon, it is before, well, it's the last third of the moon, okay?
Okay.
So, and you're not really behind the moon until, it depends on where your orbit is. You're not
So you wouldn't be in radio shadow when you might be interfering with
exactly.
Exactly. And also, do you happen to know if the Lagrange points would be satisfactory, like L4 and L5, which would they interfere with the far side exclusion zone?
Well, let me just say that the two main Lagrange points that the space agencies are looking at and commercial folks are looking at are L2 and L1. L1's on, of course, on the near side, and the L2's on the far side. The Lunar Gateway's in the L2 region, so that's another reason why we have to is no go. We did 2 meters and 70 centimeters are for contingency only, and like I said, 406 actually is they're going to be transitioning search and rescue over from 406 to 2 gigs. Yes, Burns.
Yeah, so I'm wondering about the 70 centimeter stuff that you talked about being contingency ops and having to prove that it was a contingency. Do you only have to prove it was a contingency if you transmit in the restricted shielded zone, or would you have to do that anytime? I mean, you were talking about a repeater on the surface, for example.
Well, yeah, the repeater on the surface. Yeah, I understand what you're getting at, and that's exactly what Calvin was trying to bring up earlier. Is if you could figure out where you're at, then you could turn it on and turn it off.
Oh, so it is possible to use 70 centimeters as long as you're not in the...
It is possible,
okay.
But you better have a foolproof system to
Got
be
it.
able to, and that's could be an issue. Yes. Go ahead.
Hey, yeah, Frank. I have a presentation this afternoon about non-AMSAT amateur satellites, and one of the ones I'm going to mention is Lunar Oscar 2 from the Harbin Institute of Technology, which is going to use 437 megahertz, and it's going to launch with the Cheney 6 mission next year. So, that's obviously it's not going to protect the shielded zone, but that's one upcoming mission where 70 centimeters will be used, and it will have a digipeater just like the last one they did back a few years ago.
Yeah. So, and this is where we've got to be, and I think our spectrum, our satellite spectrum folks, I really would encourage you to specifically for the amateur radio satellites, work this and make sure that we don't have these kind of problems, because it'll give us a black eye And I think you all know we're very close to losing, 1.3 gigs because of the problems. So I'm not saying we are, but when it's at the level it is in the World Radio Conference, it's a concern. So we just need to be good stewards of the spectrum that's out there. Thank you.
Thank you very much, Frank. Every time I see Lunar Gateway up there, I get excited. I'm lucky enough to write some software that runs on the propulsion module on the back end of that thing. So we'll try and make sure you get nice DC power out of it. Next up, we have amateur satellite secondary payloads from our VP of Operations and a Board of Director member, Drew Glassbrenner. And I've got to fire up his presentation here. Hang on.
Push to talk. There we go. If you're of a certain age, you'll recognize this as a generic presentation. This means I finished it this morning to fill a gap. So I wanted to point out that I see this more as a discussion. The idea here is I'm also on the IARU Satellite Coordination Panel. So anybody that coordinates their satellite, and that should be everybody, I get to see what frequencies they're using and what their missions are and whatnot ahead of time. And often a lot of these are educational-based satellites. Some of them aren't even really amateur. They're Part 5 using amateur spectrum. And quite often we have the opportunity to nudge, drag, pull, push, shove satellite builders into having an amateur two-way secondary payload. So when I say secondary payloads, I really mean two-way secondary payloads. Let me figure the mouse out here. So just for this discussion, I'd like to define secondary as either a hosted payload on a satellite belonging to a separate entity, and we've got lots of examples of these in the history of amateur satellites. Just a few of them off the top of my head. RS-12 and 13, 10 and 11 for that matter, were Russian payloads hosted on Russian geodetic satellites, very large satellites, which was good because those used 10 and 15 meters and had plenty of room for a big antenna. AO-27, the repeater on AO-27 was a secondary payload on a satellite called ISAT. PCSat-2, I think you might be able to define as secondary, got stuck on the side of the ISS for a little while. SO-67, Sumbadilla satellite, maybe some of you guys remember that one. It was an FM repeater payload on a South African telescope, Earth observation satellite, telescope but pointed down. And probably the most well-known one now, at least in certain hemispheres, is QO-100, which is a secondary payload on a TV satellite. So we've got a long history of those. Another version of a secondary mission, by my definition, and I'm talking so I get to define it, is the use of a satellite, either command and control or telemetry radio for a two-way mission that is secondary to the primary mission of the satellite. And we've got some more recent examples of these. Some of them have become very popular. There's a French university that has now launched, or French organization has now launched two satellites that have space weather sort of primary science missions, but they're educational, UVSQ-SAT and Inspire-7-SAT. Both of those use the ISIS space crossband command and control radio, which happens to have the option, if you choose it when it's ordered, to operate as a VHF up, UHF down FM repeater. So, and both of those have run those repeaters. Probably the most notable one of this subclass of secondary missions would be IO-117 or Green Cube. If you haven't heard about Green Cube, let me tell you, you're missing out. This was a 3U Italian satellite, educational satellite, that was launched on a Vega launch. The primary mission was a big reflective mast ball, basically, and it was a follow-on to a previous mission where they tracked it to be able to do optical observations as to rate of decay. So the interesting part is it went to a MEO orbit. It's at 6,000 kilometers. Typical LEO these days are 550, 600 kilometers. ISS is 400 kilometers. So what that does is it takes your footprint from half of the U.S. to half of the hemisphere. And since this is a generic presentation and images are extra, you'll have to look that up on your own to see the footprint. But it's impressive. Personally for me, from Florida, I've taken my DXCC count from 110 to 138 based on this satellite. So it's something to take note of. And the secondary mission on that was done at the suggestion of IARU. So we can make an impact in getting these missions operational. So benefits of a secondary mission as opposed to a primary mission where AMSAT or another entity builds and launches and operates their own individual satellite. With secondary missions, a hosted payload lets us focus on RF. Yeah, we still have to do some thermal work. You know, it depends on what we're flying on, but we're not worried about attitude control. We're not worried about propulsion. We're most importantly, and growing in importance, we're not worried about orbital debris. That is the main payload's problem. We're just a little barnacle hanging on. So we go where they go, and they have to do all that paperwork. Could be simplified operations. I've been the command station for several satellites, beginning with AO-51. 51 in particular, I basically was on it every day, every other day, adjusting the power levels. That was the big thing, to maintaining the satellite, uploading schedules, changing modes. A hosted payload or a secondary mission payload could have the benefit of, hey, we're going to turn it on and we're going to turn it off. And if we can't turn it off and something happens, then at the other end of that power line from the host satellite, they turn it off. So there's a little less responsibility and a little easier go of it. So what benefits for the host? The host can benefit from a backup telemetry source and possibly a backup command capability if the primary mission aligns with the amateur satellite service. So what we can't do is fly a amateur radio payload on a commercial satellite and use the amateur radio spectrum to do anything that would have pecuniary interest with that satellite. But if a university is flying a satellite and they've got their radio on one end of it, say it's a 3U or 6U or something like that, they've got their radio that they're using for their telemetry and their command and control, and we're on the other end of it, and we have access to their IHU, to their computer. If something goes bad with their radio, they have the opportunity to use us as a backup, to send a fire code to reset, to get telemetry down, to do, however you set it up. The important part is that the primary mission to do that has to align with the amateur radio service. So no commercial backdoors. The host can benefit from a public relations boost if we do something STEM related. The host isn't really going to get a whole big boost just because a bunch of gray-haired guys like us want to talk to each other through their satellite. But if we do something innovative and something that involves the kids and gets some sort of STEM boost in there, like what Frank was talking about earlier, that's a public relations boost for our host. So that's a potential benefit. With benefits, there's always drawbacks, or as some people like to call them, challenges. We have to convince the host, are we really worth the hassle? There's extra work that has to be done to integrate a secondary payload. There's, in some cases, mass equals propellant, and the more mass they're carrying, the less propellant they can carry for station keeping. I'm talking like a GEO sort of hosted payload, and we're definitely cutting into the bottom line there. Or perhaps the payment's sufficient to get them to overlook that. Schedule. Schedule is probably the biggest challenge of all of these. Commercial space these days runs very quickly. In the past, when we launched some of the first Fox satellites, we had 1-2 year lead times between the time, I'm talking in particular the two that we launched with Space Flight Services. We signed the launch contract and it was a couple years before we were getting to launch. These days, if you've got the money and you've got the license in hand or can get it in hand, you can call up and get on a transporter launch and they'll integrate you about 30 days before launch, sometimes less than that. So if you find an opportunity, you have to be able to jump on it lickety-split, or you might be waiting for the next one. Of course, we're not paying the bill, so we're going to have lower priority with regards to power. And if power is a problem, we're going to have lower availability with regards to scheduling. Are we going to be able to be on all the time? If we have to have our host do anything for us, you can bet we're going to be at the bottom of the list. So that could be a challenge. Reusing command and control radios for a secondary mission has a whole extra set of issues. And I'm going to talk about a little bit of inside AMSAT baseball, and maybe Jerry might want to put your fingers in your ears. It's pretty well known by now that the Fox satellites shared, our command uplink was also the user uplink. So that's fine when you've got a command station like me down in the corner of the continent in Florida, and most of the time I'm looking out over ocean and maybe Puerto Rico and a couple of Caribbean stations. But it can be a real problem if you need to send a command to your satellite and all the amateur radio guys don't realize that the transmitter's off and they're all jamming your uplink trying to work a new grid square. That's a real problem. It can be overcome. You overcome it with gain. You overcome it with watts, late nights, and like I said before, having a geographic advantage and doing your commanding when nobody else is around. So just some typical secondary payloads. There's possibility for other things, but these are the three that we see most often in the order that we see them. Digipeaters, FM repeaters, and transponders. Sometimes you'll see people call an FM repeater a FM transponder. I like to keep it simple and use different words for different things. A digipeater or a store and forward system, I lump those together because usually if you have a store and forward system, it will digipede also. A lot of times with the IARU work, we see these proposed as using the command and control radio. So you're tied to whatever format they're using. And there are a whole host of people building radios for CubeSats. And they run the gamut from very sophisticated and very flexible to something that looks kind of slapped together off of something you found on the internet. And they sell these. So a lot of students end up, student organizations and universities end up with a whole spectrum of radios and formats. So a lot of times you get something that's not common in the amateur radio community, you know, 2 GFSK, something that we don't see a whole lot. You know, we're kind of set in our ways with 1200 baud AFSK and G3 RUH or GMSK 9600 and higher. That's what we like to see because that's what we all have equipment for. But a lot of these digipeater missions don't use those. So another one that we see quite often is, again, leaning on the IARU experience, is that you'll see a mission that proposes a 9600 baud or a 19.2 downlink or sometimes even higher, and you get down to the section of the coordination application and there's what's your ground station? Tell us your ground station and show us that you've done a link budget for your ground station. And in the ground station they'll have listed ICOM IC 9700. Well, as anybody that has a 9700 that's tried to work digital knows that it doesn't do 9600 baud. It's not supported. Why ICOM did that, I don't know. It barely does 2400 baud. Green Cube recently ran a few days in 2400 baud, and it would receive it fine, but you were lucky to have enough bandwidth to get that 2400 baud signal through without getting clipped at the edges and decoded by the satellite. So if you want people to use your digipeater, and typically when we're sending digipeater messages, it's, you know what, 20, 40, maybe 60 characters. Do you really need 9600 baud to swap a grid square or a high or whatever? So that's a consideration to take into account with the digital secondary missions. Luckily, we're not all tied to hardware TNCs anymore, and we haven't been for quite a while. I'm going to mention UZ7HO. I've never met him. I've corresponded with him. He writes some awesome sound modems for free. He puts them on his website. You download them, and suddenly you're working this, excuse the expression, weirdo modulation format. And then he even a lot of times has clients for the other end of it, so to put your messages in. So it doesn't have to be complicated. It can be, but we have solutions now. And IO117 is the best example of that. When that was launched, the prescribed method of generating a signal for it is GNU radio. And as I expressed at some point in the last day or two, I'm a geologist. You know, I passed the first calculus class, and that was it. So GNU radio is tough, especially if you're not running it on Linux. It's tough. But UZ7HO wrote a beautiful sound modem for it, and now there's hundreds of users around the world on this satellite because of it, and it's easy. So along the same line of thought, the popularity is directly proportional to how common the format is. If you want a lot of people to use your secondary mission, use a commonly available format. And the other direct correlation to popularity is orbital height. With IO117 at 6,000 kilometers, it's the highest thing we've had in a long time, not counting the Lunar mission, and it's great. And I guess you would say the reverse of that is if you're with an organization that lucks into a high orbit launch or a medium orbit launch, reach out, put something on there. You know, that is a scarce resource. Take a quick drink here. The second most common secondary payload we see is an FM repeater. There's also a long history of those, like I mentioned in the beginning, 2767. PO101 is a Filipino satellite that has a amateur radio unit on it. It's active just about every day via schedule. It's a great satellite. Very popular. You may have your own independent feelings about FM repeaters. You cannot deny that they are popular because they are jam-packed no matter what time of the day. We could put 100 FM repeaters up and they would still be jam-packed all of the time. There was just a launch of 8 FM Israeli student satellites, the Tevel series, and they all have FM repeaters on them. They're all in the same orbit stretched out, and they're busy. Very, very busy. There are 2 or 3 or 4 of them on at a time, and there's always somebody there. Repeaters can be the command and control radio, like the UVS CubeSat and Inspire 7Sat, but they can also be a separate radio like AO27 or SO67. That's going to allow the operator to run it more often, not always have to be on a schedule. The schedules are kind of difficult to get the word out because people expect it to be on. Maybe, to borrow a phrase, a low information user might not know that it's on a schedule and might be disappointed that they can't hear it or can't access it. So if you have a separate radio and you have enough power, that generally takes care of that. You just run it 24/7. But the other side of that coin is that if you're using the command and control radio to run your secondary mission, it's already there. It's a free. It's bonus. You know, it's do not collect $200. So the ISIS space radios are the ones that are quite often used for that. They sound very good. They work well. There's a few issues. They use a RSSI-based access, so you have to have a certain signal level to get in it. And depending on where that signal level is set, that may exclude some of the smallest stations, but it also saves power for the satellite, so that can be important. But you have to ask, you have to click the box when you order it to get that repeater functionality included in it. Back to the schedule, ideally it's on 24/7, maybe it's on part-time until the primary mission's done, and then it's turned on 24/7, but that works the best. Access, either via a carrier-operated system or an RSSI-based system. Sometimes they use a PL system like we did with AO51 or SO50. That works well, and that keeps it from broadcasting to whales and penguins. So not as common, but certainly have been some out there, and certainly will be more in the future, are the transponders. Transponders as secondary payloads, again, the Russian satellites were probably the ones that a lot of us cut our teeth on because they were easy to hear and we had HF equipment already. UCube-1 carried the FunCube-2 transponder. That was a secondary payload on that satellite. I particularly enjoyed that one because I worked my last grid in the United States on a 2 AM UCube-1 pass, so I was glad to see it was there. HuskySat carried HuskySat-1 carried AMSAT LTM, the linear transponder module. That was their primary radio, but of course the transponder on it was a secondary part of their mission, our primary mission, but their secondary mission. And the next one to launch with an LTM is MainSat, MESAT-1. Should be coming up pretty soon. It's been manifested, launch. Yeah, it's up to Firefly at this point. Firefly had some issues, so they're doing the prudent thing and taking a good look, making sure they don't blow another one up. And the most famous is QO100 with both a narrowband and a narrowband transponder for sideband, narrowband data, and a wideband transponder for really cool things like digital ATV. And that's hemisphere-wide coverage on a TV satellite. Unfortunately, it's not our hemisphere this time. So, conclusion and some editorial opinion on my generic presentation. Long history of amateur radio as secondary payloads, as orbital debris, collision avoidance, location reporting, and other issues become more complicated to manage. Perhaps additional focus on secondary opportunities would be fruitful. That was as kind as I could write that. Ready off-the-shelf payloads, easier said than done, but are ones that are easily adapted to the host power and space requirements enable us to do this more efficiently. And also, I'm open to ideas for other payloads. We've got another 5 minutes, I think, so I can take a couple of questions or ideas or discussion.
That's right. We have your first question back here.
Hi, Drew. This is a question with respect to what Frank was talking about with the SFCG and the protection of frequencies on the moon. I'll start over. Dovetailing back to what Frank was talking about with the protection of frequencies on the moon and especially in the amateur 2 meter, 70 centimeter portion, do you think that IARU would have any part in that as that starts to become laid down in the approvals?
So
for coordination?
It's definitely an issue. I'm a panel member. I'm the guy who collects the carts out of the out of the parking lot and mops the floors after the business is closed as far as IARU goes. I will bring it up and discuss with Hans, the satellite coordinator. We have coordinated 3 lunar missions. One has launched and is now complete. The other one, I don't remember if it was a launch failure or a satellite failure, didn't launch at all. And then there's the third one that Paul mentioned, the Lunar Oscar 2, which was coordinated a few months ago, I think it was. So we're going to bring that up. I'm going to bring that up to Hans, and we're going to discuss it, and along with the panel. And we will certainly reconsider our how we handle lunar coordinations off of that. Any other questions, ideas, comments? Rotten Tomatoes? Awesome. Thanks.
All right, thank you. There we go. Thank you very much, Drew. Appreciate that. Next up, and we have just a little bit of maneuvering to do up here. I think Frank's going to load a presentation. We have an update from our friends across the pond. We have Mr. David Bowman, G0MRF from AMSAT-UK, and Mr. Michael Lipp, and you are HB9WDF, I don't know that one as well, from AMSAT Switzerland. So I'll let you two arbitrate as to who goes first. Please welcome Michael.
Thank you. Okay, you're good to go. Thank you and good morning. My name is Michael Lipp, HB9WF. I'm representing AMSAT-HB from Switzerland. My challenge is to hold a long talk. That's the longest I have at that. For you is the challenge to understand my Swiss accent, so I hope that that's work. About me, I'm ham since 1995, active on satellites since 1996. And from my profession, I'm working as a department manager for a Swiss retailer, responsible for about 80 employment. I'm married with my wife, HB9WDE, and I'm also an enthusiastic scuba diver and underwater photographer. So this hobby with scuba diving brings me around the world to several islands, and I'm also QRY on the Q100 station. You see me at the right on the Maldives as AQ18 Queen 7 Alpha Oscar. In the middle, I was on Gozo Island, and at the left, doing some rowing here in the United States. It was also amazing. Last year in Arizona, this year we were in the eastern part of the US. It was amazing. And at the bottom, it's my station at my home. So when I go out in the nature for SOTA activation, I have a portable station with me. And you can see this is a modular station with two FT870s. And there is also an Q100 setup that I take with me when I go to the islands. And there is a 40 centimeter dish, 40 centimeter dish for Q100, what I need. So let's talk about AMSAT-HB, AMSAT Switzerland. We started in 2016 as a group interested in amateur radio satellites, and we founded the organization in 2021. So the last couple of days, somebody told me the AMSAT North America is a small organization, about 4,000 members. So yeah, we have in Switzerland 40 members, 4 international members. One is from NA, North America, from Canada. And we had 2 SAT projects, 2 not our own SAT projects, our SAT project we had supported. But our members were in several missions involved in Q100 or in Astrocast and also on SwissCube. And we are also participated at more than 6 ARIS school contacts in HB9. So that was the day where we founded the AMSAT-HB. Some people maybe you recognize here on the screen. On the left is HB9 0 Kilo Alpha, Thomas. Thomas is very active in the AMSAT forums and AMSAT builder boards. He is responsible for our treasury. Right to him is Wolfgang, HB9 Romeo Yankee Zulu, is our vice president, and very active on Q100 and IO 117. In the middle, there is HB9CQK, Frederick. Frederick was very active on satellite in the 90s and had full automatic ground station for PACSAT. Right to him, that's me, it's not so important, but on the next is Achim Vollard. Somebody of you know him very well. It's Delta Hotel 2 Victor Alpha, or HB9 Delta Uniform November. He was involved in Q100 project and also on P3E project. Then very important is Martin Klapper, HB9 Alpha Romeo Kilo, is responsible for our technical stuff. And on the right side, you see HB9 Mike Fox Lima. He is still commanding the SwissCube satellite. And in the background, this is not a still picture, there is Delta Bravo 2, Oscar Sierra is also involved in the founding of HB9, of AMSAT-HB. Yes, and that is for Alan Johnson. We have also our CubeSat simulator. We do that also, and yeah, that was a picture on the Friedrichshafen at the ham radio fair, and we had a lot of interesting people coming around to our booth and watch the demonstration of this tiny satellite. On the right picture, you see HB9 IRM, Mario. He did more than 4 ARIS school contacts, but this is not an ARIS school contact, this is a school contact with Antarctica. We spoke with, not Mario, I forgot his name, sorry. We spoke with him in the station in Antarctica via Q100. And you know, when you do an ARIS school contact, it's about 10-15 minutes, then it's over. Such school contacts with Antarctica have a duration of about 1 or 2 hours, so you have plenty of time. And it's very exciting to do such school contacts to the Antarctica. And yeah. There is also a picture from the ham radio with the CubeSat simulator here. We do also several presentations to the clubs around in Switzerland. We have the USCA Academy, that's from our amateur radio league in Switzerland, and academy. We do some education there. There is also a picture from one of our last ARIS contact in Lunar in central Switzerland. So we have some special activities from our members. There is on the left HB9 Golf Whiskey Juliet. He's right now on the expedition to Tango Oscar 8 Foxtrot Hotel to Mayotte Island. Unfortunately, is stopped tomorrow, this activity, so I have no chance to take them on Q100. He is very active on the expedition. On the middle is HB9 Romeo Yankee Zulu, Wolfgang. He has the highest remote station in Europe. It's about 5,500 feet above sea level. And he does expedition also to Sierra Victor 9 and Crete Island. And on the right, maybe you know him. This is Andreas Spiers, Hotel Bravo 9 Bravo Lima Alpha. Andreas is a YouTuber. He has 2 YouTube channels. One is called HB9 BLA Wireless with almost 27,000 followers. And he has another channel named is Andreas Spiers, is for the maker scene, and there he has over 430,000 followers, and he does some great stuff with things in the maker scene. One of our first project was with the AFCOM. We have a strong regulation in Switzerland about 13 centimeter. We can't use it without a special license. You have to buy a license about $70, and this license is only for one QTH you have. When you go to portable, you have always to call the Ofcom and get a new license. So that's very difficult. We have they are a little bit scared about interferences in Bluetooth, in Wi-Fi, and so. So we did this year a field test with Bluetooth devices, with wireless devices, and you see my portable station, and I put it over 1,000 watt ERP, and in front you see a Bluetooth speaker, and here in front a Wi-Fi device. Yes, we had a little bit problem in the Wi-Fi, not in Bluetooth, in this distance to the device. That works. We did some other field tests. We documented these tests and get it to the Ofcom. It's in these days, I don't know what happened now, but we're hoping is that we get better access to the 13 centimeter band in the future, so that we can also do the portable activities in Switzerland. We have also support for a huge space mission for us. It's a huge space mission. It's a student group from ETH Zürich, it's Hochschule Zürich, or Institute of Technology in Zurich. It's a public school, public university. The group is called ARIS, and not the ARIS with two S's, only with one S. It's Akademische Raumfahrtinitiative Schweiz, or called in English Academic Space Initiative Switzerland. They have sounding rockets. They build a lot of sounding rockets, and they work very well. But there is also a subgroup they called SAGE, Swiss Artificial Gravity Experiment. It's a science mission for cancer research. And on this mission will be fly also a linear transponder. There is the prototype of the linear transponder board. It's not fit in a regular CubeSat standard. It's just for the proof of concept. But that is the first plugin that they built. So we were involved in the reviews of this project, and it works very well. That's our job in this mission. We don't take credits for the satellite or for other things. We are only in the review part of this mission. So, but this this works very well. We had, for 2 weeks ago, an exhibition in the museum in Lucerne, the Swiss Transport Museum. It's called the Air and Space Days in Lucerne. We had a great booth. And there is also the guys from the RSH team with their CubeSat and the sounding rockets here called Heidi. And there's also, again, the CubeSat simulator. And we had a lot of folks there. They were very interesting in our booth, and the medias were also there. It was a great success for us. We got visit from astronaut Claude Nicollier. He flew 4 times with the space shuttle. He was involved in 2 repairs missions for the Hubble Space Telescope. And there is HB9 Alpha Romeo Kilo, Chantal Wotley from the RSH team, Claude Nicollier, and Olivier Stalder also from the SAGE team. They are all in the club from the University in Zurich, from HB9 Zulu, but they don't have an amateur radio call sign right now, but I hope they work at it. So Drew told me, hey, say something about Q100. So I think Peter Gulshoff talked a lot of Q100 in the past years here at the Symposium, so I think it's a little bit boring when I talk about the same. I know, hello Peter. Peter is watching there on the YouTube channel, and a lot of other members of AMSAT-HB. I will talk about Bochum. I'm also a member of AMSAT Germany, and Bochum, there is always the AMSAT Symposium of AMSAT-DL. And I will say, go to Germany, visit Bochum. This is an amazing place. There is the Radom, is a technical monument, an industrial monument in Germany. And you have this great dish, 20-meter dish. There is also an exhibition around in this Radom, and you are in contact with all this stuff, and you see a lot of amateur radio history there in Bochum. I was several times there, and I'm still amazed when I there in this Radom, and yeah, that's Peter. This is in the control room. There he watched the telemetry signal from the Mars, one of the Mars missions. I don't remember correctly which is far, but yeah, that's amazing. When you are there, mostly they watched some NASA missions And it's amazing when you see this data coming from light years, not from light years, but from Mars or so. That's really amazing. I think it's a video, yeah. So, hi, Peter. So that's a telemetry. You see the frequency, and then behind the dish, the huge dish, the old consoles, but they still use it. Yeah. Let's see the live data from the dish. There is also the Lila ground station with the beacon for the Q100. You can also watch this live there, and it's very, very interesting to be there. And that's my last slide. There is the frame from P3E. You know, we had this project, and it's still there. The frame is there with the space frame, and yeah, not flying yet. Okay, that's all what I have to say. I hope you had it all to understand. Thank you very much.
Thank you very much, Michael. We're going to have some questions at the end for these two, but just for right now, I think we're going to have Mr. David Bowman come up and provide an update for AMSAT UK. So a warm round of applause, please. You're on.
Okay, thank you very much. Very good morning to everybody. Lovely to be here in Texas. I think my body clock is just about adjusted. And thank you very much for a very interesting trip out last night to a Texas steakhouse. Don't get many of those in London, I can tell you. What I'm going to talk about for the next few minutes is amateur satellite projects with a European perspective. This will be highly biased towards AMSAT UK's next mission, but we'll also take a look at the end at some interesting things that are going on with geostationary possibilities, which I'm hoping will generate some interest here in the room. So let's have a look at a little bit of recent history from AMSAT UK. In the last 10 years, we've been involved in these 6 missions. Some of these, hopefully, will be fairly familiar. We've got AO-73, our first CubeSat launched in 2013. Still operational in space, just coming up to its 10th anniversary in November. 1U CubeSat, designed, built, funded by the UK and our partners in Holland. And at the moment, it's done 9 years without a hiccup. Around October last year, it developed an issue with its power supply system, whereas instead of charging right up to 8.3 volts on the batteries, it's now charging, for some reason, up to about 7.8. So at the moment, we've taken off the transponder, and this is flying educational telemetry in sunlight. And we always put something in there to detect eclipse periods for power saving. And at the moment, it's in receive only when it flies into eclipse. If you want to save batteries, it's really that depth of discharge in eclipse that kills them. We usually run this at about 6% depth of discharge, and it's still working 10 years later. Working quickly around the screen, based on the success of AO-73, we had a payload on UCube-1, a mission from the UK Space Agency, 3U spacecraft with deployable panels. That was a 1-year mission for the Space Agency, and our transponder on that ran for about 2.5 years after end of mission. ended up with a probable battery failure. It was one of those thin lithium polymer battery packs, and we've got one piece of telemetry that shows the battery temperature rapidly going up, and then that was the end of the satellite. So, you know, probable cause, I guess that something happened to the battery there. EO79, sort of a thank you from the von Karman Institute. We had just a transponder on that, no telemetry of any sort. It flew a couple of sensors they wanted to check, and because they were launching a lot of satellites using amateur radio frequencies, they said, okay, we'll provide you with space for a transponder, and we took advantage of that. EO88 just re-entered, launched at 500 kilometers, so an important figure. 500 kilometers, lasted 6 years. It re-entered earlier this summer over the Pacific, just off the California coast. I've got the most amazing piece of telemetry there. Someone was recording it on SACNOGs, and if you look at that picture, you can see the temperature rapidly increasing as it came down into the atmosphere, 91 degrees before it failed on the external surfaces. So that was quite an interesting one to capture. JO97, a mission with the Jordanians. That's still in operation, still in transponder mode in Eclipse, so that's very good. Oh, actually, it's transponder mode the whole time. And one of the two missions we've had at the end there with the European Space Agency Education Office, ESSEO, talk a little bit about that in a moment. So after all of that, we can have a quick look at the experience we've gained, the lessons we've learned. And as you can see there, we've got a summary of the mission duration. AO73 still active. UCube-1 failed probably from a battery failure, 3.5 years into the mission. EO79, the von Karman Institute 2U satellite, ended up with a negative power budget. Because of the limited amount of things we were flying on that, we had no way of correcting it. There was a great deal of effort from ISIS Space in the Netherlands to come up with some new firmware to switch it on for limited periods of time in its orbit so it could charge. But unfortunately, there was so much work doing that software updating. It had about 6 months of operation and then finally died because of the negative power budget. EO88, very successful, not a hint of trouble for all 6 years. Real shame to see an active amateur radio satellite burn up in the atmosphere. We've got to be careful where we put these things. There are a lot of investment. We really need to get them up just a bit higher than that so that they can last the full duration of the components in the satellites. JO97, still working. Microcontroller failure on that one, so no telemetry, transponder only. Nice thing about most of these designs is we always try to put something just above the microprocessor controller, so if there's any trouble with the control systems in the spacecraft, we've got the ability to have I think it's a CPLD from Xilinx on all of these, so that if the digital side of it goes down, we can send a command to effectively a hardware decoder, and we can switch the satellite into different modes. So a microcontroller failure doesn't mean end of mission. ESA education, oh dear, mission duration, 0.041 years. That was about 3 orbits. They make great t-shirts. So what have we gained from that? Well, if you add up some of the parts that have flown successfully and have not failed, we've got a cumulative total of 23 years on some of those parts. So we know what works really well, but it has failed, and we know a few things that we wouldn't do in the future. Which brings us to, I think, our next project. This has gone through a bit of a revision. About a year ago, I did a presentation in the UK for FunCube Next. This started out as a 3U structure with a lot of interesting payloads, and in the intervening year, we've rationalized some of that. We've decided that what we've got left will fit quite nicely into a 2U frame, and so going forward with a potential launch date around mid-2025, we've got something that we've christened FunCube Plus, so something a little bit between FunCube Next and the original missions. So let's have a look at the details. This is what we're actively working on now. 2U will give us some more DC power above the usual 1U CubeSat. We've got 3 basic amateur radio transponders scheduled at the moment. We will probably add something a little bit more adventurous. Educational outreach telemetry in our normal format on 2 meters at 1200 bits per second. We'll probably change the data format. We've been using something designed by Phil Kahn many years ago for AO40. We speeded it up. It's really very good. I heard Nick in the front row here saying his SlimSats were going to run 50 milliwatts from orbit. We can quite happily receive 30 milliwatts from orbit at 1200 bits per second. So Nick, you really shouldn't have any trouble with that power budget. Really looking forward to that project. To keep our techies interested, and that's always a challenge, as I've found out over this week, we're going to put a camera module on. Not quite sure of the angle of that, but 6 to 10 megabyte images should be available from that. We started off looking at an X-band, but we really haven't made enough progress on that to see that as a potential success by the delivery date. So we've scrapped the X-band system. We've got attitude determination and control, but only course, so we can stop the thing spinning up. We can point it roughly in a direction, but this is by no means 3-axis pointing, but nevertheless it will give us some control. We want to separate the housekeeping and the processes used for the various experimental payloads on board, just to make sure there isn't a single point failure risk there. And we want to do something like fly your code. So the experimental processor on board will be able to be reprogrammed with stuff from the ground. If somebody wants to make use of all of the sensors that we've got on the spacecraft, they can come up with a piece of code that they can simulate on the ground, and then if we think it's safe enough, we'll upload that, and they can get their data back by changing data rates that things are sampled at, and things like that, back down to do projects here on the Earth. Educational outreach as well. We also wanted to fly a radiation sensor. We've identified one made in Switzerland, Michael, so very, very good. We've tested that. Seems to work extremely well for beta radiation, so electrons, gamma and X-rays, and it will probably respond to high energy particles as well if they've got enough energy to punch through the exterior housing on that sensor. A little bit more about that later. Something else we're going to look at is experimental digital processing of transponder signals. So a digital mode going up, the mode is then received, decoded back to basic data, and then retransmitted down using a different mode. And we think that will offer some advantages in tracking. I'll look at this in a few minutes. But also on receiving weak signals on the ground, which is more compatible with the power budget of a CubeSat. We also want to have a look at experimental data downlinks, probably QPSK, around the 19K bits per second in 2 meters. This won't be on all the time, you'll be pleased to hear, but it's something we want to try because we think 2 meters is potentially very useful because of the low path loss and relatively low changes in the phase of the signal as it comes down. So what have we got as a basic communication system? Well, we've got 3 payloads under development at the moment, fairly well advanced. The top row there, going from right to left, we've got the typical 70 SEMS receiver that we've always flown, a linear transponder, something that converts that to 2 meters, and then a power amplifier on the right-hand side, which now has 3 inputs. So the linear transponder will be 1 input into a combiner. We can then use an FM repeater type system, taking the 70 SEMS in the middle row, applying an FM demodulator to that, CTCSS, and the various timers and logic, convert that up to 2 meters, and then again amplify that out through the 2 meter PA. And then the last one is something I think we all really need to think about now, especially after Frank's talk this morning. 24 centimeters. If we don't use it, we are going to lose it. The latest bit of information I heard last weekend is that the 24/7 band for amateur radio satellites is currently 1260 to 1270. In all likelihood, that will be reduced to 1260 to 1262 at best. The Russian Federation is still saying we don't want it anywhere. It needs to go, so it's not a done deal. The last thing I heard was that it's likely to be power limited from the ground, so you don't interfere with people using the navigation systems around you. They're proposing a power limit. Don't worry, it's 5 kilowatts, ERP. But they are suggesting a 15-degree minimum angle for anything on the ground pointing to space. I think we can live with that. If you want to get down to the horizon, just reduce the length of the antenna, the beam width broadens out, you can still do it. But we really do need to use that band. So that will be FM as well. FM going in, CTCSS, timers, going into a 2-meter modulator, and then out through that PA again. Couple of little things. The high-speed data will need to go into an IQ modulator for that band. That'll be separate. And our usual telemetry will go into the 2-meter section at 1200 bits per second. So what have we got in, if you like, historical board designs? Well, the left-hand side there is the little transponder stack from AO73, UCube, NAIF-1, and JY1SAT. 3 boards stacked together, a transponder board, a CCT board, which controls it and provides the telemetry, and then another board of sensors on the bottom reading all sorts of current, and I think there might be the odd magnet, which won't be fitted to the next satellite, to keep it all pointing in the right direction. The one below on the left was some work done by a student that we sponsored down at Surrey University, our good friend Dr. Chris Bridges. We see a little less of him these days. He's become a father, and so he's got extended paternity leave. And I think amateur radio has just gone down a slight notch, but Chris, we hope to see you back fairly soon. Some great work on the 10 gigahertz project by one of the students. That was carried on this year as a degree project. We're not convinced it's gone far enough to actually take that into space, but at least it's a nice bit of research. Something else going on at Surrey at the moment, we've got a student who's just completed a project using supercapacitors as an EPS on a spacecraft. And the advantage there is supercapacitors have a much longer lifetime. You probably can't run them right the way through an orbital eclipse, running full functionality, but you can certainly keep the satellite going in terms of computer, sensors running, and things like that. So very good potential there for future long-life satellites. And after all, why throw things away when you've paid so much to get them in space? Top right-hand side, we've already done 1263, I think it was, megahertz for the SAO program. Survived all of the vibration testing, thermal testing that we had to do with it. That was okay. It was in space for about 3 months before it switched on, ran for about 3 orbits. So we never really got some long mission information from that, but at least it's been into space and survived the testing. Equally, bottom right-hand side, 2-meter BPSK transmitter and the 2-meter FM transmitter on SAO. Again, some more valuable experience gained. We would have liked it to work a bit longer in space, but there were simply too many failures in various other parts of the satellite to enable us to do that. So this is one of the new things we want to put on. We're sacrificing a couple of solar cells. If you can imagine a 2U satellite, normally it would have 4 solar cells down each side and 2 on each end. So I think that's 20. We are going to remove 2 of those from the -Z end, as I should say here in Texas. And instead of solar cells on that panel, we will be putting an aperture in for this radiation sensor, the lens for a camera, and also, because we've got 24 centimeter band, and we don't want to run a patch, because a patch antenna is likely to take up too much real estate, we've identified how to put on an antenna which is actually not a deployable, but it's fixed. Thanks to Planet Labs, who've been using 3U satellites in low Earth orbit for a long time now, they identified on a CubeSat deployer, you have a spring at one end, ready to push out the satellites below, and on the inside of that spring, you've got a little area that's totally free. So there's a little void there that nobody uses. And it's possible to put things on the outside of the satellite, so to normally exceed the envelope of the CubeSat and put something into that space. Some people call that the tuna can extension because that's about the size of it, but it is possible to put some deployables there. We wondered if we could put in a 23 SEMS quarter wave. It doesn't quite fit, so we had to think of it being moved slightly to one side to reduce the height. We like fun, so we came up with a little design challenge here and came up with the scary antenna, the slightly canted antenna resistant to impacts, because if you imagine that CubeSat going up and down, there's a fair chance that antenna tip is going to hit the end of the deployer, so we needed to make sure it was at an angle so it didn't transfer the energy straight into the mounting. So if it does go up and down, it's got to hit the end of the CubeSat deployer and just bend very slightly, so we need to protect the top of it. But we reckon that will give us a better radiation pattern than a patch on that particular end of the satellite. So that was quite good fun. Okay, last thing on this FunCube Plus mission, mode dynamic transponder. Not the best name, we'll probably change that. But it was one of those conversations that came about at a late night conversation, much the same that we are having here this weekend. One mode up in digital format and another down in a completely different format. We've heard this morning, let's use a couple of examples, IO117, packet radio, 1200 bits per second up, loads of people transmitting all at the same time, only one user can get in, and we have people in Europe who sit there with their finger on the transmit button going CQ, 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 until they get into the satellite. Only one channel, it's a real challenge, because even I get a 10-minute window with Hawaii on that satellite every few days. The coverage is immense. The reason for this idea is that uplink power for us is not restricted. We can turn up the power, we can add more elements to the antenna, and we can transmit faster with a wider bandwidth without too much trouble. You can't do that on the CubeSat. Downlink power there is limited. It needs to be a relatively high efficiency mode, preferably with forward error correction. So just as a wild and wacky idea, we're not sure of the modes yet, but just imagine you transmit up to a satellite using, let's say, a packet format, 1200 bits per second. The transmission is about 1 second, maybe a fraction longer. That can be received by the satellite, decoded back into its basic data, and then transformed into another mode, which is more appropriate for sending down. I've no idea what that might be, but I've seen people using FT4. Okay, so imagine that idea. Good thing about this is you can also define the bandwidth of the transponder depending on the band you're using. We all have to track satellites to get things in the right place. You may not have to do that with this. If you say you're going to transmit up, let's say on 70 centimeters, you know what the Doppler shift is going to be. It's about 10K one side, about 10K the other. If you make the transponder 25 kilohertz wide, if you transmit in the middle of that uplink band, no matter where the satellite is relative to your position, your signal will always be in the transponder passband. So you don't need to change the frequency. What will happen then is you can get more than one signal into the satellite at the same time because you've got a big chunk of bandwidth. The satellite can handle each of those signals, decode them back into data, and then produce some nice parallel narrowband streams on the downlink, which you can receive in a much smaller bandwidth. It's good for the satellite, it's easy for us, no tracking. It's something that was a wild and wacky idea, but we think it's got potential. Next stage on that is prototype with GNU radio, and then if it all works, transfer it to an FPGA and fly it. Okay, we've heard about QO100. That thing has a pesky little end of footprint right down the middle of the Atlantic. Two things that have been going on in Europe. Firstly, a company called Space Inventor in Denmark launched a 16U, I hesitate to say CubeSat, that's big, isn't it, for a CubeSat, but a 16U satellite into an orbit 1,000 kilometers under the geostationary belt, using some interesting propulsion technology, new products that they're developing, star trackers and things like that. And this satellite is covered with horn antennas for the microwave bands on one side of it for its main mission. They gradually nudged that up from 1,000 kilometers under the geostationary belt right into the slot that they've been allocated for this satellite. So a lot of interesting technology there. And in the future, they may be interested in hosted payloads. So just keep half an eye out on developments from Carl and his team at Space Inventor. Last but not least, European Space Agency. They've recently started to seek proposals for an amateur satellite or payload to geostationary orbit. I think they've seen some of the developments that have gone on with QO100. Lots of people coming up with new modes, lots of people doing research work on amateur television, and the progress has been really quite amazing over the last few years. So a few weeks ago, Frank Zappenfeld, Papa Delta Zero Alpha Papa, who works for the European Space Agency Telecommunications Division, came along and told us of an interesting discussion that he had been having with his colleagues and the people who run ESA funding. They're looking for proposals for either a hosted payload or a microsat to geostationary orbit. The important thing is that it must serve the radio amateurs, and this is amateur radio based, that are in countries that form the European Space Agency or their cooperating states. And I can't help noticing that one of the cooperating states is just north of here, the whole of Canada. Now, I don't see how you can run a geostationary satellite serving the amateurs of Canada without it coming into the USA. And AMSAT North America has members in Canada. So guys, get thinking about it. If you come up with an idea, they're interested in things like 5 gigahertz, 10 gigahertz, 24, maybe 77, come up with some ideas, get some proposals in. They're willing to put money into it. 250,000 euros has been already funded for the feasibility study, and if that's successful, it'll go forward. They're looking for 2 proposals, so they've got something to discuss, but that is it's an opportunity that's gone further than most that I've seen, so it's likely to be ongoing, which is really good. Okay, that's it from Europe. Thank you very much.
Thank you very much, David and Michael. At this time, I would like to take a little extra time out of your lunch, if you don't mind, to give you an opportunity to ask either one of these gentlemen a few questions. So, Michael, if you'd go back up and we can get a few questions from the audience. I think Kent has a first comment.
Good day. Been a while since I've met you at Martlesham. I do find your use of the 4-meter band interesting. I'm probably one of the few people on this side of the pond with a 4-meter station. But here it is classified as white space. So we can, very similar to the various ISM bands, use it on this side of the pond with a few restrictions. So there's no reason why more people can't get on it.
Okay, yeah, I think that's good. Obviously, the higher bands that we can use, the better. Sorry, I don't feel a patch from your good self is the most appropriate antenna for our new satellite, but we're aware of your work and I'm looking forward to the presentation this afternoon. Okay, there it is. Any more questions?
Yeah, thanks for the presentation. It's very interesting. I'll just say that I like the idea of the mixed mode transponder from an experimentation perspective, and close to the microphone. And certainly, one thing, these complicated modes with lots of efficiency and forward error correction are much easier to generate than they are to decode. So, you're better off transmitting it from the satellite, but not having to receive it, perhaps. So you could get some real efficiency out of that. So look forward to that.
Yeah, okay, thank you. I sort of anticipated the decoding would be a challenge, and I can see that, we've gone for the forward error correction and the more difficult modulation schemes in the downlink, anticipating that what needs to be generated on the ground must be perhaps easier, because it's a lot of people doing it, so it's got to be easy. Okay, thank you, Chris.
Any other questions? Okay.
If you would like to see one of our CubeSat boards for this new mission, this has just come in, and I'll leave it at the front. It's a 2-meter PA with a combiner and all sorts of telemetry and an FM transmitter on the back of it. So that should be flying in mid-25. Thanks.
Excellent. I would like to extend our appreciation for the two of you doing your presentations today. These gentlemen did not know they were going to present today. So all of this was off the cuff. They did an excellent job. Thank you very much for the update. Okay, at this time we'll be going to lunch. And we're at lunch until 1 o'clock when we come back for an ARIS update. So see you at 1 o'clock.
lunch. The first person we're going to hear from is Dave Taylor from AMSAT on an ARIS update. So please welcome Dave up to the podium.
Thank you. I'm going to shed this and take a chance on freezing. But I sweat enough without having that on. All right. It's great to be back. This is my first chance to get back to the symposium since before the pandemic. And I've missed seeing everybody's faces and having all sorts of conversations. ARIS, though, has been going along all along. And we'll give you a short idea of some of the highlights of this past year. And really, just because it's convenient, for past year I used the government's fiscal year. We are tied closely to NASA. They're one of our sponsors, and we have to report metrics about how many contacts and how many kids were this and that. So we do a lot of work on the fiscal year, and I already had maps and things, so that's close enough to our past year, October to the end of September. And hey, Frank, just a reminder on behalf of Rosalie, get a photograph of the audience. That's for our metrics. How many people we have communicated with about ARIS. Okay. The thing ARIS is probably best known for is our educational contacts. We hook up students around the world with an astronaut on the space station. And we've just about gotten back to the pre-pandemic levels now. We did 91 contacts all around the world. 20 of them were here in the US. And because AMSAT North America also appoints a delegate for Canada, I've included some Canadian statistics and information. Their mentors handled 12 contacts. 5 of those contacts were not in Canada. Canada picks up all of the Americas outside of the United States. Just as a convenience, a courtesy to the rest of us. So they also handled contacts in Brazil, Central America, several interesting ones down there. About 71% of the contacts were direct, which means we had the radio equipment right there with the kids when they were talking. They get to see it and see what's operating, see the antenna outside as they go into their school. And in some of the places, they get to help set it up and even operate once in a while. I can give you an example of that later on. Did that change automatically, or did I touch something? I hope it's not on a timer. I might have to change modes. But yeah, so far since the space station went into orbit, the first crew arrived in November of 2000. They did the first ARIS contact in December. We were the first payload turned on. And since then, we've done 1,577 contacts around the world, 75 different countries. I did not bother, I wanted to also mention we've got 3 new contacts just in the last month, or 3 new countries. We did contacts in Tunisia, Mexico, and Azerbaijan. It's always a tongue twister, which sounds like an out-of-the-way place, but they were hosting the, what was it called, the World Space Conference at the same time. I didn't bother with a US chart because it's almost entirely green. In the past 23 years, we've had contacts in 49 of the 50 states, or also the District of Columbia and Puerto Rico. So we're still working on that 50th state. South Dakota's out there somewhere, we know. We'll get them. Just grabbed a few of the contacts that were interesting in one way or another. Just about a year ago, we did a contact with what I'm pretty sure is the only school in Antarctica. It's an Argentinian base down there on the big peninsula that sticks up towards Argentina. And we did a contact, the kids there talked to Joe Lindgren, they have one school that covers ages 3 to 21 at that time. So but you know, again, possibly unique because most Antarctic bases have researchers, but they don't have entire families down there, and this one does. So I put one picture from there, the picture there on the right with everybody in their orange parkas. You can tell that they're in the Antarctic. I had about 50 students there, plus the teachers, and some of the parents came in. Then we did a big multi-point. It is on a timer. Now, I will try to just deal with that. If it jumps around, I'll take it back. The multi-point in South and Central America and the Caribbean, we had 63 schools involved from 12 different nation states. And it was an event organized by a group called Disaster Fighters, with also support from NASA and different governmental disaster-related agencies. Their primary theme was preparedness for disasters. And of course, hurricanes are the big disaster through most of that area that people need to be ready for. But we connected them all via a web conference and let them all take turns. It was very unique just because of the size and how much it was distributed. And I made this very small on here. Youth on the Air. If you've heard about it, the Yoda camp takes place once a year. They try to bring together young hams from all of the Americas, North, Central, and South. This one was up in Canada this year, in the past July. Do a lot of activities, and Ruth Willett was orchestrating the youth activities. Many of you may recognize her name. She's helped out AMSAT and ARIS on many occasions. There were a few years when she was at the AMSAT booth at Hamvention. She's a very active ham radio operator and satellite operator and all-around smart person. So the Yoda contact went nicely. We introduced the kids to ham radio. Well, they're already hams, but we let them do the contact, and then they did a lot of other projects, like a balloon with a ham radio package on board. They built electronic kits and got to operate HF and VHF and make a lot of contacts while they were at the camp. And just this past week, on Wednesday, we did the St. Peter and Thanet contact in the UK. That was, school had 360 students and over 50 visitors, plus parents and other guests, and one reserve astronaut from the UK, Megan Christian, who watched and also answered some questions at the end. There were 3 questions that didn't get asked because they ran out of time on the pass, so she filled in and gave them astronaut answers, if not from the space station. One of the interesting things about this is that I think I mentioned last year, or no, I don't know if we got it mentioned or not, but last year a young girl named Isabella over in the UK got to talk to Kjell Lindgren when he was making random contacts up there. And her father is a ham, and he called her over when he heard them on, and she made a call, and he answered her. That got picked up by the media and the press, and it made headlines all over the world. So this is her school, and on this contact, when they initially called to make contact with space station, she was the one making the call. And they were also had it on, they were streaming it on video. Her expression when she finally got an answer out of the static after several calls of just static was great. She talked to an astronaut before, but she was still out of this world and hearing it again. And then she got into line with her fellow classmates and asked another question when her turn came around. So she's becoming quite a ham radio space celebrity. And speaking of that, Chell was making a lot of random contacts while up there. He gained, with the combination of that one in Antarctica, he got worked all continents. And because it's happening more often now, we're getting random or general contacts made because our new radios were designed to make that very easy for the crew to do. They can just walk over to the voice repeater, turn up the volume, and if they key the mic, they're on the repeater and they can talk to whoever's down there. So after Chell, at least 2 other astronauts have been making random contacts this year. So we hope that trend keeps up. All right. Now, besides just school contacts, ARIS is doing a lot of other things for education. Partly because, well, mostly because we want to expand our outreach. We can only do the school contacts with an astronaut a limited number of times because the astronauts are volunteering their own very meager personal time to make these contacts. And they're getting busier with experiments, and someday there won't be an ISS up there. So we're looking at other ways to let schools get involved in the same kind of education and STEM that we've been promoting in the past and continue it on, do more now and have it continue in the future. We hope to continue it on commercial space stations, of course, but that's a long way off, and who knows what deals we'll make. So we have a big education team. This year we got a new director of education. We put out a request for people to submit their resumes and search for it. We got a lot of responses to that from a lot of qualified candidates. So after interviewing lots of interviews, our selection team came up with Tanya Anderson, who is a middle school science teacher in Illinois. She's got about 18 years of experience teaching science and doing various STEM-type operations. She's volunteered with the Civil Air Patrol and with several activities that NASA has done to do STEM. So she's got a good background for us. And as I recall, she had a ARIS contact of her own a few years ago. So she knows what's going on. She was following our first director of education, Kathy Lamott, who's worked for many years, but is running into time crunch and needed to free up more time to do her own teaching job, the thing she gets paid for. So she stepped down from the leadership, helped us pick her successor, and she is still volunteering with ARIS, just not in the management role anymore. Now, the Director of Education's job is to run our committee. We've got nearly 36 people, all teachers, most active, some former. They're involved in education. They help us out with a lot of different things. When we do a school contact, all along we've had technical mentors, hams who volunteer to work with the school on the aspects of operation, help them get their station set up and work out their processes. But now with our education team, which we started putting together 5 years ago, the school also has what we call an education ambassador. It's the complement of the technical mentor, but they assist with the education plan and help the school give guidance and oversight to their implementation of the education plan that they submitted to get the contact in the first place. And then beyond that, they help with the selection process. They evaluate the proposals that come in here in the United States to choose which U.S. schools will get contacts, because we are looking for the best education plans, and who better to evaluate an education plan than an educator. And they help with the different projects that we have going on for furthering our education. They advise our management team about how we can improve our education outreach better, improve it better. That's, well, aside from that, you wouldn't believe I was a technical writer in my career, would you? The benefit to writing was that I could look it over and proofread it, and I didn't have to talk to people. And I should have made that bigger. Anyway, the education team is very busy. They, in addition to helping the schools and picking them, they go out to educational conferences every year, meet with groups of teachers, talk about ARIS, probably 50 to 100 events a year that they are out there promoting ARIS and ham radio and trying to get new people involved. At conferences, they operate an ARIS table just like we do at different ham fests, but with more of an educational bent to it. They give papers there. They're very active and an important part of promoting ham radio and keeping the flow of schools up for us. Mentioned selection, so for those who aren't familiar with it, here in the US, we have people submit proposals to host one of these contacts twice a year, in the spring and in the fall. And those two windows, proposal windows, are for contacts in the first half and then the second half of the succeeding year. So there's a long run-up where people are preparing for it, where we're doing all the training, setting up arrangements for ground stations with local ham groups who can put a radio at the school. There is, our fall window is open right now and will be for another few weeks. During this window or any time in the future, if any of you know somebody who is involved in formal or informal education, so running summer camps, teaching at a school, an educator in a museum, whatever, even homeschooling groups, make sure they know about ARIS. There's information on our website. They can read all about what it provides and what they would have to do to get into it. We really want to keep getting the word out and get as many kids involved in this as we can. And some of the projects that we have to continue our education outside of using an astronaut. The big one right now is stereo, and our baked-in experience with NASA is showing in that all the acronyms I have listed out on here. Stereo is funded by a 5-year grant from ARDC, which has been just wonderful for us. We're about 2 years into that. That's being used for 3 primary activities, one of which is just general support of our operations. Our engineer that we maintain at at Johnson Space Center to get the scheduling done, work with NASA on all the aspects that are necessary to get us on the crew timeline and help get our equipment set up and down. The other 2 are Sparky, which we sometimes call our radio kit. Alan Johnson made a reference to that earlier in his presentation. It is what you see in the picture there. We've got the Sparky is a kit that we provide to, now that we have it operational, we're providing it to every school that has a contact. And it has a Raspberry Pi based SDR using the RTL SDR. And it comes with everything you need to use that Pi. It's got a keyboard, a mouse, a display. And of course the SDR, it's also got a little telescoping antenna you can add to the SDR if you want to set something up quickly in a classroom. Then along with that, we've got different education aids. There are lesson plans that we have developed. There are tools that help with those lesson plans, like a Snap Circuits kit to go with different projects that can be built to demonstrate different radio concepts or electronic concepts. There's something people love to play with when we have it sitting out on the table at Hamvention or Hamcation. That's a slinky. We've got 2 slinkies in there. One really big, long one, and then one conventional toy shop type slinky. You can use those to demonstrate bandwidth and modulation. And that's good for the younger kids to be able to visualize how the radio waves work. And the third part of stereo is teaching teachers. We can't just give Sparky to a school and expect a teacher to know what to do with it or how to do anything with it. So we teach the teachers, take them in, run them through everything in there, let them play with the circuits, find out how to use the radio and receiver. That Raspberry Pi has the full range of software for different modes, like Alan Johnson was talking about with CubeSatSim earlier. I think, in fact, it's the same set of software. And that also has been rolled out. We've done 2 so far, but it's all set. They're working well, getting a lot of good comments about it. And we will be doing more and more of those thanks to the ARDC grant. We can get members, the educators, members of our education team down to where we're going to do the training session. The first one was done after an educational conference. So lots of teachers there. We selected a group of them. Also, because this is a very big project, we have a dedicated volunteer as a project manager, and it's Diana Schuler. She joined in January and is responsible for all the logistics of getting these kits put together and shipped out to the appropriate schools, getting venues for training and lining up who's going to be doing the training. And anything else that's necessary to keep the stereo project moving along. She was a former NASA employee, worked as an engineer and a manager, both at JSC and then later at NASA headquarters. So she's got a lot of background information or background in the space field. And was not licensed to begin with, but she now has her own license, and she's learning a lot more about ham radio and how that all fits together too. She's doing a wonderful job for us. Another project that we have underway that's not as far along as stereo is STAR. This is going to involve off-the-shelf robots that we've modified for wireless control. And we've been getting interns through the NASA Summer Intern Program who have been helping us with this. Our intern most recently did a lot of design work on the software for this to allow communications. So it'll be set up so that students can learn to control the robot wirelessly from a computer in their classroom over Bluetooth. And then they can kind of move in steps as they become more adept at doing things, learn the basic commands while they're actually watching the robot. Then they can send commands to it by embedding them in APRS messages and sending them out. And that can be done directly from a radio in their classroom, assuming they have a licensed person there. Or sending the APRS commands through a local digipeater and controlling a robot perhaps at another school within range, which gives them the chance to have inter-school competitions set up. One school could set up an obstacle course. Actually, they would both set up an obstacle course, tell the other one what it looks like, and then each school has to come up with the commands to get through the other school's obstacle course, and they can compete with each other that way. They're not actually seeing the robot, they're sending the commands over to move it where they think it needs to go. And the step beyond that, once they master it, is to learn how to contact the space station and track it and all the extra things you learn there, and then send those APRS commands to another school through a digipeater in space. And that's going to be really tricky, but it's an ultimate goal to really keep the motivated people moving toward a really stretch goal. So this project is funded by a grant from the ARRL Foundation, and let's see, we had a bequest from Keith Pugh on that too, didn't we, to get it started? We've kind of been treating this as a Keith Pugh Memorial Education project. Keith was, I know, very active in ham radio down in this area and in AMSAT, and a wonderful mentor for ARIS for many years, working with the schools and kids. So we're happy to have this going underway. And the third thing we have going is the Student Mission Control, which we sometimes refer to as SOOSS, which is Student On-Orbit Sensor System, as I recall. The idea there is going to be to have a Raspberry Pi system on space station with a custom designed sensor hat sitting on it that's collecting environmental data, measuring gases, certain gases in the atmosphere up there, the temperature, the humidity, accelerometer to give information on motion, and all that will be sent down to Earth sort of in the background on our radios and collected, aggregated, and stored on a server down on Earth, from which kids can use a virtual control panel to look at that data, see what things are like on the space station, and look at historical data and do analysis of trends or whatever kinds of projects their teachers or we can come up with in lesson plans. We're doing the onboard sensor collection part. Overall, this was a project, an ISS National Lab project that was funded by a grant from the National Science Foundation. And we got the data collection part. The University of Berkeley was developing the control panel that will take the data we provide and let the kids work with it in different ways. So like I say, that's in early days so far, but moving along. Looking at hardware projects, following on what I just said, I want to jump down to the fourth bullet there, the ARIS Pi. The ARIS Pi that we're developing for that mission control system is also going to have some other features in it that we would like to have to support ARIS activities. So it's going to be hooked up to the radio so it can send that telemetry down. So why not give it the capability to send some commands to the radio too and tell it to change modes or frequencies, things like that. We want to incorporate that capability, and then if it's hooked into the wireless, the Wi-Fi network on the space station, we can get permission from NASA, we hope, to connect to that and control it remotely. We can tell the radio when to turn on or off or change modes by connecting through the network. And that will speed up a lot of our operations. Right now, if we want to make a change, we have to send the request to NASA, and they send it to an astronaut if it's urgent, and we have to convince them that it's urgent, or it just gets put on their timeline as astronauts have a sort of a job jar, lots of little things that they can do in any order they want whenever they have time for it. So sometimes we send a request and we have to wait a while for it to happen. And this would speed up some of our operations and changeovers. It can also, if we have that, we could send up photographs or images and operate SSTV, put it into an SSTV mode and have this ARIS-Pi feeding it. So we would have an alternate way of sending SSTV events rather than using the matching radio that's over in the Russian segment for SSTV, which is what we do now. That jumped ahead, sorry. I didn't notice that. The other projects we're working on, one is ham TV. Remember, we used to have a digital ham TV transmitter on board, and it failed a few years ago. We were fortunate enough to get it sent back to Earth. We sent it over to Italy for repair and got it back last year. And then late last year, one of our engineering team members, Kerry Banky in San Diego, got this, and he ran it through some tests to check it out. He tested it with the new power supply system that we built to make sure that it would work when we get it sent back up to ISS. It then went back to Johnson Space Center, and he went with it, and he and Ken Ransom, our engineer there, worked with NASA to do some RF tests that NASA wanted before sending it back up, and also to test it with a new HDMI camera that is on board. We used to use NTSC type cameras up there. So that testing was completed, verified that the cameras would work through the HDMI to NSTC converter we have built. We tested it with what's in the second bullet there, the ham video overlay generator, which is another item that we intend to send up to use with the ham TV. It can put scrolling text messages on the video, so we can label things, put information that matches what we're doing. What we've done in the past was have the ham TV sending down a digital video signal that students at a school contact could see while they were talking over the radio and getting their questions and answers. So we could label it, put names, or whatever kind of information we might be appropriate. And that contains the converter for the HDMI to NTSC format for the cameras. So we know all that's working. Ham TV, we identified that there is some spurs on the output of that. And so rather than send it up and have to turn it off whenever a spacecraft that might be affected by those was going to be docked, which would have been probably over half the time, we elected to keep it on the ground, and we're designing a filter that will go on it to make it, to alleviate that problem, and then we can keep it operational most of the time, so that if we're not using it actively to show an astronaut during a contact, we can just be sending down stock images. And again, once we get that ARIS-Pi up there, we could be having slideshows all the time on the digital, just for people could tune in and watch, rather than what we did in the past, which was leave it turned on and you could tune into a blank carrier just to test your receiver. Our radio system has a 1200 megahertz receive capability, and we started a long time ago devising a diplexer that we can stick in line and eventually do an LV voice repeater. So that's coming along. It's just about ready, but there's paperwork and testing before it can be flown. And the last one is very far out. In talking about the ham TV while we were waiting to get it repaired, we started thinking about ham TV Mark II, how we could update that. And we were thinking using an SDR to do some different things, to try new different formats. That has grown a bit into more of a multi-mode digital communication system that we hope to demonstrate a few of the techniques that we will need when we have a radio out in deep space, or on Gateway or at the moon. Actually on the moon. Gateway is at the moon, or will be. So we're working on that. There's a sense, right now, it's still very early picking out what kind of hardware we want to use with this. And I'm really out of touch, so that's kind of iffy. That's basically my understanding at this point. We've got our director of engineering in here, can probably provide more details about any of the projects that we have going on. But ARIS is actively involved in working on new projects to keep things interesting on the space station. Quick review of what's going on now. We have both radios up there, identical radios except for the call signs. One in the Columbus module, which is at the leading edge of the station, and one in service module, which is in the Russian segment at the back end. So they've got a nice wide separation. We've been running the voice repeater on the one and digipeater on the other. Digipeater would occasionally be taken off the air to do SSTV contacts. Both of the radios get used for school contacts, because the Russians have been doing a lot of contacts in their own country and a few others as well. SSTV, a lot of us are waiting to get another event going. It's been on the air. I tried recently to do a test with some old SSTV equipment. And a few images were received, but overall there was something getting in the way. We're going to try another test sometime soon. We don't have a definite set of start and end times at this point, so I don't want to say anything too much, but if you keep watching the ARIS social media announcements on Facebook and X and all those places, and on our website, we'll make it known. So keep an eye on those next week. There might be some news. I'm sorry, got off that. The SSTV things that we're working with is old. Thank you. So they had to, rather than use the new radio, they took it, they uninstalled it and put an old D710 in its place to run SSTV, and until they finish all that work, they're going to keep it that way. So unfortunately, our digipeater is off the air for a while. If that looks like it's going to go on far too long, well, it's under discussions, but one option is to go back to what we were doing when we only had the one radio up there and alternate the Columbus module radio between voice and digipeater on some kind of regular schedule. We had an annual meeting of our delegates and interested volunteers back in April at the ESA Center in the Netherlands, and had a lot. I think we had 15 or 20 people there in person and quite a few more online to take part. It was a 3-day meeting. And Frank will be talking about the 40th anniversary in a bit, and our next meeting will be in conjunction with that down at the Kennedy Space Center. And a little bit of the recognition that ARIS has been getting past year. NASA, 2 parts of NASA. One was NASA and one is the ISS National Lab, which is, it sounds like NASA, but it's actually a NASA-sponsored contractor that runs the National Lab part of the space station. They both came out with sets of interesting things from the year. Everybody likes to have their 10 best or N best lists at the end of the year. So we got on both of those lists, along with nice pictures of our radio station up there. And that's about it. There's lots of information on our website. And I'll take we've got a couple of minutes for questions, so if anybody wants to know something.
Yeah, Dave, does your website have the essential specifications for the ground station, such that if I get an educator to prepare a proposal, and I might offer my station as a ground station,
Yes.
you know, I'm not sure my station, which is a little old, I mean, it's a FT 736R, and that might not be up to speed these days.
The answer
What
is
do
yes.
what do you need?
We basically ask for a station that's similar to our telebridge stations, but there is a lot of information on our website for the groups that are going to hold a contact or just thinking about it, and one of them is stations guidelines if you're going to do it with the radio at your site, a direct contact. So we go into, you know, what kind of radios, power, antennas, all that thing. Anything else?
You say the ham TV unit has been shipped back up to the station. Did you take the opportunity while it was down here to try and mitigate whatever failed in the first place, or I mean, running something 100% across an entire orbit is going to be a tougher ask?
It has not been shipped up to the space station. It was on a scheduled cargo flight, but after we got these tests and evaluated them ourselves, we decided it was much better to pull it from that flight and have it on hand while we develop the filter and then send it all up together, rather than send it up and have it sitting around with a tag that says do not use. Yeah. The reliability, we sent it back to Kaiser Italia, which was the company that built it in the first place, and they determined that there was, I forget now which board it was, but a board in there had failed probably from a cosmic ray hit. And they happened to have another one on hand, or it was accessible through the community. So they just swapped the board out, sent it back to us. We didn't want to mess with it too much, because if we made any actual changes, it would not be just reflying a piece of equipment, it would be something new, and we'd have to go through all sorts of testing and paperwork again. Did it? Thank you very much.
Thank you very much, Dave. That was an excellent presentation. And here we go. That's yours. Hold on. Yep. All right. Up next, we have Frank Bauer, ARIS Executive Director, who will be giving us the 40th anniversary of Hams in Space and the 2024 anniversary event. So I think we're going to get Frank set up here. The other Frank. There are two of them up here right now.
Frank the Greater and Frank the Lesser.
Oh.
This guy is my idol. Okay, he's an inspiration.
Push that in. There we go.
Just want to check one. Sometimes Windows likes to change things around again.
It's the 40th anniversary celebration of human spaceflight amateur radio and the impact that we as amateurs have had in human spaceflight, which has been significantly positive. You can see here, in the 40 years since we started this, we've followed the NASA and now the space agencies and ultimately the commercial organizations on human spaceflight, starting with the space shuttle, and then as NASA decided they were going to work with the international community, particularly the Russians, on the space station Mir. We worked with them, and then the International Space Station, which is where we're at today. And as you can see, the patches, starting with the SARX patch, that's the newer SARX patch. There was an older one. And then we actually had flags on the ARIS patch, but decided very quickly that there were too many countries and they kept changing around, so we went with what we have today. So, what does this 40th anniversary mean? And, those that have been around a while, and I'll say I am one of them, I will say I was pretty young at the time. 40 years ago, Owen Garriott on the 9th Space Shuttle mission, STS-9 Columbia, flew the first amateur radio equipment. And we do have in the audience the person that was leading that activity from a hardware perspective, and that, of course, is Lou McFadden, W5DID. Thank you, Lou, for everything you did there. So, when Owen got on the air, we transformed, the amateur radio community transformed how people could talk to astronauts in space. Because before that, the only ones that could talk to astronauts in space were people who were in mission control, and not mission control, but the Capcoms and heads of state. That was it. And when Owen picked up the microphone and started talking with hams, that changed everything. And it's continued for 40 years. That transformational change in communications has allowed us, the amateur radio community, to pioneer a lot of really cool things. The school context Dave talked about, almost 1,600 schools now on space station alone. Other organizations have emulated us. NASA all of a sudden started the downlink capabilities. And so, we basically pioneered that stuff. When we first started, and we were on the shuttle after Owen's flight, we started doing family contacts. It was the first time the crew got to talk to their families on space shuttle. And really, even on Mir and space station, it was their link in the beginning of space station until the IP phone came on board. That was it. And then of course, those that remember us throwing a spacesuit overboard the space station called CubeSat, we pioneered that, as well as the whole aspect of being able to safely deploy vehicles off of space station, which led to the CubeSats being able to be deployed from space station. Our work in the safety area, and I'll say the Russians and the US team working that with, to make that happen, actually transformed that. And then the ARISat-1 being the largest, heaviest spacecraft hand deployed from the space station. So all of these things are pretty pioneering. And, remember that this stuff is an initiative that was led by ARL and AMSAT. This organization was critically involved in actually getting to yes, if you will, on allowing Owen to talk. And once you bridge that chasm, the doors just opened up. Okay, so before I go any further, I do want to go, hopefully this will work. The Wayback Machine, I want to, 40 years ago about this time, the amateur radio community was really in a buzz because this is going to be really cool. We're going to be able to talk to somebody from space. So hopefully this will work.
On orbit day 3, excitement peaked among hams all over the world.
Who had one of those radios? Not made for printers. If you even had a printer.
And then amateur radio's Man in Space went on the air.
This is W5LFL in Columbia. W5LFL in Columbia, orbiting the Earth at an altitude of 135 nautical miles. Passing over the U.S. West Coast and calling CQ.
W5LFL on SPS-9, WA1JXN, WA1 Japan, X-ray Norway, WA1JXN, Frenchtown, Montana, standing by.
Hello, W1JXN, WA1 Juliet X-ray November. This is W5LFL. You're our first contact from orbit, WA1 Juliet X-ray November. How do you read, over?
It was quite a thrill. I was very surprised when he came back and said that quite clearly that I was the first contact from orbit.
This is WB5LMJ, Whiskey Bravo 5, Lima Mike Juliet in Lawton, Oklahoma, calling the Space Shuttle Columbia.
W5LFL, Whiskey Alpha for Yankee Victor Charlie, WA for Yankee Victor Charlie.
KZ-17 calling W5LFL, Kilo Alpha 7, Kilo November. This is calling W5LFL. This is Kilo Alpha 7, KZ-17.
W5LFL, W5LFL. This is W5IU, Whiskey 5, India, uniform.
I had to put that one in. I had to put that part in. So it was pretty amazing. How many of you actually heard Owen in from space? Wow. And so what we want to do is to celebrate this, this glorious achievement we've done as ham radio operators. And what we're going to do is we're going to have a face-to-face ARIS International Delegate Meeting, which is a smaller activity, but then open it up for a full conference and tours at the Kennedy Space Center facility. We'll have a reception. We're going to have exhibitors available, and we'll talk about this. I'll talk through this in the next couple slides. We'll have exhibitors there and have a reception in the exhibitor area. We will have a gala dinner and all kinds of different things we're planning here. Of course, we're going to be inviting astronauts, which is going to be challenging from the perspective of financial, but we're going to be inviting astronauts to come and to participate in this. Now, of course, you know, Owen unfortunately has passed. But we've been in contact with Richard, and we set the dates for this to make sure that Richard could make it. So he's very interested. I'm going to follow up with him this weekend some more on it. But our plan is to have him as well as others there. Our venue will be at the Center for Space Exploration, Education, I should say, sponsored by the Astronaut Memorial Foundation. It's located on the site of the Visitor Center at the Kennedy Space Center. The venue you can see at the bottom is very big. It can handle a lot, and I'll show you in a little bit what we're planning on doing with that. And yeah, we'll see how many people show up, how many are interested. The conference center is almost 9,000 square feet. It's huge, and we're going to split it up in half. The person that runs it worked for Disney, and he's a consummate audio-visual person. So he's got everything all set up with really nice visual capabilities and things like that. We're splitting the room in half. Half of it will be for the conference. Half of it will be for the exhibitor. We'll also have food in the exhibitor area, you know, during the day for people, and we'll have places for people to eat lunch while we're having the activities. The other thing I mentioned was the International Delegates Meeting. It's going to be a smaller facility. You're going to see on the website that it'll say invitation only. If people are interested, we can definitely work that. We can expand up to the big facility. It's just a lot more expensive to run that big facility on a daily basis. So right now we can hold about 50 people, but we can, and the Astronaut Memorial Foundation folks are prepared to move us into the bigger facility if it comes to that, okay? So this is what our plans are. The dates, the first 2 days, February 20th and 21st, we're going to have our international delegates meeting. Dave talked about, you know, the last one we had at East Aztec. And then basically what we want to use we want to give people an opportunity to have an experience at the Kennedy Space Center. So we have, as part of, you know, if you register for the delegates meeting or the conference, you get basically a ticket to get into the visitor center and roam the area. And they have all kinds of experiences there. They have a launch experience that Charlie Bolden, you know, by videotape, of course, provides a walkthrough on what it's like to launch from the space shuttle or from a launch vehicle. And then, so that will all be on the 22nd. We're setting that up so people aren't trying to decide what they want to do in the middle of the conferences. We've set a dedicated date for people to go to the visitor center and do the tours. And you can spend all day at the visitor center. And that evening, we're going to have a reception with the exhibitors. We're actually going to, that day, the exhibitors would set up. And then the conference will be on the 23rd and 24th. And what we are doing is on the 23rd, which is a Friday and a Saturday. On the 23rd, we're going to have a gala dinner at another facility that, you know, that the organization runs, which is near Banana Creek, which is one of the launch site areas, and that's where the Saturn V rocket is located, and we'll have dinner under the Saturn V rocket. Okay. So it's pretty exciting. It's going to be pretty cool. I'm not going to go into this, but basically we're setting up our agenda for our ARIS International meeting. I mentioned this, but in more detail for the 22nd, we will, pretty much what we can do here is people can arrive before 9 o'clock and the gates open at 9. Okay, and you all get tickets. Those that register will get tickets. And we'll have breakfast snacks there for you. You can go through the Kennedy Space Center visitor center tours, and then our exhibitors are going to set up, like I said, from 9 to 4, and then at 5 o'clock we'll open up the reception. Okay, and that'll be open to both folks that register for the ARIS International meeting, as well as those that come to the conference. And then the conference itself, we're probably going to. This is still tentative, but our intent is to dedicate day 1 to the space shuttle and the Mir program, and day 2 to ARIS. Okay, and you know, our intent is to. Let me just say a couple things. We are inviting astronauts. I mentioned what we're trying to do is make sure that most of the astronauts, we have to pay for their travel. So it's about $2K is where we're thinking we're going to be paying for that. So our intent is to have panel sessions with them. Those that were in the shuttle program would talk on the day 1 activity. Some of them did both, shuttle and space station. Would be day 2 with the space station activities. So we've gotten some of our lists of who we think would be great to have. Like I said, an important person we want to have is Richard Garriott, because Richard not only, you know, it was his dad. For those that aren't aware, Richard and Owen are the first father-son team to actually operate in space. So, and when his dad was up, Richard and his brother were talking to Owen on the ham radio. So he's had experiences on both ends of the microphone, if you will. Okay? So, you know, when I say VIP keynote speakers, those are usually astronauts. But there might be, you know, I can't promise who all's going to attend, but Bob Cabana is he's, you know, number 3 person at NASA. You know, we had when Crew 6 flew, one of our social media person, Jim Reed, asked a question to to the panel, because he was there for the launch, about ham radio and the 40th anniversary. And Bob he says, well, I'm a ham radio operator. My call sign is, and he's very proud of it and very proud of things. So we are going to invite him, whether he can make it or not. He's another VIP because he's basically number 3 in NASA. So, and then other, panel sessions of how we got to yes, because that was a challenge. Just being able to fly on a vehicle and transmit independent of mission control is a big deal. And then, our experiences on Shuttle Mir and ISS, our international challenges, and that's an interesting discussion in itself. Once we started to work together as a team, Lou remembers this, and Rosalie and others, the challenges we had doing this. And we've got individuals I know from our various groups that we're going to be bringing in internationally that are interested in being part of that discussion. And then our technical challenges, our technical initiatives, like SuitSat and AeroSat, and then students that are now in STEM careers. We have, we have individuals that we can cite right now and try to bring them in either in person or through a video, a little video clip on how ARIS, SAREX, and the MIR activities impacted them and in their ability to become whatever they are in a STEM career. So then the educational and the technical challenges and capabilities is what we want to cover. So our gala dinner, would start. We want to get everybody there. Those that come, the buses will start leaving at 6. We want people to be there around 5:30. They will depart. It takes about 15 minutes to get to the Apollo Saturn V Center. You'll go past the vehicle assembly building and things like that. So we'll have dinner. We'll have a bar there, dessert, and then we'll have a program associated with that. Probably more focused with Owen's flight than other things, but there'll be discussions across the board. So. Business casual. Now, we have 6 hotels. Now, the situation is that this is the high season this is the beginning of the high season. And those of you that go to Hamcation and try to find hotels, sometimes we had problems last year. And this is like about a little less than 2 weeks after Hamcation. So we thought it was best to work with multiple hotels to get as many rooms as we could. And this will all be on the website. So, but we've got some really good ones, and we've worked with them. They're all under contract. The venue's under contract. We're all set to go. And the way we've set up the rooms, because I know some people are going to want to double up, if you're traveling with rental cars. 4 of them are in Titusville. We've got them set up as hotels that are right next to each other or close to each other. 2, the Courtyard Marriott and Hyatt Place are right across the causeway from the conference facility. And then we have a couple in Cape Canaveral area, and then a couple others at Titusville near I-95. Okay? And then the other thing I did want to mention is we are looking for sponsors to help this activity. This is a very expensive, the equivalent of a very expensive wedding. It's the best way I can describe it. And so we're trying to keep the prices down. We're stretching ourselves a bit. I will tell you what we're going to be charging now for registration, which includes the ability to get on the go to the visitor center. The visitor center costs are about $70, $80 to go to the visitor center, and then we have lunches. We're buying lunch for you all and everything else for the 2 days of the conference. It'll be $125, and then it'll be $125 for the gala. Okay, we're trying to keep these costs low to get as many people as possible to come, and so and then for the international meeting, it's a smaller activity. It's $50 for that. Okay, so if you have companies that would be interested in sponsoring this, you work for a company. I know a number of you are in the aerospace world, or you know, organizations like AMSAT or ARDC or anybody wants to provide sponsorship for this, it'd be great. Individuals that want to sponsor, you see at the bottom there, sponsoring an astronaut. It is going to cost us about at least $2,000 to sponsor an astronaut because of travel costs. And for an international astronaut, it'll be $5,000. So even if we get, you know, $500 from 10 people, we can sponsor an international astronaut. And we're working pretty aggressively to try to work through the individuals and see who wants to come and how many we can bring on. So that's my one plug. What I'll say is that it is not our intent, ARIS's intent, to make money off of this. Our intent is to celebrate this activity, okay? So just so everybody understands that. So in summary, SARCs and ARIS have really basically pioneered and transformed communication in human spaceflight. And many of you have been involved in it over the years. Even if it's working out with a school or something like that, that's been instrumental in us being able to keep this program alive. And we've all gone through challenges to keep this program alive on shuttle, on Mir, and on the International Space Station. So we thank you all for that. And you've innovated many firsts. AMSAT was instrumental in the AeroSat and the SuitSat activities, as well as all the hardware developments that went along with this and operations for many, many years. And led between ARL and AMSAT, you led the initiatives. You know, recently, and you heard Dave talk a little bit about the interoperable radio system. More recently, ARDC has been engaged, and the capabilities that Dave talked about have been partially, a significant portion of the funding came from ARDC to make that happen. But I think, you know, we've all made this happen, and it's time for us to celebrate and commemorate this and have some fun. So if you can make it, fantastic. And with that, I'll ask for questions. Yes? And I do have one more thing to announce, too.
Yeah, your slide said astronauts, but are you also inviting any of the cosmonauts like Krikalev?
We are trying to do that. We're also trying to get our Russian colleague to come, Sergei Sambarov, who many of you have met over the years. I'm trying to work that at the highest levels of NASA, because the visa requirements are 9 months for if they can get one, because of the political situation that exists right now. So, but we are trying to do that, and if it comes down to it, we might have to resort to a little bit of virtual activity. Okay? Other questions? That's a good question, because I mean, really, to be honest with you, we wouldn't have been able to turn on the radio 2 weeks after the first crew came on board if it wasn't for the Russians getting us the opportunity for an antenna that we could actually hook up to right away. Yes, Barry.
Any thoughts in terms of having this being online in any respect, either before or during or after the event?
Yeah, we will do that. I'm not talking about it a whole lot. I want to start with, you know, how many people want to come there. Yeah. But the guy that handles all of the audiovisual at the Astronaut Memorial Foundation is a real whiz. And frankly, we did a ARIS contact there back in July. One of the things we do, Dave talked about teaching the teacher, where we actually turned the tables and let the teachers talk, and we did it through that facility that we're going to be at. So we know we got good practice with them when we went to the space conference. Other questions? Well, the last thing I have to let you know about, and I'll let Lou's got a question or comment, is that we're going to open the website up, I'm pretty sure on Tuesday. We've checked it out. We did a final test it like you fly activity with it, and I have the ticket now. that we put on board, that we put in there and did full registration. So I think it'll work. There might be some quirks at the beginning, but have at it. It will be, thank you for asking that question. It will be on aris.org. And as you know, if you go to aris.org, you'll see a bunch of tabs. You'll see a tab for the 40th anniversary. Okay? So it's we're trying to make it as straightforward and recognize people know ARIS, so go to the ARIS website. If AMSAT wants to set up a link to it, great. That'd be a good idea too. Okay? Luke, go ahead.
Yeah, I just wanted to say that, well, first of all, I'm very proud to have been involved with all this over the years. And this thing is going to happen in February. It's the weekend after the Orlando Hamvention or Hamcation. So you come to Orlando, go to the Hamcation, stay to the next week, and do this. It'll be a lot of fun. And hopefully I can promise warm weather. Not this warm, though.
Thank you, Lou. Anybody else have anything? Okay, well, thank you all.
All right, thank you very much, Frank. That was an excellent presentation. Next up, we have it's on here as non-amateur satellites, which is not right. So the actual title that I'm supposed to say is, you have to listen carefully, Planned Non-AMSAT Amateur Satellites by Paul Stetzer, our Executive Vice President. Supports on this on the wrong side. Yep. See if it'll reach. Okay, thanks everybody. Again, my name is Paul Stetzer, N8HM, and I'm going to just do a real brief overview of some upcoming satellites that may or may not happen. They have been either coordinated or submitted for coordination from the IARU. Again, some of those don't end up flying, but or get delayed quite a bit of time. But I'm going to go through a few of them, and because there are some interesting ones on that list with some interesting capabilities. So the first one is apparently scheduled for launch sometime in the fourth quarter of 2023. This would be basically an FM transponder from China into a relatively 500-kilometer orbit. It would also have a X-band image data downlink experiment. I would expect that may only occur over China, but well, I guess we'll just need to find out from that. But that may or may not be coming up sometime in the fourth quarter of this year. We really don't have a ton of visibility into a lot of what these organizations are doing, but that's something to keep an eye out for. And of course, when we get any information, we do try to publish that through ANS. So that'll be, that's CRAC, Chinese Radio Amateurs Club 01. Now they also have a second satellite that they're planning to go, also scheduled for the fourth quarter of this year with similar capabilities. I think actually, yeah, it might be an identical satellite that is going into on a land space technology launch this year, also with a FM transponder and that X-band image downlink. And yes, I've pulled these. Whoa, sorry. I guess I'm too loud.
I've pulled these directly from the IARU coordination page. So again, that's where I'm getting the information here. Yes. Yep. Sure. Oh yeah, yeah. They probably cut and pasted their details as well. So, it's also possible those are the same satellite, and we know they're not. Okay, Drew's saying no. So, good to know. Next one, BY70-8. There have been other BY70s. This one also apparently has an FM transponder, as well as a voice and image data downlink experiment on X-band. Again, with some of these X-band, we found that they've only been active over the ground station, but it's potentially, if you do have the ability to receive X-band and track a LEO satellite at X-band, it's possible this will be enabled more, and may be a good test case for things like getting your station ready for Golf T's X-band downlink. More Chinese satellites. Again, a lot of these are planned Chinese satellites. There's a CAS-7A, which never did launch. I don't know if that is still planned. This one has a number of transponders, including an HF downlink on HF, or I guess that's an HF uplink. Yeah, so an a 10-meter uplink or a 15-meter uplink and a 10-meter downlink, a 15-meter uplink and a 70-centimeter downlink, CW telemetry beacon on that's going to be on I guess 10 meters would be the beacon. A VHF UHF linear transponder, a VHF UHF FM transponder, and UHF. Again, this is similar to FO118, which was launched last year, but has a few more bands on it. Again, we'll see this now expected to launch in July 2021, and did not launch yet. So we'll see if that happens. But again, point of this presentation is just kind of go through some interesting satellites that have been coordinated. There's also a series of 4 satellites from CAMSAT, the Chinese Amateur Satellite Organization, CAS-8A, 8B, 8C, and 8D. I believe they have similar capabilities, although microsatellite, and then CAS-8A is a pilot microsatellite, CAS-3B is the primary microsatellite, and then there are 3 CubeSats. These are going to have VHF, UHF linear transponders, and the expected date of launch for at least the first one is the end of, no earlier than the end of 2024. So you can read through the details on that on ARU, and I apologize for popping. Try not to do that too much.
Hey, Paul, if you're back away from it, he'll turn the gain up and you won't pop.
Okay,
Yep.
Sounds good.
All right.
All right. Okay, now this is the one I mentioned earlier when Frank was giving his talk on lunar frequency coordination and the not using 70 centimeters behind the moon. This is Lunar Oscar 2, planning to launch in 2024, so presumably this will be along with the Chinese Cheney, I believe it's 6 mission, although it doesn't say that on here. That's likely what that is going to be right along with. It's from the Harbin Institute of Technology as well, and this is a follow-on to that first lunar orbit satellite, which was LO 94, right? Lunar Oscar 94, and it had a digipeater on it. Only a few people made contacts. Drew, did you got through the transponder on that one, the digipeater, right? Oh, you never did get around transmitting, yeah. So there were a handful of contacts made through that with, I think it was JT4G, which is one of the WSJT modes. I know there was a contact between a station in Germany and I believe it was in a station in China on that one. So interesting experiment if it does work out. So I believe, from what I remember, it's a very similar operation to that first one. It also have an image downlink from an infrared camera and that digipeater. So certainly a good test of your 70 centimeter capabilities to receive signals from a 14 kilogram satellite in lunar orbit on 70 centimeters. So you need a good antenna system, but certainly I know quite at least a few hams here in this room. I think Bob, you copied it. Did you get into the digipeater at all or not?
No, I managed to get 90% of what was coming down before they changed the lottery. That was a 28 element.
Yeah. Yeah. So repeat for anybody viewing on the YouTube stream, Bob N6RFM did receive about 90%, 98% of an image with his 28 element system, a 70 centimeter beam. Yes. I'm sorry. Yeah, I do have a tendency to want to get close to the microphone because that's often the advice you get. But yes, this one is a bit poppy. Okay. Now this is a Japanese CubeSat. That's actually, the frequency coordination hasn't been complete yet, so I don't know if Drew has any further information on any of these that he can share. Certainly is welcome to do so. But this is a 1U CubeSat from the Institute of Future Science, Happy Science University in Japan, and this will have both a camera downlink that will be converted into an SSTV signal and transmitted by an SSTV downlink. So I guess there are, and I think it's from what I'm reading here, that there's the stations will actually be able to send DTMF codes to request that the satellite take a picture, and then it will downlink that. And it is planning a JAXA launch into a 540 kilometer orbit, although this does not state when that might occur. Oh, the launch failed on this one? Oh, okay. Well, then I guess this is no longer upcoming, unfortunately. All right, next one here that looked interesting. This one does not have any sort of amateur radio functionality on it. It's called ENZO from the University of Montpellier. However, it does have an HF beacon on it at 14.099 megahertz, which would be interesting to potentially receive a 20-meter signal from space, and depending on the status of the ionosphere, I guess the mission is to help characterize the ionosphere with that downlink on 20 meters through the ionosphere. Again, the launch is planned. Must be planned on a transporter mission. SpaceX from Vandenberg in Q4 of 2023. So I would have to imagine that's one of the transporter missions that's potentially upcoming. But again, to be determined when any of these reach orbit, or if any of them do. But and finally, the last one, again, we've discussed earlier. This is not completely non-AMSAT because this is MainSat-1, MESat-1 that will have AMSAT's linear transponder module on it, and hopefully we'll get on the next. Hopefully that's on the next Firefly mission, and we'll see when they launch. We may not have a ton of notice on that, but hopefully that will reach orbit, and we'll have another AMSAT linear transponder in orbit. And that's all I have for this presentation. Again, I just wanted to go through a brief overview of a few satellites that caught my eye on the IARU coordination page. Because a lot of these groups, unfortunately, they don't directly share this information with the AMSAT community, with AMSAT, with the amateur radio community. We kind of have to go search for this stuff, and maybe once it launches or a few days before launch, they'll finally tell us more details about it. So stay tuned. I always do enjoy going through to that AMSAT-UK's IARU coordination page and just reading through some of the stuff that is being planned, and checking it out for potential new satellites to listen to or potentially work through. So again, that's all I have. If there are any questions, comments. Yes, Burns, wait for the mic here.
Yeah, this was just a suggestion. If anybody wanted to prepare for the 77-meter downlink from Lunar, might be a good idea to try listening to AO109.
That's a good point, Burns. AO109, with that about 8 milliwatts transmit signal now. That's if you can hear that well, you're probably going to be equipped to hear that lunar satellite from lunar orbit. So. All right. Well, if there are no more questions, then thank you very much. And we'll get on to the next one.
All right, excellent. Thank you very much, Paul. Appreciate that update on those non-AMSAT amateur satellites. One more time. You want to put that up there? Well, you put it up there? You want to just put it down there? Let's plug this in then. There we go. Yeah, we've got Kent up next here. Yeah, Kent's up. All right, so next up we have Kent Brittain with his space-qualified antennas. And there we go. Where is Kent? Hey, there you are. We caught him off guard. Well, you're early. You can talk more, Kent.
Me?
Yes, he can talk.
Use this forward and backwards, and here's the green arrow that works on that screen.
There you go.
Absolutely fantastic evidence of technology.
Just stay back from the mic if you would, please.
And what's up and down on this one? It's on my thumb. Okay, never mind. Okay, we're going to talk about some of the problems you have when you're putting an antenna in space. We've got a few of these been floating around. These are an LNB. This is a complete down converter designed for narrowband services in Europe. These have been floating around for about $5 on eBay. I'm afraid in the last 24 hours that may have changed a bit since we got the information out to these guys. But this is AMSAT 1040N, comes out 462 megs on the one I tested. If you want to listen to single sideband, it comes out at about 380. And it is stable enough for CW and single sideband. This is your down converter. Now there's going to be a temptation to put this on a dish. You can't track a LEO with this on a dish. Hold your hand at length, look at your thumbnail, and that's the size of your beam, and you're going to hold that on a LEO. And if you say, I've got 1/10 of a degree resolution on my positioners, I've got the satellites and everything else, do you allow for atmospheric distortion? It bends. I've been tracking Oscar 0 with a 12-foot dish for many years. Oscar 0, by the way, is the one that God put in orbit 4 billion years ago. Some of us use it even though the batteries are still dead. If it's not 500,000 miles, it's not really a DX contact. But we would see that Moon the optical moon and the radio moon to be in two different places. And I asked Tom Clark about this. I said, well, you guys use the big dishes. If I have this with a 12-foot, what do you do? Oh, we track 4 quasars horizon to horizon, do a least squares best fit analysis. And our tracking program includes barometric pressure, relative humidity, and current air temperature. So good luck tracking it. What we're going to actually be looking at doing is coming up with some horn designs to go on this to drop the gain from 36 or 37 dB back down to about 20. That gives you a much broader beam. And as you can see, the horn is really easy to remove on this guy. And there's the information on the part number for it. Now, what I'm hoping we're going to be able to do, now that we know there's a lot of these out there, this is not the only one for narrowband services. There's a lot of other narrowband service LNBs as we track them down. If you know anybody who does a lot of satellite receive installations, let us know. Let's talk with them and see what we can find for some LNBs that are also for narrowband services. The ones for DirecTV are a phase lock DRO. They're okay when you're looking at something 500 megahertz wide. It doesn't work with narrowband signals. Want to cover this real quickly. This is a Vivaldi antenna. You can think of it as a cousin to the rhombic antenna. It's fed at the back, signal goes out the front. The width, whoops, the other button, okay. The width right here determines the highest. Well, I gotta see it too. The gap right here determines the highest frequency it works at. The width here determines the lowest frequency it works at. Making these work over a 10-to-1 frequency range is not a problem. They're very broad-banded. In this particular case, I put a dielectric lens out on the front and was making it circularly polarized. But that's not the objective. I just want to show that these form an antenna by themselves. Okay, this is the one that's been through a few variations. It started out on the left and they kept adding more bands they wanted it to work on. So this is a super secret design from the 1930s called a planar disc antenna. Very broad-banded. On low frequencies, it's a fat dipole. As you go up, it kind of, I'll figure this out in a minute. Too complicated. I'll be using that one I want to use. Okay, as you go up in frequency, it turns into 2 Vivaldi antennas. So it's very omnidirectional low. As you go in, it kind of becomes more of an oval shaped pattern. Ideally, when we put one in orbit, it'll be positioned about like this, flat. Now the energy will be going at the horizons. So a person directly underneath and a person over at an angle will be getting similar amounts of energy. Then they said, you know, well, this is going into the EDIS. This can also become the 435 meg backup antenna. So right here we have a little inductor that is the base load for a top hat vertical, and it also becomes an RF choke to keep the microwave signals out of that antenna. So now it's also now the 435 backup in addition to being the L-band, S-band, C-band, and in theory, it works up to 26 gigahertz, which is really the limit of the SMA connector. Here's a 10 gig. We've done quite a variety of these. These are on space qualified PC board material. Did an interesting trick on these. I picked a length-width ratio that gives the feed point impedance here to be 100 ohms. So I have 100 ohms, 100 ohms, and they meet at a 50 ohm trace. The 50 ohm trace tapers to 100 ohms twice, and now I'm back to 50 ohms again. So the impedance matching is tapered lines and the shape of the patch, that's the word I was looking for, itself. This was the first antenna I put into orbit. It was initially made as an ILS antenna for a business jet. The owner of the company had been an F-14 pilot, so it was Tomcat Aviation. And as you can see, we got two little F-14s on it too. He thought that was extremely cute. Depending on what components we put here, this can be tuned anywhere between 50 megahertz and 400 megahertz. Your choice. Also, we have where you can put an inductor and a capacitor in series, and those become notch filters. So you can tune this to one frequency and simultaneously notch at the antenna two other frequencies. Well, got a call from a group down in Austin who was building a CubeSat, and they needed a 137 meg antenna. This was going in a getaway package on the Space Shuttle Endeavour. Do you know how much paperwork there is when you put something on a man-rated spacecraft? Fortunately, this is on Arlon 25N PC board material, which is space qualified and was used inside the cabin of the space shuttle. So that saved me about 5 pounds of paperwork. But because it was going into a getaway package, they couldn't put anything external to the CubeSat. So this became a conformal antenna to this CubeSat. And I think we were checking with somebody yesterday, can we make this twice as long and tune it down to 10 meters? And the answer is probably. When it's you drive it right here, so it's a combination inverted F and loop antenna. And again, by choosing what components can go here, you can tune it over a broad range of frequencies and get rid of two others. One thing I want to make real quick here is on space qualified. They are very, very, very finicky about outgassing. Normal PC board material in space outgasses. It tends to collect on optics and solar cells. You're wondering why your CubeSat has suddenly had its TV camera develop glaucoma? You wondered why the solar cells are degrading faster than one would predict from the radiation? It could be outgassing from your circuit boards. So there's a lot to be said for taking your boards after you've finished and sticking them in a vacuum for a few days and go ahead and take care of the outgassing. This is one I'm currently doing for Moorhead Group, Moorhead, Kentucky, which we talked about doing a couple of, how exactly were you wording that, Jerry? We're exploring partnerships with Moorhead for you guys. As for me, I'm already working with them. So they wanted a broadband antenna. This will be hinged at the back, held right here in the front, and is now deployed. This turned out to be not big enough for them. They want to go even lower in frequency, so the next one's going to be a little bit bigger and limited only by the size of the local PCB processing tanks. And yes, mass was an important consideration. Log spirals. A lot of guys start talking about these because, again, they have very, very broad bandwidths. I'm going to figure these buttons out yet. How fine you can do the artwork in the middle determines the upper frequency. Outside diameter determines the lowest frequency. These have roughly 10 to 1 frequency spans. There are commercial ones that go as high as 40 to 1 frequency spans. The bottom one was originally developed for my own personal antenna range. I was doing a lot of circularly polarized antennas, and I needed to have a polarization reference. One of the problems with actually putting these together is the input impedance is like a transmission line. You don't have a hot and a ground. You have like twin lead, and I'm going to get this figured out yet. The input impedance, we need a bigger piece of foam on that. The input impedance is about 120 ohms. But I gotta see it. I know. We'll do it this way. Now I can see it and talk. Yeah, but now I can actually see what I'm talking about and point it out. Okay, this works out better. So right here we have an input impedance of about 120 ohms. Kind of hard to do with coax. So we use what's called a taper balun, sometimes called an infinite balun. We start out at about 50 ohms here and taper, and now we're 120 ohms parallel. This ends up somewhat setting how long your cavity is going to have to be behind it. But we'd set it up one way, and we're left-hand circular polarization. Do it the other way, your right hand, or as Tom Clark used to say, you have right and wrong polarization. And that's one that I do for the U.S. Navy to mess up monopulse radars, but that's another story. Well, this guy talks me out of a pair of these. Again, they were made for my own personal use. And he was kind of fuzzy about what he wanted, so I sent him a pair. I'm at Xenia last year, and he shows up and says, remember those antennas? Let me show them to you. And they're on an electronics intelligence satellite. They're now in orbit. I'm going, what? That's not space qualified material. We put it in a vacuum for a week, we're happy. Now, this is another, we had the Vivaldi antennas. This is another Vivaldi antenna, and one of the big challenges is to get two of them to slide together, so that you got vertical and horizontal. Well, when you slide them together, you cut this in half, and that doesn't make, I never could figure it out. This guy in Florida has been harassing the bejeebies out of me to do crossed Vivaldis. Kent, I don't understand your problem. You can buy them from China. So he bought some Chinese ones and sent them to me. Now, I guess I have to be careful. Like, let's say, calling this antenna a piece of defecation is insulting defecation. This guy averages 3 dB return loss. For those of you who are into SWR, that means it averages about an 8-to-1 SWR. If you've ever done any PCB microwave layout, they terminate the line with a radial stub. A radial stub works on one frequency. And this is a broadband antenna. But all the little doohickeys slid together. So using my Vivaldis and their slotting techniques, I've now got some crossed Vivaldis. So I'll have to ask for your forgiveness. I have stolen intellectual property from China. A few of you remember Michelle, W5NYV. We discussed about 10 years ago the idea of converting these into dish feeds. If we put a little 90-degree hybrid like the ones that are available from mini circuits in there, drive the two Vivaldis 90 degrees out of phase, we can now have a very broadband circular polarized antenna, which would work good as a dish feed. So this is a 10 gig Vivaldi but that would become a new dish feed and could work over at least 3 ham bands. If we pay big money, we can get it over 4 ham bands. Dish materials. This is in black and white because it was a long time ago. This is a picture of Voyager. That is a 10-foot carbon fiber dish. They took it out on the antenna range, tested it, it met specifications. As a weight savings, it was never metallized. Those pictures came back from the outer planets on a carbon surface dish. Please tell me again that stealth aircraft are made out of carbon fiber because it's radar absorbive. Once you get above about 1 gig, carbon fiber looks just like sheet aluminum. This is known as a scimitar antenna. It looks like a scimitar sword. The inside radius determines the highest frequency. The outside radius determines the lowest frequency. And it's very happy working on its harmonics. The Apollo spacecraft were covered with these. They were using them on all frequencies on both the Apollo spacecraft and on the service module, sending data back. They're a great broadband frequency antenna. We were doing some for a C-130, so I made several up. You saw the one that was there made out of carbon fiber. I guess I need to back up one. We had a question. It's really challenging to solder carbon fiber, okay? Believe it or not, for a demo at one of the antenna contests, I showed up with a carbon fiber Yagi antenna. One, we had copper mesh all the way through it. One, this has only got about an inch of carbon mesh in it, so I could have something to solder to. And then I had the one that was solid copper. On the antenna range, we could not tell the difference between the three. So carbon fiber works pretty good. One of the headaches we have is the feet. I'm going to get this figured out. Uh-oh. Use that one? Yeah. Oh, great. This modern technology. World's gone downhill since CPM. Okay, that one right there. The input impedance of this guy is about 20 ohms. So it's a very low impedance input. I'm going to get this figured out yet. I need a boom mic, I guess. Okay. So we're back to using a version of this where we use a taper balun again, although in this case it's just a taper line. And I'll make this end 50 ohms, or actually look more like the other way. We'd make this end 50 ohms and then slowly taper to 20 ohms. And then we get a broadband match on the antenna and we get something that works over many gigahertz of frequency range. I stated I didn't like helices. I don't like ham helices, I guess would be the best way to put it. I've had well over 100 of them on the antenna range, and less than 10% are circularly polarized. Just because you made it a curlicue, it is not circularly polarized. This is an actual NASA one, part of an uplink system. They have an insulated boom, insulated spokes going out, and keep the line isolated. When I have a radio wave traveling down along a wire like this, it travels at about 95% of the speed of light. Some variation there depending on diameter and if you got paint or anything else on it. But guys will build these. I just put that transmission line on a dielectric. It's now going to be moving at about 60% the speed of light. Now, I'm not saying you can't compensate for it because I just used a formula that we took out of a textbook which assumed that the coil is in free space traveling at 95% the speed of light, and now it's traveling at about 60. What happened to your axial ratio and turns ratio? But it's easier to make this way. I'm not saying you can't compensate for it. All you have to do is know the dielectric constant of this plastic. Next time you're down at Ace Hardware, ask them what the dielectric constant of their PVC plastic is. Oh, I'm smarter than that. I looked it up on the internet. The standard procedure for measuring dielectric constants of plastic is to measure it at 1 kilohertz. I can assure you by the time it gets to this frequency, since I've made these measurements, it's dropped about 30%. Now, another thing is you can make a helix that looks like a nice helix, put it out in the antenna range, and axial ratio is if I take it and I turn it, how much does gain change? If it changes less than 1 dB, we pat you on the back. If it changes less than 3 dB, you can call it circularly polarized. I have seen in excess of 20 dB. That's roughly equal to the axial ratio of a Yagi antenna. what you can end up doing is taking these, and I did it again, and start trimming off the tip, 1/8 of an inch at a time, maybe 1/4 of an inch on a 2-meter one. And you will now change the axial ratio of the antenna. And you can find a place where it's actually circularly polarized, but just where you stopped ends up making a difference. Another antenna I have an issue with. It was learned 60 years ago that if I take a log periodic and I bend the elements forward about 30 degrees, it'll work on its third harmonic. You see this very commonly on TV antennas because channels 7 through 13 are the third harmonic of channels 2 through 6. There is currently an antenna made by a company with a name similar to a cousin of a moose, which thinks that you can make a log periodic with straight elements work on the third harmonic. If you happen to have one of those antennas, turn it around and point the ass at the satellite. You will find the signals get stronger. I've had a discussion with the guys on that, and they're saying, we're selling them well, what's the problem? But this is one that was actually made, one of my AMSAT type versions, and this is a 2-meter, 440 log periodic designed to work on its third harmonic. And it's been published. I probably need to write a better write-up on it sometime, but it's easy to use. We were discussing planar disc antennas, again, a super secret design from the 1930s. Speaking of which, I recently got a very nasty letter from Turk Antennas saying that I had stepped on their patent. I got out a book showing how to build a TV antenna to build to watch the experimental television transmissions from the Empire State Building during the 1939 World's Fair. That antenna design was in the 1939 book. Sent copies of it to their lawyers, and I haven't heard back. But this is the planar disc. I've made them in different sizes, and I've got some real little small ones that will actually work as a 10 gig omnidirectional antenna. So go down to your favorite dollar store, get you some 18-inch pizza pans. You want the steel ones. They're much easier to solder to than the aluminum ones. Pardon, David, aluminum ones. Mount them as close together as you can right here, and you now have a 2-meter through 1200 meg antenna. Something, I've got one of these hanging in the attic of my house, and it goes down to one of my scanners. There's one that I made out of pieces of PC board cut round. Here's one that these are used for direction finding. This is known as the sum and difference techniques. Here we have two antennas, and they sum together. These two antennas are 180 degrees out of phase. And there's the 220 version up, 2.4 gig version up there. We've done some testing with them in some labs. And this is what happens when you sum the two antennas together, and you get additional gain. When you have them out of phase, you get a null in the middle. So the bottom one right now is being field tested in the Ukraine. The frequency is for GPS. So you hook up the bottom one to your software-defined radio or one of the other ones, and you listen to the Russian GPS jammers. This locates it to about 20 degrees or so. Now you know about where it is, so you hook up this one that gives you a null, and now you can locate it to about 1 degree. Send a couple of mortar shells down that line and see if it gets quiet. We could improve the side lobe patterns a little bit by putting radar absorber on the back of those antennas. There's some wraparound energy going there. And radar absorber tends to be pretty expensive. But if you get some of those sheet magnets that, put Acme Lawn Care, or the smaller ones are on business cards, This is iron-loaded rubber. It's not as good as the $100 a square foot stuff, but it ain't bad. So this is a cheap source of radar absorber. You got an amplifier that works great until you put the lid on it and you trap everything. Well, go take some magnets off of the fridge and put them in there, and maybe you'll stabilize it when you put the lid on. Oh, this was a fun one. I have a missile. I have an antenna on the tail of the missile. I very carefully and meticulously look at its pattern. Then you light the motor and you have 20 feet of plasma coming out the back. What happened to my antenna pattern? So we were doing some pattern measurements while the motor was running, and we might have had this one just a little too close. This is a 435 meg patch antenna. I've been wanting to make these for years. The question is, how do you solder coax to aluminum foil coated styrofoam? This is the styrofoam sheathing that you get to put some insulation in the walls of your house. Costs about $3 for a 4 by 8 foot piece. And what I finally figured out was I did it again. You get a piece of sheet, tin, brass, your choice. And over in the next aisle, they sell the aluminum tape for holding stuff together. So this has got a little piece sticking down, put some of the aluminum tape around it, and then I do the same thing on the back side, and that's how I attach the coax connector to some tape, and you can make some big patch antennas. So nothing like have something that sits flat in your attic and you can work AMSAT with it. Here's another one. These are some 1269 antennas made just for AMSAT, available to get down. And what I'm trying to show here is you don't have to put all the elements on one boom to get circular polarization. You can have two antennas close together, one vertical, one horizontal, and get the CP out of that. Here we've got one horizontal, one vertical, and you've got circular polarization. Well, it's right-handed. I want left. Well, just unbolt this, turn it around, flip it the other way, and now you got the other polarization. Nearly 20 years ago, not very far from here, there was an AMSAT convention, and I did a talk on this, and I guess it's time to remind a few people of it. And that's when you mount Yagis. When you mount a Yagi and you stick a pole right through the middle of it, you get a coupling effect, and essentially it makes this element and this element appear longer. You could allow for this by trimming some elements off, but much better ways of doing it. The headache comes with the guys who like to put up the cross Yagis, and then they use fiberglass boom coming across, and then run the coax back along the boom. Well, the coax is an electrical conductor. You've still done the same thing as having a metal boom. We put these on the antenna range. We actually made the measurements, and we found that when we used, we mounted the antenna X fashion, ran the element as close between elements as you could, used a metal mast, and then ran the coax back along the metal mast, the circularity distortion was about 1/4 of a dB. So now you're not disturbing the antenna, you don't have the coax running out the back, you haven't had to find a strong fiberglass, and it still works just fine. So this is a good way to mount them. I'll let him get his reference. Okay. This is one I'm working on for another plan. I kind of fell away, but this is just one thin sheet of circuit board material. And the idea is that this is a lot cheaper to make, real easy to make, and then you mount it about 1/2 inch above user supplied sheet aluminum. And this becomes an uplink antenna. And again, you'll note that I've picked a design that gives me about about 100 ohm impedance here. Bring them back, I'm 50, 50 back to 100, 200s back to 50, and so forth. So there's my power divider. Tail warning radar dish out of a B-29 and a little log periodic feed. So it gives me nice broadband for used on 2, 3, 5, and 10 gig. And my antenna range, when I've got it set up and using it, I've got about 300 feet I can work with. So, comments, questions, insults? That's silent.
Speaking of antenna coupling, reminds me of all the social media posts we see where people have their arrow antennas and mounted within that their phones, their radios, and all sorts of devices in between the elements. But it looks cool.
It's simplistic. Duct tape is a time-honored tradition. I also have a 1269 PCB Yagi that mounts onto the arrow antennas at about a 45-degree angle. And on my website is the files for printing out the clips that hold it onto the boom.
So another time-honored ham tradition is fox hunting. And I'm wondering if you have any thoughts about a convenient handheld 70 centimeter or 2 meter directional antenna.
Well, we're looking at, you're looking at my next column for CQ magazine. You can make some little 2-element Yagis who do them like this and have them find approximately, then switch like this and null it, and you can get 1 degree resolution. The biggest headache is explaining to the guys how to make the power dividers to bring them together. And one of the easiest things to do is to take those little couplers that are made for your TV set, so you can put 2 antennas on one or 2 TVs on the same one. They're a little hybrid transformer. They don't care what impedance they are. So you can use them as, take the 75 ohms and just put some 50 ohm adapters, or take the hybrid transformer out and put it on 50 ohm connectors. It doesn't care. It's a 2-to-1 transformer, so it doesn't care what the impedance is. More silence. I return control of this menagerie to you.
All right, thank you very much, Kent.
Hey, Kent, just one comment from the internet, Kent. Mike N1JZ commented that he had tried that 1269 log on his arrow and it worked quite well. So.
I got a complaint from him when or one of the guys who had it. One of the complaints I got was, when I use the arrow, all I got to do is just kind of point like that. But when I have the 1269, I got to point like that. Well, it's a 4-element versus an 11-element.
All right, again, thank you very much, Kent. Thank you to all the speakers who were with us yesterday and today. That was the last presentation we have for today. I will remind you that these presentations will be available on the internet. They're not all out there just yet because we didn't get them all in time, but they will be up, including corrections, if any, just like the correction I'll be making to my slides that has AO40's mass as 1 order of magnitude off. So corrections and amplifications, as they call it in the news industry. Again, that does conclude the symposium, the 41st AMSAT Symposium this year. We will take a break until 3:30, where I will turn it over to Robert Bankston, the AMSAT president, for the AMSAT annual general meeting and award ceremony. So please be back, let's say about 5 minutes early, let's say 3:25, back in this room, please. Thank you very much.
want to see my drill sergeant voice? Good afternoon. My name is Robert Bankson, KE4AL. I'd like to welcome you to the AMSAT Annual General Meeting. We have those in attendance as well as those that are attending live via YouTube. Of course, we're here in Irving, Texas. So before I get started in the actual general meeting, I want to say what a great symposium. I want to thank all the presenters. Some great information. Thank our internal teams, engineering, education, with sharing what they're working on, as well as what's going on around the AMSAT community. I would be remiss if not mentioning a special thanks to Frank Karnauskas and Zach Metzinger, our hosts for this year's symposium. Having been the host for 2 of the past few years, I could tell you my hat's off to them. What a great job. So thank you very much, Frank and Zach. Today's general meeting, we're going to talk about the state of AMSAT, where we're at, where we're at as an organization, and who our leadership is, our financial position, a membership, and as well as my little report card of how we're doing. So hold on to your seats. It's going to be fun. After that, I'm going to talk about what we're doing in the future. What I like to say, onward and upward. Talking about a bold vision for tomorrow and keeping our promises to our members and to the AMSAT community. Okay, these are our board of directors. New this year is Barry Baines. He's not really new. He's been around before. We'd like to welcome him back. WD4ASW. I can never remember your call sign, so what I do is every time I have to write your name down, I have to Google it. But just say AMSAT Barry and it pops up. That tells you how long he's been associated with this. Yeah. I'll have to think another cuter acronym for that, though. Drew Glassbender's coming back to us. So, Drew, where are you at? Way there in the back. So, appreciate you, both of you stepping up, as well as Frank Karnauskas. He's always been around as our VP of Development and Martha 2, as I like to affectionately call him. But now he's our first alternate. Then also elected this last election cycle was, I believe, Jerry Buxton, as well as Zach Metzinger. I believe those are the other 2 on there. And then the old guard, the ones that were elected the previous year, Mark Hammond, Paul Stetzer, and Bruce Page. The outgoing ones is me, thank God. I was running dual hat for a little while. That was a little confusing and burdensome. So I thank Barry and Drew and Frank for providing their names to be on the election cycle, as well as Armbruster, Joe Armbruster, yep. So thank Joe for his service as our director. So these are the guys that provide direction. They also control the purse strings, and a great team. So thank you for electing them. Officers. So these were the same names, but they were re-elected in this recent board of directors meeting on Thursday. Myself as president. Executive Vice President is Paul Stetzer. Vice President of Engineering, Jerry Buxton. Assistant VP of Engineering, Jonathan Brandenburg. Vice President of Operations, Drew Glassbrenner. Vice President of Education Relations, not education or education outreach, he'll remind you it's Education Relations, Dr. Alan Johnson. Vice President of User Services is vacant. And if you would like to be a part of AMSAT, and I'll be talking more about that, I'd love to hear your name. VP of Development, which also stands for Marketing for the layman, is Frank Karnauskas. Our Secretary, Jeff Davis, who was unable to attend this symposium due to some family issues. So we wish him well, and can't wait to see him when he comes back. And our Treasurer, Steve Belter, who I think his wife had something come up, so he was unable to attend as well. So all these are our officers. They've been doing a great job, and they really help my job be a lot easier, so I thank them for that. But they're not the only ones. We have our managers and team leads. We've got Joe Karnowski as our senior editor for the AMSAT Journal, and you always hear the term herding cats. Well, he's got to go out and chase them down and bring them in, trying to get articles for the AMSAT Journal. So Joe, where you at? He was here earlier. Mark Johns is here in the back. He is our ANS senior editor. Does a great job of, they work a rotational staff. There's about four of current rotating editors right now on a weekly basis. And I am subscribed to their coordination list. And let me tell you, a lot of traffic that work together, so I appreciate that. Our Getting Started guide, if you've looked online or seen any pictures, it says 2020 on there. And that's the last time that we published one, right in the heart of COVID. We are without a senior editor at this time, so we are in search of a senior editor. I'll be reaching out to the membership to try and fill that position. I've got a couple people that are already willing to step in and help, as well as Steve Belter, the outgoing one. He says that he will help in the transition. But we do need to update that guide. It's a valuable tool for those just getting started in amateur radio, as well as a great reference for those that have been pointing their antennas at the sky for a while. Our Director of Ambassadors, Bo Lowry, lives in Lexington, Kentucky. He's coming us from as a JPL NASA ambassador. He has got when I sat down and talked to him, some great ideas to kickstart and re-energize the AMSAT ambassador. So we should be hearing more from him in the coming year. Now, he's been on board. There was some stuff we had to work through and for a little while, so that should be all kicking off in 2024. Our webmaster is vacant. We're looking for a webmaster. I'll talk more about that, about our website. Right now it's being filled in by our information and technology team, Matthew Alberti and Joe Fitzgerald, and then certain pages and other stuff is being updated by various other volunteers within the organization. Our online store manager is Bruce Page, and our IT team I already mentioned. The Orbital Elements manager, Ray Hode, has stepped down this last year. I don't know how long he's done that, but for a long time. Although he's done it quietly in the background. But Joe Fitzgerald has stepped in his place to cover that. So those are that's my key team leads that are helping me out, doing a great job. And as you notice, there's some vacant positions. We're always looking for help. AMSAT is a membership organization. It's run by members. It's an all-volunteer organization, so it's everybody that helps out is part of AMSAT, and so I hope that if you're a part of AMSAT, you could help out in some way. Okay, where are we at cash-wise? So right now, we're sitting at about $150,000 in the bank. Probably a little bit more than that, but I knew there was some outstanding bills that had to be paid. And $1.4 million in investments. We're with Merrill Lynch. It's an investment broker managed account, so you don't have to worry about me picking which assets we're investing in. They did, we expected to lose about $200,000 last year. We only lost $110,000, so we were pretty well positioned. Since then, it has come back up, and hence why we are back at $1.4 million. That sounds like a whole lot of money, but when you figure out the cost of space, that can go quickly. So don't be surprised when we ask for more. 2022, so almost a year ago, we had generated $478,000 in revenues and had $191,000 in expenditures for $287,000 operating, what we call a profit. Now, of that 287, 109,000 of that was through a generous grant from ARDC, who are helping us with our open source 3U CubeSat structure and deployable solar panels. So we thank them for that. So if you take away that 109, you're looking at about 180,000 just from our volunteers beating down the doors, trying to get money in and selling items on our store as such. And the ugly number there, investments, I guess I should have put that in red, where last year was a tough year for anybody. If you have a 401k, you'll know it hurt last year. So we end up with a net 177,000. We're probably somewhere around there, if not a little bit more for this year so far, year to date. And if our treasurer was here, I'm sure he would have brought you up closer where we're at. Any questions on the money? Okay, our current membership, I think last year I mentioned we had 4,000. Well, guess what? We're 50 shorter this year, 3,950. Of those, 1,946 are our annual renewals. We have 29 current student memberships. Those are, it's at $22 per year. I can't tell you the age grouping of those because we don't ask for age or race. Some of those are grown students. Some of those are young students. I would like to see that number a lot bigger. So we will be looking for some ways to improve our student membership either through a reduced cost or more promotional efforts. Lifetime members, 1,916. Lifetime provisional, that's the one-year payment plan. We're at 26. And society members, that's at 7. Most of those are amateur space and amateur radio clubs throughout the United States and Canada. I think there's one that's overseas. So the number that fluctuates, it goes out, goes up and down, you know, plus 50, minus 50, plus 50, minus 50. And it looks like on average we've lost about 50 members. I would say part of that is, unfortunately, some of us are getting older, and so they've passed away and became a silent key. Some of those are upset that we no longer have the printed journal. And some of those are mad because when you log into the member portal, you have to click the robot. I'm not a robot. So believe me, I see every email that comes in to the AMSAT membership portal, and I just have to smile. But we're here to help you and serve. Okay, the President's Report. Okay, I'm fixing to give some grades. We'll do A through F. A for doing great, F for they are in trouble. This is not based on the performance of those efforts. This is based on the perception of the performance of those efforts. Basically from our customers, our members, of what they think of it. So satellite-wise, it is a C. And part of that is because right now we're in that lull point between Fox and Golf, or Fox Plus. So we're not launching anything right now. So I always get the answer, when are you going to launch? When are you going to launch it? You know, why is it taking so long? Part of that is that they don't understand the full process, but then the other part will come down when I talk about member services. Education, I would give them a B right now. Both of them are fledgling programs, our CubeSat simulation and our AMSAT youth initiative. Being a B, you know, some great products, and as soon as that they go live with their final products and it gets activated, it'll surely be an A+. Some great efforts going on there, but we do occasionally have people asking for more educational efforts. The Getting Started Guide is one. Hosting the AMSAT Academy at various events across the United States. Those are requests that we get. So we will work toward improving those efforts. Member services, and I have to place this squarely on my shoulders. I'd give it an F. That's a harsh grade, but it's reality what it is. We had I was the vice president of user services about 5 years ago, and then I became the treasurer, and I covered both jobs. And then when I became president, I had to give up the other two jobs, being treasurer and VP of user services. Since then, it has remained unfilled, but that means that I'm the one that answers every member request on the member portal. I don't always get to it timely. Sometimes you have to wait a week or more for a response. So the communication to our members from the member portal is squarely my fault, and I've got a plan to fix that, and hopefully you'll see better service. So my apologies for that. Another part of member services is our communication to you. Let you know what we're doing, not so much on a daily basis, but at least the highlights. It's easy to have your nose to the grindstone and not see what's going on, or not forget to share what you're doing with the members. So we talked about that at the board meeting. That's something we really need to work on. I think I've got a few things that will fix that for the coming year, but we promise to do a better job because you deserve it. Non-member services, that is part of our mission, is to help educate the public. It doesn't say just help educate our members, help educate the public. I'm going to give us a D right now. The D is because, number one, our website it's got a lot of information on there, a lot of great information, but you just can't find it, at least not easily. So we're going to, in 2024, redo our website. We're going to probably put together a team of volunteers to make recommendations, but we're going to outsource the design and implementation of it. And then hopefully we can take care of it after that. If not, we may have to hire somebody to manage it as well, because we don't have a webmaster. In addition of non-member services, we have the AMSAT redirect email address. That's yourcall@amsat.org. That system was created a long time ago, and it was open to the public. It was just a public service that we provided. And unfortunately, with the ever-changing spam rules that ISPs are putting in place, it is a constant battle for our IT team to unblock all the stuff. AMSAT.org, because those redirect email addresses have AMSAT.org, it affects the entire organization. My own emails get blocked to a non-redirect. So I have a rbankston@amsat.org. They get blocked. It doesn't just go to my spam folder, just the ISP says, hey, AMSAT.org, they're a spammer. We're not going to accept that email. So more than likely, the service will either be discontinued, or we may offer it only to AMSAT members, active AMSAT members, because we're going to have to pay for a service. So if we have to pay for it, then we're going to have to make sure that somebody has paid us a little bit. Last time I looked, there was about 4,000 people using the AMSAT email redirect accounts. Most of those are overseas. So it's not necessarily our members that use them. If we do with our members, it'll come back in a new form, probably of AMSAT.net, similar to how ARRL has ARRL.org for all their official business, and they have their .net for their member redirect services. So those are the four areas that I see that of where we're at. Of course, our satellite programs, our engineers are doing some great stuff, although, in today's day and age, we'll get used to getting things quick. Amazon delivers in 2 days. You can go to McDonald's and get you a Big Mac in probably about 2 minutes through the line. And waiting on satellites is just painful. I think we can lessen that pain if we keep you informed of what we're doing, and we're going to work on that. But it's still going to take time for us to build satellites. Of course, education, I'm real happy with them as well. It's the bottom two that we got to work on. And I thought it'd be better instead of pump you full of sunshine, give you some honest feedback. Okay, so let's talk about the future. I already talked about some things we're going to change, but let's talk about the big stuff, the stuff I'm excited about. And we're looking at, how am I doing on time-wise? Somebody hadn't said 5 minutes, so we're good. Okay, so in 2021, we came out with a strategic plan. And in that, our board of directors committed to continuing our development of experimental amateur radio in space toward higher orbits and beyond. And then also at the same time, we recognize our obligation to meet the needs of those just getting started, or for our casual user members, to provide accessible amateur satellite service in space. So those are the two big takeaways from that. In addition, we have a responsibility to share what we learn, not just with our members, but with the world. You know, that's part of amateur radio. That's the spirit of it, to help promote amateur radio, especially amateur radio in space. And we do some great innovative stuff that other people can use. And then as well as we need to promote the training and development of tomorrow's designers, builders, and even our leaders and operators. So we have that responsibility. So bold vision is what I challenge the board with, and we'll see how they react to that in the coming year, is that we need to, instead of just saying we're going here, next, we want to go even further. And then how are we going to get there? The common thing is go to HEO. Everybody wants to go back to highly elliptical orbits. I think it's a great idea. Golf is that plan to get us there, because a lot of things have changed since we were there with AO40 and before. So we need to figure out how to put all those maneuvering devices and everything that they talked about inside of a small CubeSat form factor. Then also, not only where do we want to go, but what do we want to do there? How do we want to communicate? Do we want it to be digital? Do we want it to give the user the option of choosing the method of communication method that they do? Do we want to try and develop new communication methods? And then also, and that all falls back once we figure out what we want, what do we need to do, and what do we have to overcome to get there? Picking stuff that's easy is easy. Let's pick something that's hard that we can't do and figure out a way to do it. So promises kept. Since I've been a part of AMSAT in, I think, 2016, October 2016, I made my first satellite contact when I was on a buddy pole de-expedition in U.S. Virgin Islands. And somebody said, hey, take this Yaesu and elk antenna and make some contacts. And I was hooked ever since. But that motto has always been there, keeping amateur radio in space. So luckily, AO7 is carrying the weight for us. It's carrying our water. It's been up there for almost 50 years. We've got AO91, AO92 is come back occasionally. AO109 is there. But we need a plan that provides a continuous stream of satellites. Fox Plus is the program meant to meet that need. And we're just having to wait for a little bit for it to finish its startup part right there. The supply chain challenges in the past few years have been tough to swallow. But I think we're supposed to be getting CubeSat frames delivered this week or next week. So things will be moving along. But whatever that design is, we've learned from, in CubeSats, you got to use smaller components and you got to really pack stuff in there. We learned some valuable lessons that can be applied as we move forward. And we want it to be simple, low cost, and also reliable. Build it like a tank so it can last as long as AO50. Unless it comes down out of orbit. We can't do anything about that one. In addition, there are opportunities, every once in a while someone will say, hey, we got this opportunity to host an amateur radio payload. Can you help us? Are you interested? And the answer is always, yes, we're interested, but do we have something? So I think we need some solutions that will, could be, couple different options on the shelf ready to go, and they say, would you like to? And we say, yes, here it is, and be able to go, because number one, they're free launches, and every satellite that we can get up there again, or get up there, means more opportunities to enjoy this great hobby. We also have, you know, our LTM is a great product. I think we can do a better job at promoting that. We kind of slowed up a little bit when there was some questions about the PA system, and then also there became some, I think, end-of-life components. I think that's been pretty much resolved, and we will hopefully see more of that activity come in the future. Okay, my favorite part, international collaboration. Hey, when's the last time that we worked together with our sister organizations? AMSAT-UK, AMSAT-DL, AMSAT-JA, etc. So last year we approved an export control and compliance program. That's a fancy name for how do we get around ITAR EAR. And that answer is to make our projects open, be it just publishing it in the public domain to satisfy ITAR, making it available to the public for EAR, doing open access, that's an opportunity, and also for open source. There's all different types of licenses. The big thing is we've got to go open. So now, last year we came out with the policy. This year I presented an implementation and certification program for our volunteers. So we're going to implement or evaluate our programs and projects and get those documented, and then certify, you know, get our volunteers trained and certified, and then we'll be ready to go fully open and not have to worry so much about EAR and ITAR. That exclusion, though, only applies to information. So as we develop a satellite system or a satellite in whole, that part could be open and not subject to EAR. Once we get to the final production stage, we're doing the flight models, then we're still subject to EAR. So if we decide to send a system to AMSAT-UK or DL or something like that, we will have to obtain a export license. What does that mean? I don't know yet. My training hasn't, on-the-job training hasn't gotten that far, but it will this next year. So with that said, I will be extending the invitation to all of the AMSAT organizations around the world to begin, or to put forth the idea of us working together on a project. Whether it be an existing project for someone, us or them, or whether it be to formulate a new plan for amateur radio in space in the future. I don't know. We'll find out. But that conversation is going to begin next year. And with that, I think I'm done with my general report. Any questions? Let's open the floor for questions first. We got somebody already asking for the mic. Just when you give it to them, make sure it's turned off. You'll be next. Yes, sir. Paul, I'm sure you will let me know if there's questions coming in from the interweb.
And here I thought I was done.
Hey, what do you mean by volunteer certification? Explain that.
Okay, so to be a part of the ITAR, EAR, and compliance regulations is, number one, they have some of our systems will be closed. Some of parts of our systems will be closed, meaning not open source. As an example, our ADCS unit that we bought from South Africa is a proprietary piece of equipment. So that restriction that we can't publish the documentation and the software for that will mean that portion of that system will be closed. Meaning that we can only allow we cannot allow non-U.S. persons, and non-U.S. persons is defined as U.S. citizens, legal residents, or people here on protected status. They cannot work on it. So our certification process is simply a form, U.S. Form I-9. They will complete that. It will have their name, their personal information, and they'll have to provide proof of their citizenship, whether it be U.S., Canada, Iraq, Iran, I don't know. You laugh, but we get people volunteer all the time. So they'll complete the training. They'll sign off that they have read and understood the policy and understood the training. They'll submit an I-9, and then once that's done, they'll be certified. Those that are past the U.S. persons test will be allowed to work on those closed portions of projects. Those that are, those that are U.S. based get to work on the closed. Everybody, unless they're from a restricted country published by the State Department, U.S. Department of Commerce, and somebody else, think like North Korea, stuff like that, they will not be allowed to access any information. So it's just a process for us to screen those persons to see if they're restricted or not restricted, and if they are restricted, what level of restriction they'll do. So it's a real simple, we have a technology control program document that's going to get filled out on each project and program, like a one-pager, and then we're going to have a one-page restricted party screening form. So that portion will be simple. The important part is we want to make sure our volunteers that are working on it know their responsibilities. So the training is a key part of that. Yes, sir. Right behind you.
Yeah, Robert?
Yes.
One of the things that I like to do, and maybe others do as well, when you're talking to somebody that doesn't have any experience or information about ham radio satellites, is I like to tell them, as I did with a guy from the UAW I was talking to at lunch, how many ham radio satellites have been launched, which always staggers them.
Yeah.
I wonder if you or somebody in the room has a recent count. We used to count them, but I don't know that's been done lately. Yeah. Do you have a recent count?
Okay, total satellites. So Oscar, orbital satellite carrying amateur radio. What I always do when somebody asks me that question is I go to the AMSAT.org webpage, and then under satellites, and I see what is the latest number that Drew has issued. And it's about 119 right now? 118, 119. Yeah, somewhere in there. So if they don't coordinate, then we don't know, and we can't keep track of everybody.
It's about 120, and then you have probably 30 Russian satellites, actually probably more closer to 40 or 50 Russian amateur satellites. So well over 200, counting all the things on the periphery.
I was hoping to get a closer number than over 200.
Yeah. The key word is uncoordinated. So when they don't tell us, then we don't know. And so we find out about stuff, and there's not a master list to say how many total satellites. I think the more important number is how many that we have done and how many people of our sister organizations have done. But usually I refer to that Oscar number. Whatever the latest Oscar number is, I say, that's a good, solid number I could say. Because some of those could have had amateur radio, that they were using amateur radio frequencies, but they weren't providing an amateur radio service.
Robert, and to answer your question, I'm sorry, not sure your name. There's a gentleman in Japan, Mineo, JE9PEL, and he has a whole long list of every satellite that has had amateur radio on board. I'm not sure what the total is. The format of the spreadsheet doesn't make it necessarily straightforward to count lines, but that list is available, and he has an exhaustive list of everything that's been launched with amateur radio on it, even stuff that failed to get to orbit or never worked.
Sorry, I didn't have more definitive. I wish there was a place, go here, and you could see that whatever number is, and a counter. All right. Any other questions? Paul, was there anything from the web? No. He wants the mic back.
Yeah, so we did have a question from Reed Mertz. Is there a project plan being built that will get us to any of the goals mentioned? Somewhat of a vague question.
Okay, so the goals mentioned, I assume he means by higher orbits and satellite service. So right now there is not a specific satellite program on the table to be launched in HEO or geostationary orbit or MEO. We have Golf, which is a broader program that is designed to help us establish those capabilities to operate at those higher orbits. So it is a stepping stone. But have we actually put a paper down to, a program down to paper that specifies a high Earth orbit? That answer is no. We'll be working on that, and that may be one of the topics that we can discuss in our upcoming international collaboration. As far as the second goal was continued accessible stream of amateur radio satellites. That is Fox Plus. I know one of the sticking points right now is we've got a linear transponder that's close to completion that we can throw in one. What we don't have quite up yet, but we are working on, is an FM repeater. So for those that don't, we designed like the FM repeaters for Fox 1 series. Great repeater. The issue is they were designed way back then, and those parts have since come under end of life. They're no longer available. So now they need a complete RF redesign. Sometimes you can find a replacement chip, other times it needs a complete rework. So they are working on that right now and looking for alternatives. Is that right, Jerry? Is that, correct me if I'm wrong. You can just do it. You didn't hear me.
You were correct, except for the fact the first one will have a linear transponder.
And I would add that VSAT-1 is going to be launched soon with a LTM on it, and there are other university projects in the pipeline.
Yes. So we're making every effort. Would I like to, I'd love to be able to give you a schedule that says on this date this one's going to launch, on this date this one's going to launch. I can't do that yet, but as soon as I can, I will. And the good thing is that launches for satellites are happening a lot quicker. Before it used to be you may wait 2 years. Now it's almost like a monthly basis. Ask Drew, he lives by one of the launch pads. They launch all the time. Any other questions? Your opportunity. All right, if not, then let's take this part of the annual general meeting to recognize some of the accomplishments. We're going to start with our contest and awards program for our field day contest.
Robert?
Yes.
I did just have one comment from going back to the number of amateur radio satellites.
Yes.
Graham Sherville, G3VZV, comments that the IARU coordination team has dealt with 938 coordination requests since the first one, which was AO51 back in 2003.
Wow. All right. So I'm going to turn the microphone over now to Bruce Page, our Director of Contests and Awards.
Thank you, Robert. Every year we have field day, and it's along with the ARRL. We've been fortunate that the ARRL follows some of our rules now, or we follow some of theirs. Anyhow, they've made it a lot more fun. There's a lot more people getting involved. This year was kind of slim, which was rather strange. We had 19 stations participate, and when I say participate, they sent me their scores. And we had 27 satellites. Now, those are not actually orbiting satellites. I count a satellite for the purpose of field day by the mode. So if it has a linear transponder and you can do voice and CW on it and digital, that one would be 3 modes. Otherwise, there's really no way to manage the statistics. So we had 330 phone QSOs, 28 CW QSOs, and the most ever, 133 digital QSOs, which I can't imagine where they all came from. Might have been something like GreenCube. There were a total of 491 QSOs and 802 points. This is the lowest participation we've had since, see, I put a 19 in there. It's 2017. Okay, don't know why. People just didn't want to submit their logs this time. So anyhow, first place this year for home commercial power goes to Dave Jones, W2GDJ. And if you're here, come on up and I've got your your certificates. First place home station on emergency power goes to Brooks Samuel, N5DGK. And then we have our club stations. First place on emergency power, Lafayette DX Association, W9LDX. Second place goes to the Huntsville Amateur Radio Club, K4BFT, or they like to be called Big Fat Turkey. Third place goes to the North Fulton Amateur Radio League, K4JJ. And this year we were graced with 2 participants from Japan who made their contacts over Green Cube. We had Nobutaka JK2XXK and Masa JS1LQI. So I was happy to receive logs from them as well. And that's all we have. Is anyone here from any of those clubs or individuals? I guess they get them in the mail this year. So thank you.
All right, thank you, Bruce. And thanks for all those that participated in AMSAT's field day activities. Shoot, I don't remember where I was that day. I wasn't on the satellites, unfortunately. Yeah. Okay, next up is where we're going to take an opportunity to recognize some outstanding volunteers in the organization. We're going to start off with a collective group, mainly for, we'll say, the non-engineering group. And they will come up first. I'm going to have Frank is going to read off the names. I will hand out the certificates. And then we're going to get a group photo because probably most of them are here. All right, Frank, come on up.
Thank you. All right, when I call your name, if you would come up here, and let's start with Paul Graveline for his contributions to the amateur news, or to the AMSAT Journal. Paul, K1YUB, thank you. Bring it. Paul, let's line up over here by the table here, okay? And then Joe Kornowski for editor-in-chief. Joe, are you here? You must be off running someplace, so we'll hold that one. Tom Schuessler for your contributions in helping keep the audio-visual running and the streaming for the... Oh, you've done a lot, believe me, okay? And then we're saving the best for last here. Nick Pugh, where are you, Nick? Must be getting ready. And Bob Twiggs, are you here? They must be getting our keynote speakers tonight. We'll give them their plaques a little bit later. We also want to recognize a couple of members who weren't able to make it to the conference, and that would be Mark Johns, K0JM, and Mitch Ehrenstoff, AD0HJ, for their contributions as well. Mark is the editor-in-chief for the AMSAT News Service, and Mitch is one of our rotating editors. Huh? Yeah, he left. He had to catch a plane back. We also want to recognize the members of our information technology team. That would be Matt Alberti, KM4 EXS, is the manager of the IT department. Joe Fitzgerald, KM1P. Trenton Ivey, K9ET, and Bob Nicolay, K1NLS. We want to thank them for their work. And as Bob mentioned earlier, Ray Hode, who had been WA5QGD, who had been the KEPS manager for many, many years. So let's thank those people for the contributions that they've made over the last year. Sure. Who's got a camera? Well, we've got him on video. Jerry's got a camera.
Thank you very much.
Okay, Jerry, if you want to come up here, we can recognize the engineering people who've done so much in the last year. Yeah. And, okay, so Kent Pertain. Kent, are you here? Come on up here. WA5VJB. Will Brozovic. Burns Fisher. Rich Gopstein. How did this one get in here? Zach Metzinger. Kip Moravik. Bill Reed. There's Bill. Andrew Robinson. Heimer Thor Sverrensen. And Chris Thompson. Chris Thompson, are you here? There he is back there. Thank you. Hang in there, guys. We're going to get your picture real quick.
Go big widescreen.
Yeah. And while they're doing that, I'll read the names of some of the people who were also recognized. We'll mail their certificates to them. That would be Cameron Castillo, Don Corrigan, Joe DeVerde, Doug Drouch, Jeffrey Gentile, Dan Habeker, Dave Hartram, Bruce Herrick, Tom Karnauskas, John Klingenhofer, Aaron Kumar, Leandra McClellan, Dave McCoy, Jim McCullers, Don Mills, Corey Minyard, Dwayne Moberg, Mike Moore, Addie Olteen, Hillard Page III, Ray Roberge, Eric Skoog, Carl Wick, and Thomas Wu. That's a big engineering staff we have, and a lot of people doing a lot of good work. Let's give them a round of applause, too. Mr. President, the podium is yours.
You know, it takes a lot of volunteers to keep this organization going, and there was probably about 4 months ago in one of my AMSAT Journal articles, the Apogee View, I mentioned that we had about 30 to 35 volunteers. Since that point in time, engineering alone has 35. So that is a great response. I thank you for that. There are still openings available. I'm looking for a AMSAT VP of Member Services or User Services. We can work on a job description that will fit your abilities and your desires. And anything that you can provide will take something off of my plate. So believe me, I appreciate it. We're definitely looking for, well, I say we're looking for all of them. We're looking for a VP, or not VP, a direct senior editor for the Getting Started Guide. In the past, they were made CubeSat or satellite specific, so it told you how to work AO91, taught you how to work AO92, etc. Of course, some of those satellites that are listed that they teach you how to do are no longer up there, so that needs to be updated. But I thought it would be better if we made them mode-specific instructions and then provide updates so that you know how to work a VU FM repeater satellite or a UV FM repeater satellite or a VU linear transponder or UV or APRS or 117 down the list. So we'll make a better product. We're just looking for somebody to take lead of a team. So if you're interested, please give me a call or how about send me an email. well, I'm going to give you my real email address, ke4al@yahoo.com. My call sign Yahoo. If you can't remember that, you could do ke4al@amsat.org or rbanksit@amsat.org. But I could really use your help. And with that, if there's no further questions, I will close this year's annual general meeting. But one more highlight. What do we got going on tonight? So at 6 o'clock, we're kicking off the party in the, was it afterburner? What is it called? Attitude adjustment. Yep. Some of us need some attitude adjustments. Although I think I'm going to, after as much as I spent at the auction last night, I will probably need less attitude adjusting. Anyway, so that's at 6 o'clock. That is going to be located in a room they call, what? Right around here. Yeah, look for the sign. That banner I have carried all over the United States, so luckily it's guiding us here. It's almost like a beacon, right? And then after that, we have the banquet. Tonight, our host, that is going to be right in here. Our guest speaker tonight is Bob Twiggs. I guess you could call him the father of CubeSats, since he's the one that came up with the idea. So we have the privilege of hearing him tonight, and I look forward to that. And then, of course, tomorrow morning at 8 o'clock, we have the AMSAT member breakfast, and that will be, I don't know where. Just look for the sign. Yes, sir. 7:30. Oh my God. I may be a little late. I can't get used to, you wake up, you know, I live in Alabama. It's just 2 states over, but at 7:30 when the sun is just starting to come up, that's a little weird for me. So 6:30 is more like it. Of course, now at home I get up at 6 or 7:30 anyway. So anyway, 7:30 tomorrow morning for the AMSAT member breakfast. Come last minute to get together before we head back home. So thank you very much for attending. I appreciate every one of you. All right? Where's the, oh, we didn't talk about that, did we? No. Okay. I'm going to call, well, we talked about this at the board meeting. We're going to Florida. More than likely, it'll be the Tampa area. We're going to keep a close eye on the hurricane season. Tampa's not too far from my house, about a 5-hour drive, so I'm happy with that. But it has been a while. We are always open for other locations and other years. So if you're interested in hosting a AMSAT symposium in your home state, then please let me know. I'd love to hear from you. I think somebody needs to push Frank Burns a little bit so that we can go up to New England. Not Frank Burns, Burns Fisher. Oh, yeah, right. Yeah. Who's Frank? Oh, Frank Burns is from MASH. Yeah, they're not even close. I was going to say, Burns could give Hot Lips Houlihan a run for her money. Okay, so with that, thank you very much, and we will see you tonight.